Okay. Yep.
Yep.
Okay. We're live. Okay. Good morning. This is Jim Heisey at the Collegiate Space Mining Competition here, and we're getting set up with Virginia Tech. Am I right?
Yep.
Yep.
Max
To
Lunar
run.
here.
And Max again here with me, ready to uh, give us the lowdown on their robot. And you know, I'm going to kill that. I don't need to hear myself twice. And so last time, Max, you're up here, we got introduced to the team. You got your robot started, but I think we had some technical difficulties. What were they? How'd you get them fixed?
So last night we've had, well, actually this whole week we've had a couple different electrical bugs that we've been trying to chase down. Most of the
Gremlins?
focus, yeah, gremlins. Most of our focus. Oh, we're starting.
Hey, we're moving. Okay. Well, go ahead and let
Yeah.
us know what you did.
So most of our focus has been, since we had two bots, the one that's going to Florida.
Yeah.
And so we've been going back through the electrical, trying to resolder all of the XT90 connectors.
Yeah.
Using some Anderson power poles now, which is what we used completely on the other one.
Yeah.
Where I think we're transitioning completely to that. Just making sure that our CAN network, or CAN bus, is sound. Everything's connected. We're not shorting the two wires.
Yeah.
Which we were a lot of times. It's fixed now though. It's fixed now though.
Yeah.
It's moving, as you could briefly see. We're no longer.
Yeah, I heard about one of the advisors really getting upset with his team because they had never made a wiring diagram, never made a wire harness design, and kept telling it, you have to do that.
Yep, we do have that. We do have that. It's
Yeah.
just, I don't know how well it was followed on the spot.
Oh,
The other one that we made sent to Florida, very, very nice. This one, also very good. So it's working.
yeah. Well, I should admit, we do have a wiring diagram, but we don't have a wire harness design on a robot.
Yeah.
We never have, and I hope someday we will, because it's really important to have a good wire harness design so you can make sure you don't have those problems like pulled wires and shorts and grounds and whatnot.
Yep.
Yeah. So, but okay, your robot seems to have disappeared.
Yeah, I think we didn't install any like cloaking technology.
Oh. Yeah.
But I think it's just the camera angle in
Yeah,
the
it's
corner.
just a camera angle, but it kind of
Um,
makes it feel like somebody beamed him up.
Yeah. The so the coloring yesterday I told you about.
Yeah.
I said it was anodized. I misspoke. It's actually powder coated. We partnered with a local
Powder
company in
coated.
Virginia.
Okay. Yeah.
And they were able to actually do the powder coating for free. And
Oh,
so it looks
nice.
very, very nice. In my opinion.
Oh,
Of
I
course.
think it looks nice even on camera. I'd like to get over there and take a closer look at it. And
Yeah, it was
yeah.
a actually very good process. And then the gear ratios I was talking about, I said they were 12 to 1.
Hmm.
I was off by about a factor of 10. It's about 100 to 1 on the drive.
Yeah.
And it's I think it's 50 to 1 on the dig linkage.
On the dig linkage.
Because
Okay.
that allows us to like hit the optimum of the torque curve on the motors.
Yeah. That sounds
We
great.
keep them in the low RPM zone so we get the higher torque on the brushless motors.
Yeah. Yeah, that's the big issues with electric drives is, of course, taking advantage of the motor's efficiency where it is efficient, because motors are efficient when they're running at about 72% of their max speed. That's
Yep.
where the peak efficiency point is usually at. Their peak power is always at 50% of their max speed.
Yep.
And so that's really the sweet range you want to run your motor between is
50 to
between like
72.
80% of max speed to 50% of max speed. Because if you get below that max speed point and operate too long there, and that's for whatever voltage you're running at, because you can run the motor slower with a voltage, but you want to make sure that the load that you're using on the motor doesn't get you below that max power point for whatever voltage the motor is running at, because then you'll overheat the motor.
Yep.
Yeah.
Yep. That makes sense.
Yeah. If you're running the motor at what's called a derating, that is running at a lower voltage than it's designed for, like say you have a 24 volt motor and you're running at 12 volts, your damage time usually is about 4 times longer than it would be at 24 volts. So it's something to keep in. These are all the little physics
That's cool.
that
That's
goes
cool to
along.
know.
Yeah,
Like, because undervolting, you'll not be reaching the capacity as much.
yeah. That's why the kids' Power Wheel Jeeps.
Yeah.
Yeah, they have a 24-volt motor in there running them.
Was
So for all you out there that want to modify a Power Wheel, I didn't tell you this. But they put a 6-volt battery in it
Yep.
because that way the motor's never going to burn out as the kid stands on the throttle switch at 6 volts. You know,
Yep,
you
yep.
might stall the motor, but the motor can sit there taking that and not burn itself up.
Exactly.
Yeah, because it's 4 times under its rating, and so its burnout time is much longer. But usually the battery pays the price, and then the battery goes out, and the parent goes to replace the battery and finds out the battery is more expensive than the whole vehicle itself. Then it winds up getting thrown away. Yep,
we're
here
back
we
on
go.
camera
We're
now.
back in camera now.
We seem to
Have lost
halted in the
connection or
twilight zone.
halted. Maybe we're thinking about what we're going to do with that rock.
yeah,
Yeah, I don't know.
I'm not entirely certain. People in the control room look like they're doing things,
They're
but
consulting. Maybe they're
they
gonna
look like
do
they're concerned a little bit.
Are they going to try to do do you guys have autonomous navigation capabilities on your robot?
So we designed it for autonomous navigation.
Uh-huh.
However, most of the sensors were used on the robot that we sent to
On
Florida.
Graham.
On Grim, or this is Grim. That's
Grim.
Reaper.
That's Reaper down
Yeah.
there. Okay.
And so this one does not have the sensor capabilities that we need to be able to do that right
Yeah.
now. But there are, otherwise it is designed for that capability. So we have the right processors in there. We have the right, like, some of the sensors are still wired up. So we have what are called
Yeah.
CAN coders, which are motor encoders that communicate over the CAN network integrated.
Okay.
I keep saying CAN network, CAN bus.
A little interesting point of information. When Iowa State was doing their run yesterday, we used no pit cameras. We hadn't used no cameras on the robot. The driver drove it strictly by the LiDAR unit on the front of the robot,
Wow.
which was why we were turning around, because we only have one LiDAR unit on it. So you had to rely on that to know where he was in relationship to the dump area. So, because normally you would just go straight in and straight back,
Yeah.
straight in, straight back. He was turning around, going in, turning around, dumping, then coming out, digging, then
That's impressive. That's
yeah,
impressive.
yeah,
We
driving it by LiDAR.
We had some, we were using, I think, some depth cameras, or at least we were exploring this idea, and generating a virtual environment that we
Mhm.
could view on our screen what the robot thought it was around it. So that
Okay, it
we
looks
could
like they reset your time
get
to
better
30 minutes. I
sitcom.
don't know what's going on here. Can
I'm
you
not
get
sure either.
Can you get some information from Mission Control as to what's going on? Reset the time? Okay.
That makes sense, because
Yeah.
if my team was heard that they needed to restart, they would have stopped moving the robot to stop the
Yeah.
power.
Yeah.
Um,
And we lost a camera here. So,
Gotcha. I remember reading about the electric Jeeps that you were talking about, the little kid cars. I
yeah.
remember reading about people that modify those and race them in Make magazine years ago.
Oh, gosh, yes. And then there's a group that strip them out and off-roaders, and I've watched movies of this, and it's just hilarious. They downhill race them.
Oh yeah?
Yeah, full-grown guys sitting on these little Jeeps, and they're just coasting them downhill at a cut rate speed, and parts go flying off, and they wipe out, and it's whoever can make it down to the bottom first, and
That's
it's just
fun.
hilarious. And
That's
then
fun.
there's the dads, and there's plenty of videos out there too, who will pull the 6-volt battery and put a 20-volt battery in,
Yeah.
24 volt, and then let the kid drive it. And
I feel like they're asking for injuries.
yeah, well, some of them put wheelie bars on it, and because they go quite fast, and the kid can't quite control it, and he'll wipe out. And usually they're on grass lawn, but sometimes they're in concrete. They get smoking pretty fast, and
That's fun.
yeah. University of Alaska Fairbanks,
Yeah.
their advisor requires their team to use 80% recycled materials on their robot.
Oh.
So they typically every year showed up with these Power Wheel toy motors and gearboxes on their robot.
Well, that's a good way to reuse it.
Oh yeah, that's recycling. And the interesting thing is, you know, with all this different motor drive issues we've seen with all the different robots here and that, I've never seen them burn up a motor or strip a drive on the
Hey,
robot.
if it works, it works.
It's very durable. We actually here for our when I teach freshman engineering graphics, I have a number of those gearboxes that I've taken apart, cleaned all the grease out of them, and I give one to each team. I break the class up into teams, and then they have to take it apart and reverse engineer it. So they
Oh
have to
yeah.
measure everything, CAD it up, and then I tell them, look, here's the project I want to do. I want to take those motors and I want to put them in this 1/5 scale tank that I'm going to build for my grandson so that he can go terrorize the chipmunks in his backyard. And the students rather enjoy that. I haven't built the tank yet. My grandson is now too big for the tank, so I'm going to have to go to 3rd scale. And
Well,
but I
that
do
skipped a
have two
full.
other grandsons, and so I can still get one built for one of them. And
I think tanks are normally crewed by 3 people, right?
yeah, yeah, if
Full
you're going to
scale,
do it
put all
right.
3 of them
If
in
I'm
one
going to
tank.
put all 3 of them in there, that's guaranteed recipe for true trouble in the neighborhood. So, uh, and they since moved from that house, so they don't have as many chipmunks over there.
Yeah.
But
So moving around in
yeah,
the arena, we've got Wyeth, Aiden, Brett, and Zach.
okay,
You can kind of see some of their name tags on,
yeah.
but their heads are all cut off by the camera, so you
By
can't
the
tell who's
camera,
who.
yeah. Well, we're interested in the robot, so
Yeah. Well, my team's watching at home, so
ah, very good. Yeah. Well, hello to folks at home, and I'm sure Dr. Shimpaw is watching too.
yep, probably.
Kevin, wish I could have been there in Florida to spend more time chatting, but we'll take care of that next year.
Yep.
Uh,
In the control room, we've got Emma, Tim, Cameron, and Swara.
okay.
Looks like we might be starting up in a minute.
Yeah.
I don't know. We'll see. It looks like Brett's looking at the. I think it's probably Brett looking at the electrical box, which is around the side there.
Mm-hmm.
Just making sure that, yeah, that's Brett. All of the electrical lights that need to be green are green, and all the ones that aren't are not.
And it looks like we're still.
Yeah,
Why is well, I won't bother them. They're trying to work that all out. We're still
yeah,
missing one camera.
yeah, that's fine. For now, I guess. Um, so you reminded me with the gears, actually. That's what it was. We
Yeah.
use, I think it's Rev Max planetary gears, and a
Okay.
couple
Yeah.
stacks of them,
Mm-hmm.
just to get because that's a pretty high gear ratio,
Yeah.
and they do it in very compact space.
Yeah. Rev
Uh,
Max, you said, is what you
yeah,
use.
I believe that's right.
Okay. I'll have
The
to
Rev
look
Max
those up.
planetary,
Okay.
or Rev Max planetary.
Yeah.
I remember we had, I think, one of them break last year, but I
Mm-hmm.
think that might have been at the same time that we sheared the shaft, so that's kind of to be expected a little bit.
Yeah.
Um, but this year, I don't think we've had any issues with them so far. They've been very solid, and we've built actually 3D printed cases for all of our motors, and uh, anything that could be exposed to dust is now enclosed.
Ah, very good.
So there's nothing getting into the electronics.
Yeah, we actually did a design in senior design this year, an R&D project for a club that we took Milwaukee fuel drills
Yeah.
and hacked them, literally, uh, so that we could take the motor, the gearbox out of that, pull the collet off of it, take all of that stuff off the nose of it, add a PS6 4-to-1 planetary gearbox on the nose of that so that you had the low and high speed drive of the drill, all metal gears, and then this PS6 gearbox has an 85 foot-pound output torque limit on it,
All right.
and put that on there to give us a very high reduction rate that works optimal for like your drive wheels and that. And if you want to run faster, then you switch the drill over to the high speed. Now you got something at double speed
That makes
than what
sense.
you had before, and put that in its own case, and the Milwaukee fueled brushless cordless drills, it turns out they have encoders in them already. So
No,
yeah, so you can it wires right up to a SparkMax controller.
that's
And
fantastic.
yeah, and you can program the thing through the SparkMax controller to run like a servo motor, so you can cog it,
Yep.
or you can run it for X number of revolutions, so
Like a stepper.
like a stepper, and you can run it by speed control, and
Huh.
it has a very good speed range on it. So we'll see, and it's just a question of can we get our hands on enough of the right type of SparkMax controllers, because they're always a limited commodity out there, thanks to First Robotics.
Are they used in First Robotics?
Yeah.
Gotcha. I've noticed that a lot of the popular components that we use here are popular because they were popular in
In First Robotics, and you get a lot of First Robotics alumni in these groups.
Yep,
running
you do.
competition. Yeah. Okay.
All right.
Yeah. Okay. So for those of you watching, wondering what's going on, we had some technical issues on our end with the cameras in the mission control room and in the lunar arena, and so we reset their setup time and resetting their competition time, and here is Grim going now on its competition run. So let's watch and see what they do, and Max, you can give us the lowdown as to what's going on here. As we
our
roll.
first strategy is to, number one, get the regolith simulant into the build area.
Yeah.
And just start on the berm. We're not going to use the dump to start. We just want to get some in there so that it scores. After we do that, we'll work ourselves up to more and more regolith in there using the dump system, which is a conveyor belt, and the dig system, which we actually removed the vibration motors because they were having some problems, and so we decided simpler is better in that case. So right now what we're doing is we're aligning the dig linkage by tapping on the ground, and that, because the ground is the ground, and so that ensures that we're at the bottom level of our arc before we start digging.
Okay.
Now you'll see we start digging. We will probably just scoop it up and move it into the berm area, or push it forwards. So you might be able to see on the front of it in some of the shots, probably not now. What we have are called hard stops, and they're a little bit adjustable as well, which sounds a little strange, but it's adjustable in one dimension and a hard stop in the other dimension, so that when we're pushing forwards with our dig bucket, it actually has something to rest behind it, not just the motors, so that we don't burn as much power.
Very good. Yeah, that's one of the things I talk about very heavily in my suspension design class, as you're designing vehicles, that you have to make sure that in all your linkages that you're designing, that you have a hard stop.
You can see it kind of right here. If you look at the bottom left image, right in front of the tracks, you kind of see two bright colored dots.
Yeah.
Those are two of the knobs on the hard stop.
Excellent. Because a lot of times in designing of vehicles, like for instance, what you won't find on a formula car is a hard stop on the suspension system. But you look at any standard sedan, you'll find both a hard stop for the suspension coming up and a hard stop for the suspension going down, so it can't be damaged.
Yeah.
And the same is true for the steering system. There's always a hard stop for the steering system, so you can't take it too far. And in formula race cars, the hard stop is inboard on the rack itself, because they're not planning on hitting anything, and if they do, they just want it to break anyway.
Yep.
But
makes sense.
But it's very important on the cars that our students design here that they have those hard stops for safety reasons.
Yeah.
Yeah. What they actually use for travel hard stop on the Indy cars, that has nothing to do with robotics here, but since we were talking about hard stops, they actually have hardened steel pads underneath the car, so the car bottoms out. It's the body that's why you see the sparks if you're watching a race.
That makes sense. That makes sense.
I can't imagine what that feels like for the tailbone of the driver that's driving the car, but
they've probably got like a pillow in there.
Yeah, I'm sure they got a cushion, because the other interesting thing is, because of the ground effects in that, I teach a vehicle dynamics class. I used to work at General Motors.
Oh yeah.
So you don't want to have a car that's going to ride at a suspension frequency ideally higher than 1.7 hertz, because past that it's going to start to feel harsh or uncomfortable. And you don't want it to be below 1 hertz, because you're going to have a lot of your passengers getting car sick.
Yeah, that makes sense.
Typical race cars will be springed at about 3 hertz, because it's not about comfort, it's about
No,
performance.
it's not.
But at 3 hertz, you start to feel uncomfortable, or you start to feel pain in your internal organs as they're being jostled around too much.
Huh.
Now here's where things get insane, because the Indy cars and the Formula cars, with the ground effects that they have on them to really pull the car down, a lot of those suspension systems are sprung at 5 hertz.
Oh wow.
Yeah, so it makes me wonder often, just how do those guys feel driving those cars? And I'm pretty sure they have their cockpits fairly well cushioned to try to take the edge off of that
That makes sense.
stiff suspension system. But sometimes you can watch on a race and you can see the Formula cars coming down a straightaway, and how they're vibrating. Just that they're thinking, there's no way that can be comfortable. And with how tight the helmets are in the cars for protection of the head, I don't see how they can see anything, if you're jostling so hard, the whole world's got to be shaking on you. But
Yeah. So what you see us doing here
Yeah.
in the video on the top right and bottom right is we're scooping the regolith into our dig mechanism, the dig bucket.
Yeah.
Then we're going to dump it into the internal
Yeah.
reservoir in the back. Reservoir?
Yeah.
That's for fluids. It's
Hopper?
a powder.
Yeah.
Hopper. There we go.
Yeah.
Thank you.
So
And the hopper will then move it into the dump zone when we back up. So that prevents that negates the need for alleviates the need for us to turn around, so we can just back
Now,
up.
is it your notice too? You have a very jagged tooth design at the
Yep.
edge of the bucket
Yep.
for good cutting.
So we did research into how different tooth designs affect, or like what different tooth designs are used for in industry. So like some wider teeth are used for like scooping clay, looser dirt. Some pointier teeth are for breaking up like harder stuff,
Yeah.
where you need that higher pressure. And so we decided to go with kind of a mix, but mostly pointy, but not spike-like.
Yeah.
And sort of a spaded bucket as well,
Yeah.
so that we could effectively dig into the packed regolith.
Okay. Well, we'll see how we do here with.
Yep. Yeah, this is how the dump's working perfectly. Fantastic.
Yeah.
All right. That went very well, I think.
Yeah. It did. Just have to figure out how to maximize the amount that you're collecting over a given unit of time.
Yep.
Now, what's your robot weigh again?
So our robot, I believe, weighs around 70 kilograms, 150 pounds. I'm not absolutely certain on that, but I'm pretty sure that's roughly was our target.
Yeah.
I believe the max is like 80, right?
Yeah. 80 kilograms is the max. It's 176 pounds.
Gotcha.
This is very reminiscent to West Virginia's design they had back in 2014.
Oh yeah.
Only their bucket didn't really have any tilt. It was just a fixed angle. They'd bring it down, run it forward, scrape a bunch of dirt up, bring it up, dump it in, and keep going that way. And then they had the live bottom on the hopper like you have here to unload.
Gotcha.
And it worked very well for them, because we competed against them in Alabama and University of New Hampshire, University of Hilo at Hawaii, and who was the other team that was there? There were 6 of us there. But at any rate, this was the one time that Alabama brought too many gremlins along with them, and the robot just kept dying, and they couldn't get anything collected. But West Virginia and Iowa State had a grand time just digging up lunar material, or actually it was Hawaiian material on Mauna Kea. And the fun thing was, we were finding a lot of rocks, usually about the size of a baked potato.
Yeah.
And both systems were just ignoring them. At one point, our robot dug up one, and it made the robot shudder, but then it wound up just kicking the rock down the way as it dug, like it was kicking a can down the street.
Yeah.
But in the end, as I've mentioned here before, though, after 40 minutes of competition runtime, we had dug up 1,000 pounds of material. And unfortunately for us, West Virginia dug up 1,040.
Oh, wow.
Yeah, it was,
That's close.
yeah,
That's
very
close.
close, very close.
I've seen a lot of the live bottoms this year.
Yeah,
I think that I've seen them do very well, so I think that they're probably going to stick around.
yeah,
Previously we had the whole dump bucket
yeah. The
rotate
dumping
with a linear
hopper, like a
actuator.
dump truck. Yep.
Yep. And I think that this way is just more efficient.
Efficient time-wise and
comes to-
stable.
And
That's
stable. Yeah, we
yeah,
aren't moving the entire center of gravity of the robot.
yeah,
We're just moving a small amount of, like, a fixed amount of dirt. We know exactly how much dirt gets dumped every single time.
yeah. Iowa State's club is for a long time had dumping hoppers with a bucket ladder attached on the front of the hopper, and the actuators controlled dig depth and pick the whole thing up to dump it. And in a lot of cases, the CG shift on the robot made it very unstable, and we had to rely on leaning against the receiver in order to make sure that the robot didn't tip over.
Oh,
Yeah, if we picked it up all the way to dump and we're not in any vicinity of the receiver, it would just tip right on over, and we
Ooh.
had no self-righting mechanism. So one year we did finally take care of that, and we got motors positioned so that we wouldn't have that issue with dumping. But then we ran into a whole bunch of other issues, so we never had a chance to really run the robot and test it that year. That was in 2015 with Hermes 2.5, we called it, and then Hermes 3 and 4. Well, that was ketchup and mustard, space ketchup
Gotcha.
and space mustard.
Of course.
And NASA, every year we go down there, asks you when you're going to bring ketchup and mustard back. So,
And I thought I saw you guys had a live dump system this year. Is that not, or live bottom this year?
yeah, we do have a live bottom in our hopper this year.
All right.
And we're having discussions about doing away with that and using a vibrator with a dumping hopper again. And yeah, I'm sitting here wondering what I should say of anything, or maybe make a suggestion that one of the big issues is the belt that we're using for our live bottom is thicker than it needs to be,
Uh,
and the drive system is more robust than it needs to be.
gotcha.
And so we could do some things to fix that.
Gotcha. It looks like now that we are going to try to push in as much as possible.
Yeah,
I don't know exactly what the reasoning is behind the shift. It could be that we lost power to the dump system. It could be that we just think that that's more time efficient. I wish we could hear what they're talking about in the control room right
yeah,
now.
that's that, but we can't do that.
We can't do that. That's correct. That's correct.
Yeah, but yes, and there is a very interesting talk point. Oh, nice little flick there.
Yeah.
And that comes down to efficiency in design, efficiency in systems, and reliability and durability as well. As we saw in New Mexico Tech's robot yesterday, that thing was very efficient, very durable, and driven by a madman. No, actually, I shouldn't say that. It turned out their driver operator, first of all, he grew up on a farm, and he spent a lot of time driving skid steers. And so you have a team individual here very familiar with the type of equipment, knew just exactly the ratios of geometry, because in designing a lot of these vehicles, I see this all the time. You notice how some of the wheeled vehicles, and they're using the skid steer type navigation, and they turn very easily, and other ones struggle to turn, and that has to do with the configuration of your wheels. Are they far apart, or are they close together? And of course, your trade-off is as you start bringing your wheels closer together, and you wind up with stability issues.
Yep.
Okay.
Yep. I've seen a lot of them rocking back and
Rocking
forth.
back and forth, especially UIUC's little robot,
Oh, yeah.
using the snowmobile or snowblower track drive with a great big happy face blade on it. Yeah,
Gotcha.
they were having a real issue. This is just my observations. Not saying this is right or wrong. It's just the way IC things, that the big issue there is that because the length of the robot is so short coupled, you get your bucket set to try to get a controlled scoop, and you move, and all of a sudden, because it's so short coupled, the thing either dives or it picks up, and now your scoop is nowhere where you wanted it to be. So unless you have something to control the bucket attitude with respect to the ground, like a depth indicator or something like that, so
Yep.
as you move, the bucket automatically changes its elevation. It becomes a real challenge, and they did struggle with that. And the other thing they struggled with is, even though the robot was as cute as it was, it didn't have enough weight to have the
Yeah,
thrust.
that's what
They
I was.
tried to push the
That's what I
rock,
was thinking
and
when
they
I
were
saw it
struggling with
myself.
the rock, and the rock won. And
I didn't see their run, but I did see the bot, and I was thinking that that would be a potential issue.
yeah,
When we build our robot, it's
yeah,
100% built in CAD software before we put it into physical parts.
yeah,
And so we actually go in and we look at the regular simulant, and we
hmm,
make volumes in the computer design to figure out exactly, like, in what poses where the center of gravity is,
yeah.
to make sure that we don't actually tip over when we're
Hmm.
doing things. So
Well,
last year, I think last year, if we were up on a hill,
yeah,
it may have caused, like, there could have been a way where we tipped over, but I don't think that we ever ran into that.
yeah.
Um, I don't think we've ran into any sort of tipping this year either. Um, just going back to the reasoning behind why we had the hopper, like why we don't just
Oh, yeah,
dump it most of the time, is because the hopper allows us to increase our weight during the match. If we
yeah.
increase the weight before the match, that means lower points, because the weight is a penalty.
Right.
But if we increase the weight during the match, that allows us to dig deeper and
Yeah,
get more regolith per cycle than otherwise would be possible.
yeah. Well, that bucket seems to have a very good range of rotation capability to it.
Yes, it does. It does.
But they must be doing visual operation of it, because it looks like from time to time he gets the bucket going too far.
Yeah,
Uh,
so part of that is also the encoders, the bucket, and the linkage has two rotating joints.
okay.
The one for the bucket and the one where it attaches to the body.
Hmm.
The bucket one has encoders on it, or they both have encoders on it. The ones attached to the body have been turned off because they were not secured exactly
Oh,
right. We were supposed to bring Loctite with us, and we did not.
oh, well, we could have, we,
It was around when we figured that out, because we were chasing down electrical gremlins for a while before we even
sure.
realized that that was an issue.
Yeah.
And it was about, I think, 3 a.m.
Oh dear. Yeah. Well,
But
we could have loaned you some
it
Loctite if you
works
asked.
though. It works
Yeah,
though.
it's
It
working.
just has a little bit less
Yeah.
exact control
Hmm.
with the vertical thing. So it's just what we needed to do. It just needed to happen.
Let's see. There's enough power here in the motors to
Yeah.
pick
So
that
you
up
probably
nicely.
saw that just now.
Yeah.
The bucket did press back against that hard stop I was telling about
Yeah.
previously.
Yeah, but he got a very good bite of material in
Yep.
that too. So now we can just get all that. And I really like that it has that rotation to it, that he can get that
Yep.
full 50 degrees plus down angle.
It's so we can dump to the front and dump into the internal
Yeah.
reservoir.
Yeah, that's what's impressive about this robot is that range of motion that bucket has.
It
Uh,
gives us very much needed flexibility.
yeah,
So, like, I mean, ideally, we back up to the berm, dig forwards, dump into ourselves, and back up
yeah,
to do another round of digging. And while we're backing up, the dump system puts it into the berm volume.
yeah,
So then it's very just a continuous thing. However, this gives us the flexibility to be able to do different things depending on what we see
yeah,
in the control room as our optimal strategy.
yeah. Hey, if any of my students, team members, and Cardinal Space Mining are listening in the pit area, what I'd like you to do is get pictures of each team with their robots in the pit area before they all run out of here at the end of the day, because I'd really like to have that for historical purposes. All the smiling faces with all the wonderful robot designs that we've seen here over the last 3 days before they all get out of here, because there's a lot of fun, very creative, very interesting, very inspiring designs here, and I'd like to get that captured if we could. So somebody please get your camera with a phone in it out and take some pictures, and otherwise known as a cell phone. Uh, I mean, when you stop and think of what people use their phones for these days, it's not so much for calling as it is texting, doing online search, taking pictures, everything but a standard telephone. It's amazing how technology has changed everything for us. And we get to see that here too in the design of these robots, how things have progressed significantly from the initial designs to what we have now. And it's congregating more and more. And we had a discussion on this last year after the NASA competition was over. Eric Reiner's had a number of the advisors who had been in the competition for many years, and we were talking about the evolution of the competition with Rob Mueller, and as to what sort of designs teams seem to be gravitating to in order to accomplish things, and what seems to be the most prevalent. And of course, bucket ladders was a big part of the discussion, but we're still seeing a surprising number of buckets. Not a lot of bucket drums, and this is interesting because NASA has chose, for their Razor, a bucket drum system.
The Razor is 2 bucket drums, right?
Two bucket drums. Well, it's technically actually 4 bucket drums, but they're because there's a drive motor in the center of it.
Oh yeah. Oh yeah, I remember this now.
Yeah, and on a boom, and that configuration allows them to use those bucket drum, or the drum bucket. Also as a drive, third and fourth drive system for their 2 drive axles that they have, or actually 4 drive wheels, so they have the equivalent 8 drive wheels on the robot to get over obstacles in that, so it can climb its way out of things. And I do think too they put some self-riding elements on it too, so if it happens to tip over,
Yep.
They can get upright again.
Do you know why your team didn't choose the bucket drum?
Efficiency.
Interesting.
Yeah, but a different type of efficiency, because and we got criticized on this one year by one of the CAT judges. It was an excellent question. I don't want to be getting down on the CAT judge, but what was so funny about the situation, our club member that was doing the presentation, we had 2 guys doing the presentation. One of them was very good at answering questions, and the other one was very good at presenting, but you ask him a question, he could never give you a straight answer. His thought process would go around in circles. And but at this one moment, he had a moment of total clarity. And the CAT judge says, well, it's obvious you've designed your robot to maximize points in the competition. And he looked right at this judge and he said, hey, if you want a different result, change the incentives. I about fell out of my chair. I couldn't believe he just said that to the judge. It was a perfect answer. It was not disrespectful. It was just very matter-of-fact point. And so that's the key thing here. And that's the big struggle in setting up a collegiate design competition. If you're trying to actually, do something to further a moon mission and understand what the true requirements of the moon mission would be, and yet at the same time not make it too complex for the students to engineer, make it feasible for them to do, and yet at the same time accomplish the sort of goals you want to have toward getting technical data toward what you're going to do with your moon mission. That's a tall order. It's quite complex, but I think they've done a good job of it. It looks like Grim here is starting to build a pretty good mound, just using its bucket.
It's not entirely in the box, which I think is what they're trying to do right now, is to shore it up and move as much of it as they can into the box. I'm guessing that would be, that is almost definitely what they're trying to do right now.
Yeah.
There's still 7 minutes left, so I think that
they got enough time to do some
got
adjusting.
this in the bag. I'm very, very pleased with how it's going so far. It looks like our robot's moving around, doing what it needs to do.
Yeah, and
I think we're using our drive as little as possible, because that's one of the places. So the drive is.
Mm-hmm.
I don't actually know if it's. I know it's Krakens on the dig system.
Yeah.
I think it might be the larger Neos on the drive system.
Okay.
Um, I'm
They've
not.
had some reliability issues.
I don't think so.
Okay.
I don't think so. I think we've been pretty happy with those.
Yeah.
I believe the select. Yeah.
Because
I think I said that they were Krakens yesterday. I think I was
Okay.
corrected by someone.
yeah, we've been running Falcon 500s. We went out and bought a Kraken. I gave the club my reservations on jumping to Krakens because now you're getting up to a 700 watt motor, and we've run motors as high as 4,000 watts on a robot in the past, but they were very high RPM, high voltage. They were RC boat racing motors.
Gotcha.
And yeah, and they would burn up in a heartbeat, but we weren't running them for that long, and we weren't getting and that's what we had on our digger. It came back to haunt us because we'd get into the mining area and we'd turn on our digger, and they would plunge the bucket ladder down, and in both of our runs that year, this was with Space Ketchup and Space Mustard, and we'd hit a rock, and it had so much power behind it that it would take the robot and kick it about a foot off the ground and about 2 feet backwards, and we'd wind up back in the obstacle area.
Wow.
Digging in the obstacle area, and the rules that time said you were not allowed to dig in the obstacle area. Digging in the obstacle area was immediate disqualification for the mining award.
Oh wow.
Yeah, and so on both runs we disqualified ourselves. Now we still got the points for digging the regolith, and that could go toward the overall points that we did, but we could not get the mining award as a result. So that was a little disappointing, but it for me it answered the question: can you have too much power? And the answer is absolutely.
Yep.
Yeah,
Yep, you
because
definitely can.
before that we were running about let's see, about 300 watts. On our
Gotcha.
digger. So we went from 300 watts to 4,000 watts on our digger.
Yep. So
Yeah.
what it looks like is that
Yeah.
we've decided to call the run, which means
Yeah.
that we folded our dig bucket back over into the transportation configuration, and
Okay.
so in a couple minutes, I think they're going to send back in the bunny suit team to take the robot out.
Okay.
We considered purchasing bunny ears, but the ceiling was a little low, so
Yeah.
maybe next year.
Maybe next year. Yeah, we have had over the years some fun with some of the teams. I saw at NASA this year, some of them had capes on as
Oh,
they
yeah?
were, yeah.
In the arena?
In the arena with the teams that were bringing the robots in. Yeah,
Huh.
they had capes on. I don't know what prompted that.
I guess you can like identify the team based
Yeah,
rather than just like the Tyvek suit.
yeah, the Tyvek suit. You know, in the past they've often used a permanent marker and put funny phrases on the
Yep.
back and
Yep.
nicknames for their team members. We've done it too, and so and the whole objective here, while at the same time completing the mission, is have fun doing it.
Yep.
So, well, I have to say, I really, it's a pretty robot. It's obviously very nicely constructed. But like everything else, it is technology, and there's always little things to be perfected, to optimize, to increase reliability, durability. And that's what engineering is all about. And that becomes our biggest challenges.
Yep.
So, becoming familiar with how the robot operate and what sort of strategy should you use in order to optimize its strong points. And I would say your team has good potential, but you got some things to sort out. And
Yep.
A little more runtime on Grim and Reaper, and maybe you'll do much stronger next year. And we hope to see everybody down at the Kennedy Space Center next year.
Hopefully.
Yeah.
We'll see what happens. I
Yeah.
think we were actually considering possibly doing a different competition. I'm not sure. Either way
Yeah.
it goes, I think that we're going to put a lot more focus onto our wiring harnesses
Yeah.
and electrical systems next year. We've already made some decisions to start using Anderson power poles instead
Yeah.
of XT90s completely because you can link them, you can get different colors, and they crimp instead of being soldered, and so
Ah,
you don't run into any issues with the quality of the solder job. It's just crimped and done.
yeah,
When it comes uncrimped, you just do it again.
yep.
So that's the run.
Okay.
After they get that out, I'm gonna go meet the controls team. They're gonna be coming out of a door that I can almost see
Yeah.
from here.
Well,
Um,
if we can get a chance, why don't you get a report for us, or have one of the control team guys come over and the driving crew and give us a review as to what happened and their impressions of the run. But it looks like you got a very nice mound there of material.
Yeah.
And so congratulations on a successful run, really. So
Right.
thank you for spending time here. And I
you.
loved the conversation we had.
Did you say you wanted to talk to my?
Yeah, I would want to talk to one of them here.
Hey guys, you want to come over here? I'm gonna go grab my backpack real quick. Y'all left it in the control room. I'll be right back.
Yeah, I'd like to get the lowdown as to what was discussed. Oh yeah, come here, sit down. We want your audience to know what's and you are
My name's Cameron.
Cameron, okay, and the rest of you come back around here too. You get in the camera, yeah. So, all right, so that was a
Something.
very interesting, very educational run. It really was. It really was. I could only imagine what the conversations were in the control room. So what were they?
We were mostly questioning how effective or whether our volume would be positive or negative. We are at 0.011 meters cubed, by the way.
Oh,
Way more than we would have expected given that.
yeah.
Yeah, we lost a drive motor right near the berm zone, so we couldn't really translate. We could only rotate.
Oh,
So that led to us just trying to flick regolith into the berm zone.
okay.
And what we've dubbed as like the sushi strategy, because like at a hibachi restaurant.
Sushi, yeah.
Yeah. So
I love all these terms we come up with. We're under the stress of the moment doing the competition, and then something happens, and it'll become dialogue for years to come in the club. Remember when we did the sushi operation?
yes, that'll be a thing for a very long time, I'm sure.
Yeah, sure. Well, it'll stick with me too for a long time now. So thank you. It'll be something we'll enjoy and remember. So you lost a drive motor on one of the tracks.
Yes.
Yeah. We had that happen too. You notice one time we were going around in circles, and on our first run, I call it the Billy Preston maneuver now, where you just go around in circles, building up a berm all around you because you can't get your bucket ladder up and down, and you get enough pile, and then you go pick up this, you can pick up that, you can pick up that, and then go dump it, and you got a pile. The little strategies we use. So what were some other technical challenges you ran into with the robot?
So we built two robots. We went to NASA and
Yeah, that's
here
Max
this year.
told me. You got
Yeah.
Grim and Reaper, and this one's Grim.
Yeah, Grim.
And
So
I really like the finish and the fit on this robot. Very nice job of constructing it, by the way. It's a very good looking robot.
thank you. Basically, our biggest technical challenge was our electrical integration.
Yeah.
So we didn't plan our wire routing as effectively as we should have, especially around the dig linkage area. That's been a problem for a very long time.
Yeah.
But in this case, it happened to be a drive motor. But
Yeah.
we weren't necessarily protecting our wires and cabling as much as we really should have.
Okay.
So that's one thing we're definitely going to do next year is
Lesson
make
learned,
sure
yeah.
we absolutely have all of our wires protected. That's still
Yeah.
a lot better than 2 years ago, where our final robot electrical system was mostly a breadboard.
Okay.
Yes.
Yeah, and I know what that is. For an audience, a breadboard is you got this little board with holes in it. You stick all your wires in it. That's meant for exploration on a electrical circuit. It's not meant to be a running system on a robot.
Yeah. No, somehow zero electrical failures on that at UCF.
Really?
It was amazing. We only used it for signals for
Yeah.
like sending PWM signals, but we were still shocked that lasted.
I'm surprised too.
Yes.
Yeah, but that's very interesting. So, what's your plans from here then? You come to CoSMiC. You've made a couple runs. You had a successful second run. even in spite of all the technical challenges. What's your plan from here?
So frankly, we're really considering changing competitions for future years
Yeah,
because of, well, you've been there.
yeah.
We were looking at the University Rover Challenge as
Okay.
something to transition to. So that's
Hmm.
probably going to be the next step for our club. We have to have a talk about with all of our team members, but roughly I've gotten to speak to half between Florida and here,
Yeah.
and almost everyone agrees that unless you guys are hosting again, there's
Okay, we'll keep that in mind.
unless you guys are hosting it, which seems like a huge logistical challenge.
Our intent was to make this competition a one-time thing so that all of us who didn't get into the Florida competition at least had something to do with the robots and learn, because that's the big thing about this is learning. But I've been getting a lot of requests from teams and from other people, and NASA and Caterpillar included. Would we make this a regional competition? And would we want to do it again? And I told them no, because I want my club to compete. I don't want them to be a club that runs a competition. But and I'm putting this out for any of our ISU students that might be watching. If there is an event club out there that wants to have the experience of running an event like this, we would be very happy to work with you to, if we want to do an event like this again next year, to have that. And nothing would make me happier than to make Iowa State one of the space mining centers in the world that teams could come to and have a good time. As you've experienced, we run things a little differently here than at NASA. It's more about having the chance to really learn and have successful runs, and to have some fun at the same time. And I certainly hope you had a chance to eat very well at some of the very excellent restaurants that we have here in town. So
Yeah. We've been
What?
cooking at our Airbnb. We'll have
Oh,
we'll have to stop by some of these restaurants.
oh yeah, you got to hit Hickory Park before you leave town. That's down on South Duff. Or another one of our staples is Aunt Maud's or Sweet Caroline's or the Cafe or downtown Cornbread. Sweet Caroline's downtown too, along with Aunt Maud's. We have a lot of fine restaurants around here. The Cafe is out north of town. There's a sweet little sandwich shop over here too, if you get hungry. They have the messiest sandwiches you ever eat, but they're worth it. It's called West Side Deli. Yeah, so you have to try some of those out. But I gotta understand, you're going on a college student budget. You gotta save money, and so you do an Airbnb and cook there, because that's what we do too.
Yeah.
And then we have a food budget, and it's all part of making your dollars go farther on this. One other question I want to ask, just out of curiosity, robot budget. How much did it cost you to build this robot this year?
Okay, so our overall budget for the two competitions was 42,000.
Okay.
That includes travel and expenses and like renting our vans and stuff.
Yeah.
I believe it's around 14,000 per robot.
Per robot? Okay.
Yeah. Some of our cost items probably got intermingled between the two robots, but it's
Sure.
about 14,000.
Well, when you buy in bulk, you do save money, right?
Yeah. And we were buying a lot.
But that does sound pretty normal, because a lot of times in our robot building budgets, we're somewhere between $5,000 and $15,000, unless you build two robots, and then it gets up to 17,000. That was our budget with Space Ketchup, and Space Mustard. If the motors that we use for the tracks, if we would have had to pay for those, they were given to us by a company up in Minnesota, our budget would have probably increased by $20,000, because they were Air Force missile motors.
Oh.
$4,500 a pop. And, they ran great, but they run at a much higher voltage and very high RPM, which made a real challenge for putting the Vexpro gearbox on it. And I'll spare us all the story on that. It's too long. But we decided after that year, as nice as the motors were, if we burn one of those out, we can't afford to buy another one to replace it. So we went to something else after that. But we still have them. But anywho, well, hey, congratulations on a run. Thank you for being here as a part of our competition this week. It's been great doing this and having you here, and look forward to seeing you at the banquet tonight. And try to get your motors fix because we're going to do a robot tug of war
Oh,
this afternoon.
yeah, we're interested in the tug of war.
Yeah. Yeah. Okay. Very good. Well, thank you.
Yeah, thank you for hosting
and
such a wonderful
yes,
competition.
for having us.
yes, you're welcome. And congratulations on a successful run.
Yeah.
Okay. Max, thank you for your time on camera as well.
Thank you for having me.
Take care. Okay, that was the team from Virginia Tech and the robot Grim, which as you can well imagine, I enjoyed watching run and really like the fit and finish on the robot. But unfortunately, it's not just fit and finish, it's reliability, durability, and performance that all have to come together as well. And as I teach my students in senior design, I have this little diagram I call it the milk stool. The milk stool has 3 legs. Those 3 legs have to be of equal length in order for the milk stool to sit square. And those 3 legs, if it's your design project, it has to be cost and quality and safety that they have. And we just kind of discussed all 3 of those items here. And then the quality itself is another milk stool, and that milk stool, the 3 legs there, that is definition of quality. We all have an idea of what quality is, but how do you define it as an engineer so you can put it into specifications? And there it has to be performance, durability, and reliability. We just saw that firsthand here in this run, how the durability and reliability issues came up short, and now the team has some goals to work on as to how they're going to proceed with their next year's robot to address those issues. So always things to be learned here in engineering. It's not an easy profession. It's not for the faint-hearted, and it is something that we have to get accustomed to disappointment, and we can't rest or sit there and get down on it. We have to just keep moving forward, fix the problem, move on to the next thing that we're going to do. So next up, I believe, is the San Diego State. Yeah, I'm not going to mess this up this time. University Team Creed and their robot, and we're looking forward to watching them run. So come on in and remind me your name again. Colin again. Yes, thank you, Colin. Round three. Oh. So, but
right.
this would be official run 2, or is this practice?
Official run 2.
Official run 2.
Yeah.
Okay, very good. So tell me, between the last run and this run, did you get any sleep?
Couple hours here and
Couple
there.
hours here and
But-
there. Yeah.
This whole week has kind of felt like one really long day.
Yeah.
But yeah, it's super exciting to be here.
Great. Yep, it's on. Okay, we're good. Thank you. Thanks, Tim. So asking too on this, what were some of the major issues you were working through?
Yeah, so I guess so for our first round, we had to end early at about 12 minutes.
Yeah.
You remember that, right?
I do
Okay.
remember that. Yeah.
So that wasn't us just flexing.
No.
But so what happened was our conveyor belt on our excavation system slipped off of our pulleys.
Okay.
And we suspect that that's because a lot of the regolith simulant, in this case the limestone, got stuck into the bottom pulley on the excavation
Oh,
system.
yeah.
And so all that buildup caused it to not catch on the teeth and then just walk off.
Yeah.
So what we did was we added some U-channel aluminum tubes.
Okay.
Maybe a little closer.
Yeah, you got to be close to the mic for it to pick it up well.
Sure. Yeah.
Okay.
So we added some U-channel to that side that it was slipping off of.
Uh-huh.
So hopefully that will act as kind of like a guardrail to keep it on the pulley.
It's reminiscent of what's one of the things we had chased in 2011. We were having material load up in one of our bucket ladders. We were using a flat belt pulley type arrangement for driving those.
Mm-hmm.
And yeah, we had to wind up putting scrapers in there to try to keep material and angle it so it would take it to the outside
Right.
and not jam the pulley up.
Right.
Yeah.
Absolutely. So
Okay.
that's one thing we'll try to keep in mind for next year's team,
Yeah.
for sure.
Well, we wound up going to, have you heard of star pulleys?
Star pulleys.
You have to look that up.
I'll have to look that up.
Yeah, when you're doing a flat belt, if you've got a problem with debris, you don't actually use a round roller. You use something that is like 6 flutes.
Oh, okay. So it's
And-
kind of staggered.
It's staggered, and the belt wraps around it, rides on it, but it has these open areas so that debris can collect in there, not get packed in, and it flows to the outside. And
Gotcha.
falls out.
Ah, okay.
Yeah, and it works out very well. So look it up for the flat belt conveyor, star pulleys.
Star pulleys.
Yeah.
Okay. Keep that in mind.
Yeah, this is a fun thing about this design is the competition is as you're designing things and you get an idea and then you go to build it and it doesn't work quite right. Well, then you can go do some research, find out, okay, how did somebody else solve this problem? Because surely they ran into it too and they have a
Right.
solution. So then now you just have to go out and find that solution,
Right.
and it becomes another arrow in your quiver as engineering tools
Right.
that you use.
Absolutely.
Yeah, so looks like we're
Starting
getting
to set
close
up.
to ready to go.
Mhm.
Well, that's just, he's making the chalk marks.
Oh, okay.
Got myself a little moisture in the old voice box. Some of my students said, "Hi, Mr. Heisey, how are you going to hold up? You're going to be talking for 3 days straight." And I said, "Well, I do a lot of lecturing every day too. So I think I'll be okay."
Yeah. Just doubling up a little bit.
Yeah, double up on the coffee.
Yeah.
But I am so far behind on my summer class and lectures. I am going to spend it all day tomorrow
Oh, man.
recording stuff and getting it up.
So even more talking then.
Yeah.
Oh, man.
Well, it's the penance I pay for the privilege of making my students suffer by having to do all the work that I assign them. So,
Yeah. There you go.
yeah, it's like I said, one of my favorite Civil War generals was quoted as saying, "Suffering builds character." And I believe highly in developing the character of my students.
Yeah.
Yeah,
Absolutely.
there you go.
Discipline.
Yeah, yeah. I could use a little bit of that myself some days.
Don't we all?
Yeah. Yes, we do.
Mhm.
So great. So,
So one of the other issues that we had this morning, actually,
Yeah.
super unexpected, probably one of the worst case scenarios, but
uh-oh.
one of on our excavation system,
Yeah.
it slides on a linear rail. So
Yeah,
we have 2 Kraken X60 motors, one on each side.
yeah.
One of those motors had a failure, mechanical
Uh-oh.
failure, so we had to quickly swap that out in like 15 minutes.
Oh,
So
geez.
a little bit of a stressful morning for sure, but
Yes,
Mhm.
in 2013, no, it was 2014, we munched a gearbox 20 minutes before we were supposed to be at tech inspection
oh my
at
gosh,
Florida for that. We had to do a complete gearbox swap out on a track drive
oh my gosh,
20 minutes before the
20 minutes.
check-in time. Yeah, we got it done, and then we
Yeah.
had a very good run.
yeah,
And but boy, talk about pressure.
Yeah, oh, yeah, I bet.
Yeah,
Yeah.
these are the things we go through in these competitions. They just
Yeah.
that's probably why I don't have much hair left in. The stress that we go through with getting everything ready to go. And even though I'm not the guy designing and building the robots,
Yeah.
you students are.
Mhm.
My heart's there with you guys, and
Yeah.
and there's not much I can do. I could bark commands and offer advice, but are you really going to listen to me? I'm just an old guy. What does he know? But no, actually, the team usually do great. But it's one of those cases where you just feel helpless. And
Yeah.
your heart goes out to the teams. My heart goes out to all the teams here with everything they have to do because, as you well know, we've been doing it for a long time.
Mhm.
But for me, it's a very special thing because I think it's an excellent training ground
Yeah.
for new engineering students.
Right.
I mean,
Yeah. Quick troubleshooting.
troubleshooting,
Diagnostics. and-
diagnostics,
all that.
getting to fully understand, well, that wasn't a very good idea. How are we
Mhm.
going to make it better?
Right.
And that's the key thing on engineers. And this is where when I talk with business managers that say, well, I'll just go hire a young engineer. They're cheaper. And I'm sitting there thinking, well, that's nice. I want you to hire young engineers, but you got to understand that if you're just going to get rid of your old engineers because they're expensive, you're getting rid of a lot of technical knowledge at the
Right.
same time. And just because they have a 4-year degree and they're an engineer, it doesn't mean that they're going to magically walk on water every time.
Absolutely. Yeah.
As you well know, I mean, there's so many things to be learned in this field.
Yeah.
So many things to be experienced. And our challenge as educators is to give you as much of that experience as possible.
Yeah.
And so that you can develop a thought pattern that helps you to really understand that there's a lot of information out there and you got to go find it. And you don't want to just do things alone. You want to collaborate with everybody around you and find out what they know.
Right.
And be a sponge and soak that all in and get help from others, because there's all sorts of solutions out there. And it's just a matter of finding the right one.
Yeah.
And this is where I say too, analysis goes a long ways, because if you can get it defined by numbers exactly what you need to have, then you know exactly what you have to pick up at the Menards or Home Depot or Lowe's or Ace Hardware or whatever it is
Right.
that you're going to put in there, or the next robot store. So
Yeah.
okay, so Creed is coming in. Again, very nice design for the most part. Very, very stable running robot on the regolith.
Yeah.
And you really haven't had any wheel drive issues on this robot, have you? It's just all been in the loader.
Yeah. Yeah.
Yeah.
Basically, we haven't gotten trapped yet.
Yeah.
Got to knock on some wood. somewhere.
Right here.
Okay.
It's a wood counter with a linoleum cover over it. So that's as close as we can get to wood, unless you want to knock on the top of my head.
Oh man.
Yeah, no, it's been a very reliably driving robot, and just as we've experienced here, just issues with the digging conveyor and with the unload conveyor, and now we discussed a little bit some potential solutions that could help there.
Right.
You should take a look at what we've done on our conveyor as well for doing that, because we're not using flat pulleys on there.
Is it the star pulleys that you?
We don't
mentioned?
even are using star pulleys. We're using very open multiple pulleys on a shaft.
Oh,
They're spoke.
interesting.
So
Okay.
so you've got a narrow band, because the belt it doesn't have to have a pulley all the way across it. If you have strategic locations of support for it, it'll hold that. And then if your pulley has open spokes for the material to go, it tends to clear the material out.
Interesting.
Yeah. So and then the drive on it, then we have cogs on the backside of the belt that work with the scoops, and we have a pair of scroll cages in there.
Okay.
And again, they're designed to reject material.
Gotcha.
And so you have plenty of room for the material to go. That is not what we have on our tracks, and we're using a chain sprocket for driving the tracks, and then we have the tracks in a very enclosed, and that's actually turned out to be a bit of a problem for us. We're getting material trapped in there. It jams the track up, and then it's shearing off a key and a round shaft. So already our team is saying next year, no more keyways.
Yeah.
It's all going to be hex drive shafts.
Gotcha. Yeah.
Are you running hex drive
We
shafts?
are running hex drive shafts.
It's gotten to be a very commonplace thing in these robots, is using the hex shafts.
More surface area.
More surface area to drive with, and it seems to work better.
Right.
Not necessarily ideal for high-speed machinery, but for what we're doing here, the RPMs that we run, it's just fine. And it carries a lot of torque. So we got about 7 minutes and 45 seconds to go on setup time.
Oh.
One of the things we've done in this competition is this doesn't happen at NASA, because they have to get all their teams through, and so they have very tight rules because they have so many teams to do. But if they're ready to go early, we can curtail the setup time and get right to the competition run time. Or if we have difficulties on our end, we'll reset the setup time and give the team an extra chance to get set up. We do have it set up that if the team winds up during the competition run 5 minutes of no contact connectivity, no activity, then we'll kill the run and get on to the next team. But we give every team the maximum chance possible to have a successful run. And I'm looking forward to seeing what you guys can do here. I would assume that you're not going to try to dig down to the bottom of my pit like the other team did.
No, so that was I think that could have been one of the mistakes we made, which led to the buildup on the pulley.
Yeah.
We found that we really only had that buildup issue when we tried to dig too far down.
Yeah.
So we're gonna try to be a bit more of a surface skimmer for this round.
That actually is a very good strategy. Kind of dig to the depth of your bucket and then translate, move along the surface so that, because you're trying to collect volume
Right.
and you have what's called a swept area where you come down with your bucket, but see, that's area, it's not volume. So how do you get volume? You move. And that's one of the equations on the back of our t-shirts for the club.
Oh, really?
Yeah, we have can you dig it, and we have all these equations, and one of them is A x dot.
AX dot.
A x dot.
Okay. So
And that's your m dot equals A x dot and times density on there.
oh, okay.
Yeah.
Yeah.
Oh,
Ah,
yeah.
there you go.
Yeah, you gotta move.
Bringing in words is a,
Yeah.
a little bit, but yeah, I'm like writing that in my head right now.
Yeah.
Yeah.
I have one year, Alabama came up to us after we had a very good run. We had beaten them that year in mining. He said, "What's the secret to being a successful miner?" And I said, "You want me to tell you what's going to make us win?" You're seriously asking me that question? Well, yeah. And I said, "Go read the back of our shirts."
Oh, there you
Pretty
go.
audacious question from one of their team members. It was meant in all honesty. I mean, he was pretty frustrated. They had a lot of frustration with their robot, and we had seemed to be cruising along pretty good. But we've had frustrating years too. I mean, all of us have, and varying levels of success. And as we've seen here, we're not the team to beat this year here. It's you and New Mexico Tech and what Virginia Tech had a good run here, and of course YSU with their little robot in the running as well. It's going to try to get the points pulled up here and kind of see where we're at on everything. It's been really interesting. But it's more than just the amount of material collected. It's the autonomy, it's the efficiency, it's the dust mitigation, and of course weight penalties. So it'll be interesting to see what we do here. One of the big things that we measure is, of course, the total power that was used by the robot when it gets done with its run, and we compare that to the amount of regolith that's been deposited in the berm area. So one of the major calculations for points is kilograms collected per watt hour, and that's an important one too. And the interesting thing is that is really one of the factors that is most critical to NASA with what they're doing, along with the ability of the robot. How many hours of operation can they run that robot until it's no longer usable?
Right.
Mission life, as I think they often call it.
Mm-hmm.
It's like Voyager 1 and 2 that are out there.
Right.
They're now billions of miles away, but they're still sending back data. I was just watching a show on this the other day, but they figure that Voyager 1 nuclear power plant is probably only going to last about another 10 years, and that'll be it. No more signals coming back from Voyager.
Oh,
It'll
wow.
just be out there floating away with its gold record and a map of the solar system and where we are. And hopefully, if you're a Star Trek fan, it doesn't get found by the Borg
Right.
and we become assimilated. So,
Yeah.
but
Wouldn't be good.
yeah,
Wouldn't be
not be good, not be good.
Mm-mm.
Okay, so we got 2 minutes and 30 seconds left to set up time. Looking forward to watching Creed run, see how much material they can get collected. Again, the previous team, New Mexico Tech, they dug a big hole, which got me to use one of my favorite phrases in the Cowboy Guide to Life. It says, when you find yourself in a hole, the first thing you need to do is stop digging. I don't know that Creed is going to do that. They're going to surface skim, so we'll see.
Mhm.
We'll see how that works out. Hopefully, the drive pulleys hold up. I have very good confidence in the drive system for moving the robot. I don't think there'll be any issue there, but it'll be clearly an issue of swept area, picking up as much material as possible, getting in the hopper, getting back to the berm area, and dumping that material in and filling up that berm box uh, to the greatest extent possible. And I know they can do it because they've shown me some pictures of their testing in a volleyball sand pit, and you could not see the robot sitting behind the pile. It was that big. So I know they can do some great stuff. So let's keep our fingers crossed here and give a shout out to San Diego State University.
Yes, sir.
Yes, I wanted to say that very clearly because I messed up the last time.
No worries at all.
Yeah, and let's see how we do here.
About a minute left.
Yeah. I do have to say, I talked to one of our guys, Walter. He said I was worn out by the time I got the pit back together after New Mexico Tech.
Oh, I bet.
Oh, that was a lot of work.
Yeah.
That was a lot of work.
Yeah.
And I see they got the hole that New Mexico Tech put in my wall taped up, so that's good.
Nice.
Hopefully you guys.
Oh,
know
I
it.
do see that.
Yeah, yeah, that little white spot right
Mhm.
there. Yeah, yeah. He put his bucket right through that.
Oh man.
So about 4 passes into the run, I thought this guy's driving like a drunken idiot. I need to call the police and have him report a DUI incident. Yeah,
Oh man.
but he got it worked out. But I tell you what, there was some very high pucker factor moments, as I like to call them, in there watching him run. He was very familiar with his machine, knew how far he could push it without it tipping over.
Mhm.
But I texted that to Eric Reiners and told him he needed to watch this run. He texted me back this morning, asked which video to pull up, and I told him where it was. I'll see if he's responded back yet, but very interesting run. We like sharing these moments where, yeah, no response back from Eric on that. So, Eric, if you're watching, I hope you're enjoying what you're seeing here at the collegiate space mining competition at Iowa State. And we've got the timer ready to go for Creed's second competition run in the Iowa State Lunar Arena, the room I affectionately call the box. And here we go. Saw a little nudge
Got some
there.
mobility going.
Yeah, there we go. We're on the prowl.
Mm-hmm.
And just look at that thing roll. I just love the way that thing just turns and no stalling,
Yeah.
creating a whole bunch of piles of material. It just keeps rolling.
Right.
Almost like a Conestoga wagon, great big wagon wheels.
Oh yeah.
Yeah.
So I believe they'll start out with their autonomous routine,
Okay.
just while the path is clear for the most part.
Yeah. Okay.
And again, this is a time-based routine. So
Okay.
they'll dig for a few seconds while moving forward, and then come back.
Back up and down. Okay. Well, it looks like we've got a perfect position.
Mm-hmm.
And away he goes.
A little bit of latency.
Yeah, I think our video appears to have stalled.
Oh.
Oh, here we go.
Oh. I
There
think
we
they just
go.
ran it again. Yep.
Yeah.
Just to get it in the berm area.
Yeah. Okay, there's the start. Looks like you're going to shift to the right a little bit, stay away from that rock.
Mm-hmm.
2014, we had it worked out that with the number of buckets that we had and the depth we were digging at, which was about 10 centimeters, that we could get a full hopper in 2 meters of operation. So we had it set up so that we would drive to the end of the arena. We had a contact switch that would hit the arena. That was the year where they still allowed us to touch the wall, so to speak.
Mm-hmm.
And then we'd back up using our encoders 2 meters, put the digger conveyor down and run her forward until we hit the wall again. Then we'd go back and empty it out, and it would just automatically do that back and forth. And every time it went out, it would jog to the left and jog to the right, jog a little more to the left and a little more to the right.
Oh, okay.
And it worked out really well for us. So we kind of did a fan pattern in the mining area by the time we got done. And it worked out really well.
Nice. And that was a fully autonomous routine.
Fully autonomous routine. We had a bad first run. We had a very successful second run, but we didn't go all out.
Mm-hmm.
But we wanted to demonstrate what it could do, so we asked if we could do a demo run on Friday and of that week.
Mm-hmm.
And in 10 minutes, we dug up 199 kilograms of regolith.
Oh my gosh.
Yeah, it was pretty impressive. The judge we have it on video recording. The judge says, as we were pulling the robot out, he said, "You all would have had a first run like that. You would have destroyed everything." And yeah, we felt that way too. So we made some changes to the robot for the next year so that we could do even a little better. And then we got bit by the communications gremlin and controls gremlin. And we broke our robot in the first run, and the second run, with it repaired, we couldn't get it to connect, and it was heartbreaking.
Oh man.
Sit there for 15 minutes and not have anything happen. It was hard.
Yeah, especially with all the work that goes into
Yeah,
designing and building
yeah.
all that.
It was a very long drive back to Iowa.
Oh man. I bet.
Yeah. Drive last year was much more enjoyable. And this year the drive is going to be very enjoyable because we're not driving anywhere.
Yeah.
We're right here at home, enjoying watching all you guys sweat.
Yeah. To be fair, you guys did put a lot of effort, I assume, into making the
heavens,
arena
yes.
and,
Oh,
and
yes,
coordinating
yes.
all.
Yeah, we've been having sleepless nights too, getting everything
bet.
ready. They really, my heart goes out to all of these club members, all the work they've done, not only in the arena, getting that set up, working with ISU administration, getting permissions to do everything, because, you know, the administration wants to make sure that we're safe and that we're following all of the legal considerations and everything. And my heart goes out to those people as well, because, you know, sometimes they have to say no when they really want to say yes, but they've got tough decisions to make. But they've been very supportive for us, and we're very thankful for that. And they've been very excited with what we've been having going on here. And I think they're ready for us to do it again. The question is, are we ready to do it again? Because we like competing. We like competing at NASA.
Right.
We chose, because we're hosts, that it wouldn't seem right if we would compete and win any awards at our own competition. So we chose just to demonstrate and share the love, so to speak, with everyone else. And yeah, I really think we've done an excellent job of setting up a scenario here for nice pits with good room.
Absolutely.
And, good accommodations, hopefully. There's enough hotels.
Yeah. Mm-hmm. Lots of housing nearby.
Yeah. and some excellent eateries as well.
Oh yeah.
Yeah. So what are some of the places you guys have tried out here locally?
You know that you mentioned Hickory Park
Yes.
last time. We actually went there for dinner last night.
Yeah.
Super good.
What'd you have?
The barbecue plate or
Barbecue plate?
dinner?
Yeah,
Yeah, one of the two.
barbecue.
Yeah.
Yeah. Did you have the brisket with that?
I didn't get brisket.
Or what'd you get?
It was pork and steak.
Okay.
Yeah, steak
Yeah.
slices. Still really good.
Yeah.
I kind of
Did you
wish I
have
got
ice
some
cream
brisket.
afters?
Yeah.
Oh,
Yeah.
what'd you get there?
I got a milkshake actually, but
Milkshake? What flavor?
it was the chocolate chip mint chocolate chip
Mint chocolate chip.
mint chocolate chip. Yeah,
Yeah, they have,
that's my favorite
they have
flavor.
a coffee flavored shake too.
Coffee. You know, they had a huge menu. I remember
Oh
that.
yeah, yeah.
It was almost bigger than the actual
Then
food
the actual
menu.
food menu, yeah. It's a great place.
Yeah.
It's not where you want to go if you're on a diet.
Oh yeah.
Yeah. Yeah,
Yeah.
it is an Ames staple. It's unique to Ames, and it's very much an Iowa State institution. And,
Mhm.
yeah, we go there often.
Yeah.
We have a lot of other fine eateries in Ames that we take advantage of too. So, but I'm glad you enjoyed it. So
Yeah.
everybody has to eat there at least once if they're here in Ames. So,
Yeah. I got a T-shirt from there as well. So
oh, wonderful.
yeah.
Yeah. Well, I'm sure the owners and operators of Hickory Park will thank you for sharing the word that that's a great place to go eat.
Yep.
Another one of those little best kept secrets in the middle of a cornfield here in Ames, Iowa.
Yep. Almost a third of the way.
Third of
into
the way
match.
through, and I think we're getting to a good point. Maybe it'd be a good time to
Start expanding.
start expanding. Yep, and that's what he's doing. He's making the turn, jogging the robot over.
Yep.
Yep, setting up for another spot to dump in.
Yeah.
Looking almost routine. And here we go. Getting some good bites of material in there as well.
Yeah. You can see it kind of top off a little bit on
Yeah.
those buckets.
Mm-hmm. Yeah, when you get that little triangle of material up there above the bucket, you know you're getting a maximum fill.
Yeah. It's the best feeling.
Yeah. So, Colin, tell me your major again. Are you, what engineering major are you?
Mechanical.
Mechanical?
engineering. Yep.
Sophomore, junior, senior?
Senior.
Senior.
So yeah,
Okay.
everyone on my team is actually we've already graduated.
You've already graduated?
Yeah, we graduated last week. Yeah.
Excellent.
So-
Okay. Where are you off to after this?
I'm gonna stick it out in San Diego for a couple months and then move back home to San Jose in California. So
Okay.
around the Bay Area.
Bay
Yeah.
Area there. Do you have a job lined up yet?
I do.
What are you
And
going to do?
I'll be working at Lockheed Martin.
Oh, cool.
Yeah, in Sunnyvale. Yeah.
Okay. Can you tell me what you're going to be working on? Is that all top secret because you're part of the Skunk Works?
Well, actually, it's a space facility. Lockheed
facility?
Martin Space. Yeah.
Nice. Excellent.
And honestly, I'm not entirely sure what I'll be doing either. It's
All right.
I'm still working on getting my clearance
Okay.
right now. Yeah, the investigation's still going on.
All right,
But
excellent.
yeah, they do a lot of satellite testing at that facility.
Yeah.
So
I think
yeah.
we have some alumni out there. I think I have some former club members that are actually working out
Oh,
there
yeah.
too. So I'll have to find out if there's any Iowa State people out there.
Yeah. Make
What
sure
we
to
got going at doing the NASA competition for the first time in 2010, one of our alumni, Lee Graham, said, "Jim, you got to get involved in this competition." I said, "Great." And I asked him, Lee, just out of curiosity, how many Iowa State alumni are there in the engineering ranks at Johnson Space Center? That was where he was working.
Mhm.
And his next phrase to me was, "Are you sitting down?" And I said, "Yeah." 1 in 4.
Whoa.
Yeah, 1 in 4 engineers at that time at the Johnson Space Center, at least in his area, were Iowa State alumni.
Oh, wow.
Yeah, we have a very strong aerospace program here.
Mhm.
It's not an Embry-Riddle, but it's very close.
Oh, I
And,
bet.
yeah.
With all these facilities.
Yes,
Yeah.
yeah, yeah. We have close to 10,000 students in the College of Engineering. We're a little over 2,000 students in mechanical engineering. I'm not sure what the numbers are in aerospace. Our electrical computer engineering is the next largest department,
Mhm.
but with an enrollment of 31,000, it's just about 1 in 3 students is an engineering student here on the campus of Iowa State. About 1 in 16, 1 in 15 is mechanical engineer.
Oh, wow.
So
That's a pretty big
yeah,
amount.
yeah, and you can tell it too because you'll see some very interesting things around campus to tell you, yeah, this is an engineering school.
Yeah.
I watched somebody drive by on their motorcycle and he had attached to the side of his helmet one of those Boba Fett antennas from Star
Oh,
Wars.
really?
Yeah, 3D printed
Oh,
and painted
wow.
all up and attached to
That's
his
so
helmet.
cool.
Yeah. See, now you said that's so cool.
Yeah.
Some other person would look at that and say, there goes a geek.
They don't know what they're talking
That's a
about.
strange person. But yeah, it's all Star Wars and Star Trek, and that's the biggest debate. Which is better, Star Wars
Star
or
Wars
Star
and Star
Trek?
Trek.
So which is better, Star Wars or Star Trek?
I'm honestly gonna have to say Star Wars. I grew up with it. It's it's all in my childhood, so.
Yeah, yeah.
What about you?
I'm kind of on the fence. I grew up with Star Trek. I
Mhm.
really love all the series that I love Star Wars too, but see, that was a galaxy long, long ago, far, far
Yeah.
away.
Oh yeah.
And Star Trek is our future.
Mm-hmm.
So that's kind of where my mind is
Future
at.
forward,
So,
yeah.
yeah. I was talking with Phil Metzger, again, a physicist at NASA, is now at the University of Central Florida. And I asked, Phil, is warp drive possible? He says, well, yeah, actually, based on physics and that, it is possible if we can get string theory figured out. I said, well, oh, wow, that's cool. How much power is it going to take? And he said, that's the problem. I said, what is it? He says, the power required to go warp drive is enough power to blow up the Earth 7 times over. So, really? I said, yeah, numbers don't lie. And so,
Oh my
whenever they
gosh.
talk about the warp core blowing up on Star Trek, you got to
Mhm.
really wonder, that's a hell of a bang.
Yeah. Oh yeah. 7 times over, huh?
Yeah. I don't even want to know what that is in foot pounds or Newton meters or whatever units they would use because it's such an unbelievably large number.
Yeah.
So,
About halfway through the match now.
yeah, halfway through and getting a pretty good pile.
Yeah.
Yeah. Our proof of life video we did in trying to think, that was 2016 or 2017. I think it's 2017. Was pretty amazing. Again, it was the 4,000 watt drive motor. You can look this up. You could do Rule 32 2017 Iowa State University, and the robot. We had sand in. They were testing with sand because we didn't have a regolith in there yet. We had just built a new test chamber in the building we were in. And they run the robot in there, and it engages with the sand, and in the next second, you can't see any of the digging bucket. It's running so fast and
Oh.
pulling up so much sand that all you see is a river of sand coming up off of the surface and into the hopper.
Whoa.
And the hopper was filled up in about 6 seconds.
6 seconds, huh?
Yeah, and then they went and dumped it, and it was like 75 kilograms in 6 seconds.
What?
Yeah.
Wow.
Yeah, but see, that's 4,000 watts.
Yeah. Oh, yeah.
And then we hit that rock in the competition and wound up flying back into the obstacle area and get disqualified. So,
Oh.
yeah, there's a difference in running in sand and running in regolith, especially when Mr. 4-inch rock is hiding underneath the surface.
Oh,
And
yeah.
that's the other thing you'll find on the back of our T-shirt is beware the rock. And he's got a smug little cartoon face on him.
Yeah.
Because every year we've been at the competition, somebody finds him. One year Alabama found the rock. As they were digging, they were going very deep, and all of a sudden the robot shuttered and it stalled. And they did a reversal, and they dug and it shuttered again, and then it got moving and then this potato-sized rock come bounding right out of the hole. And so they continued digging because now the hole was open, but it moved the ground just enough, the rock rolled back in.
Oh, wow.
And they kicked it out about 3 times before it finally stayed. So fortunately, we don't have any rocks like that in here. This is all crushed lime rock. There's no hidden rocks in here, so it's pretty safe.
Awesome.
So we got some inactivity. Do you think?
I can't tell what the issue is right
Well,
now.
you know, he had the concern with a lot of material getting the bottom of the belt. I wonder if we're stalled again.
That's definitely a possibility.
Yeah.
For sure. It's hard to tell at this angle. Cooling down? Oh, okay. Gotcha. Got a little bit worried.
Okay. Well, he's cooling it down. It got a little warm.
Yeah. We have been having a little bit of a heating issue with the Falcon motor that turns the excavation belt.
Ah,
So
here's some examples of those fluted pulleys that I talked about.
gotcha.
Yeah. That would help that problem out immediately. So,
Oh yeah.
yeah, it looks like we've gone to the mission control. Hey, Tim, can you give me an update on the run? Are they? It's sitting still. Okay. All right. Guys are making me hungry over there. Touching on the chips.
Yeah.
Well, nonetheless, still a very good pile sitting there in the berm area.
Mm-hmm. Hopefully we can get some more to fill that.
Yeah, fill that up.
Mm-hmm.
It'll be interesting to see what the rules look like if NASA continues with this competition for next year, and I'm sure they will. Very very certainly hoping they will. What adjustments they're going to make to the rules on there. I know one of the interesting things I was talking to Rob Miller about is he has to apply for a grant every year to do this competition. And the people who approve the grant ask him every year, what are you doing to advance the mission? So he can't just run the same competition year after year after year. It has to advance in order to help them advance through their Artemis mission, what they're going to do.
Right.
So it'll be interesting to see if we're still going to be building berms next year, or if we're going to be doing habitat construction or something like
Oh,
that. Yeah,
interesting.
that could be interesting too. Like you gotta maybe cover a habitat with a meteorite shield. So
Interesting.
now all of a sudden it's not just depositing material. You got to get up to a certain height and deposit material. And oh, by the way, don't create a big dust cloud at the same time while you're doing
Right.
it. Yeah.
Mm-hmm.
Excellent example of that. Back in 2011, we had it was an international competition that year. And the University of Laurentian University out of Canada, they had a robot that Oh, okay. Yeah, the word is from Mission Control, they might have hit their own e-stop accidentally while running. But the robot is not running, but the clock is now stopped. So it looks like we're done with the run, but still, nonetheless, a very successful run in the arena for Team Creed. They have a very nice pile of regolith in the berm area. So congratulations on that.
Thank you.
But obviously you got some more engineering work to do.
A little
So,
bit, yeah.
but get some sleep tonight.
Try to do that.
Okay, Colin, thank you so much again.
Thank you for having
All
me.
right. Good run, San Diego State. Thank you. So as I was starting to say for people who are watching online, Laurentian University in 2011 from Canada had a robot that had four wheels. The wheels turned, and so it could rotate, turn, much like the NASA robots on the Mars do. It had a very tall bucket ladder that dumped material about 2 feet into a very large hopper. And the hopper had a live bottom that would move the material along in the hopper, and then they had another tall conveyor because the deposit bin that we had to put the material in was 1 meter off of the surface of the arena. And as they ran, and this was a team that I really think had the performance numbers that still to this day we have not matched in the competition. In 15 minutes of dig time, they dug up 273 kilograms of regolith in the lunar arena at NASA. But by the time they got done with their 15-minute run, because they had a 2-foot drop with no dust mitigation and everything, and this is why Rob Mueller named that robot the Beast. There's 2 competition arenas in the tent that we're running in, and you couldn't see the robot running in either one of the pits. It was just all grayed out. It was like a great big smoke cloud inside the arena because all of the lunar dust that was floating around. And that year they didn't have points for dust mitigation. They hadn't thought about that. And the very next year there was major points for dust mitigation in operation. But nonetheless, 273 kilograms of regolith collected in 15 minutes is a very impressive number. But we saw some equally impressive numbers here. San Diego State, I'm really looking forward to seeing what the numbers are here when they get that evaluated for what the quantity is. Yesterday, New Mexico Tech deposited about 310 liters into the berm area, and if we calculate that out by 1.8 kilograms per liter of weight, it was over 500 kilograms of material over a 30-minute period. So see, not quite to the 273 and 15, but very, very close with a very well-trained operator. I think with a little bit of work here, and I've seen pictures of what this robot can do, I know it could be very competitive once you get all the reliability and durability issues sorted out on it. And it's a very good operating robot on the surface of the arena. Didn't have any problems with traction. It's just a matter of the digging conveyor and not getting jammed or the other common issues that we have is sheared keyways, sheared drive pins, burnt motors, wires coming loose, and various other different technical aspects like that, because these robots they move, they shake, you get some significant shock loads in it as you're digging, and that can jar things loose. And so a lot of what they have to put in their designs, they have to be thinking about these things, and fabrication quality becomes a huge issue as well. And when you're getting up against deadlines, sometimes things get put together a little too quickly, and then you have to spend time sorting it out. So one of the common things that occurs here at these competitions over the course of the week is a little thing called lack of sleep. And it's one of the things that it's not fun to go through, but it becomes kind of a rite of passage for the opportunity of doing these sort of things. And I know myself, having done that as an undergraduate and now as an advisor for these teams, we look back on them, oddly enough, fondly, because they were fun times, good times that we had in the competition. And here we are on the third day, getting down to the last few runs that we have for this competition as well. But stay tuned because we're going to do some fun here too. There has been discussion about having a robot tug of war in the arena this afternoon, and we do have some teams signing up for that. So a good old Iowa style tractor pull is what that's going to wind up being, and we'll see who has the best traction and the toughest motors and good drive connections, because it's really going to be an acid test on those. And I hope we have a strong enough rope or chain for the robot tug of war, because some of these robots can really do a good job of pulling. So we'll see how it goes. So we'll be back in a few minutes as we get the arena repaired. It looks like University of North Dakota will be up next to run their robot, and we'll be ready to talk with one of their team members when they're in the arena ready to run. This is Jim Heisey, faculty advisor for Cardinal Space Mining Club and professor of practice in the Department of Mechanical Engineering at Iowa State University at the Collegiate Space Mining Competition, coming to you from the Student Innovation Center on the campus of Iowa State University in Ames, Iowa. So time's going for setup for University of North Dakota. I got Cole here with me. I'll let him talk a little bit more about their robot, how it operates, what sort of issues you've been dealing with. So why don't you tell our audience out there the features of your robot and what sort of things you've been having to engineer through, get ready for the run.
Yeah, thank you. Well, like I said on yesterday's stream, we've had a bit of issues with our computer sending out signals to our shaker motor and our rear door motor. After about 20 hours in the past 2-3 days of troubleshooting and working, still haven't gotten those RGIOs to work. So what we're doing instead is we went to Menards, found a nice little button, and when we raise our bucket ladder system now, it will hit that button, and that will send current from one of our generic 5-volt ports to the shaker motor. And we still couldn't get our hopper door to work, so we have it currently propped open at 2 inches,
Okay.
which is, we tested last night, is just enough to hold the regolith once it like takes hold, and just enough for it all to shake out as well with that offset weight motor on the rear end of the hopper.
Oh,
So we kind of did a how would you say backyard engineering
sure.
solution,
Yeah.
but it definitely seems to
I call
fix
that
our problem.
TLAR solution. That looks about right. Yeah. The acronym I have coined and I use with my students, and yeah, they tend to repeat it after a while. So
Yeah, our team's very excited to get our robot running and have a scored time. And from it also sounds our connection issues have been identified, and
great. Yeah, that's always been a big issue is connections and linking into the Wi-Fi.
yeah, so hopefully our solution works. I believe they're going off of a plugged-in Ethernet cable straight to our router, which worked last night. We were testing until midnight, and then we woke up back at 4, went back at it in the morning. But at midnight, our solution worked, so hopefully it reigns true this morning.
Okay. And I've been told too that it might be a very strong possibility that we'll get to hear your robot run all the way over here in the stepatorium from where it's at the opposite corner of the building.
That is correct. Yes. We when we tested back at UND, you could hear our motor from the opposite end of the hallway. Now, in our terms, if you're a UND student, you know that that's a pretty long hallway. I would say it's
Yeah.
about a 1/4 mile long. We have a very long
Oh
hallway.
my gosh, that is a very
It
long
is a
hallway.
very long hallway that we
That is
have.
a long building.
Yes. Yes.
How much time do you have between classes to get to the next classroom?
Oh, not enough. Never
Not
enough. Especially with aerospace engineers.
Mm-hmm.
A lot of our buildings, we have maybe one class in our engineering building, and we have one class in our aerospace building, which are on 2 opposite ends of the campus, which always gets very fun because we get 5 minutes between classes. We learned very quickly how to use the bus system. And thankfully they have what we call them, blue routes and red routes. One goes clockwise, one goes counterclockwise. And if you miss that bus, you are showing up late to class.
Oh dear. All right, so we got about 4 minutes and 45 seconds on setup time here. Pardon me, I'm going through the scores from yesterday and Thursday, and just kind of get an idea of where we're at on everything. Each team is Illinois, Arbus, okay. And we got about 4 minutes left.
Yeah, no. Coincidentally, we drew to face in the south direction, which our robot is, funnily enough, designed to be predominantly driving backwards. Because when we were designing for autonomous period,
Yeah.
the only good spot we could fit our camera was on the rear side. So we figured we would have our rear be our forward and our kind of more traditional forward be our rear,
Yeah.
which allows us to basically kind of look at it in the right direction. We don't have to start with a 180 turn right off the
Yeah.
bat.
Yeah, that's often been a debate here. Which way is forward on a robot? You know, with the way it drives, the way it operates.
But yeah, true forward is our hopper door,
Yeah.
but the practical forward is our bucket ladder.
Yeah. Oh, by the way, and this is for the other teams out in the pits, if you're listening. Before you go, I don't know if Sparks Cafe is open today or not, up on the 4th floor. You have to check it out. But one of my team members' parents brought me down a very delicious pint of lunar lavender ice cream,
Okay.
and it was delicious. They figured I had to have it because it had the word lunar in it. But nonetheless, very, very, very good. If anything, we know very well here at Iowa State too. It's dairy.
Fair enough.
Oh yeah, and very good stuff.
Big dairy and corn state, right?
And pigs.
And pigs.
We have more pigs in the state of Iowa than we have people.
That's a fun metric.
Yeah, yeah. And if pork production is big here, the Iowa or the National Pork Board headquarters are here in Ames, Iowa, and we have a very, very large agricultural college here supporting agriculture. We also have the Iowa State School of Veterinary Medicine here, and we also have the National Animal Disease Center here in Ames, Iowa. So anything that is critical as far as animal disease, those animals brought here to Ames, Iowa from every corner of the country. You can see some very interesting livestock at that place as well.
And so,
Okay, yeah, go ahead.
we're about to start.
Yeah, we're at less than a minute now, and we'll see how. Does your robot have a name by any chance?
Yes, Susie.
Susie, that's right. You did mention that, Susie.
Susie. After the fact, yesterday, we had a discussion and we decided to no longer state the reasoning.
Okay.
Just in case of a cease and desist, but it
Oh.
is Susie nonetheless.
Those darn lawyers.
Right?
Yeah, I know.
Mm-hmm.
Yeah, it's the same reason why we went from being Team Lunasci to ISU Lunabotics, and then because of the change in the name of the competition, we decided to go to Cyclone Space Mining, and then we were told we couldn't use that anymore, so now we're Cardinal Space Mining
All right.
Club at Iowa State University. We have to use the full name if we're talking officially about the club. It has to be the Cardinal Space Mining Club at Iowa State University.
That is a mouthful.
It's a mouthful, but that's just the way it goes these days.
Mm-hmm.
All right, so setup time is complete. Looks like the robot's ready to rock and roll, and pretty soon they'll get the timer set for the competition time. Again, I'm going to take a moment here to thank our sponsors for allowing this competition to happen: Caterpillar, Collins Aerospace, Mechdyne, Danfoss Corporation, SICK Sensor Systems, the Iowa Space Grant Consortium, and the College of Engineering.
Oh, we got our fingers crossed here.
Yes, we do. Hoping everything works well. I want to hear that thing growl.
One extra modification we did add to it with our bucket ladder, we kind of gave it a little bit of armor, as you can see in the front.
Yeah.
Usually it is an open bucket ladder system, but we went to Menards the other day, got some sheet aluminum,
Okay.
help prevent any dust from getting into our electronics there.
Ah,
Because we did
yes.
have a little bit of an issue with our motor turning our buckets. Got a little bit of regolith in there in the small hole that allows our wires to feed through our
Yeah.
guard. And
Mm-hmm.
that small hole was just enough to get enough regolith in there to block it all up. So
Oh, wow.
we got a nice sheet casing around it and
Okay.
got it all sealed up. And
I
hopefully
see you got your navigation sign in there as well. Is that yours?
that is not ours.
Oh, that is not yours. It's from a previous team.
Must be
Okay.
from a previous team, yes.
Yep. Okay.
In fact, we actually removed our camera to reduce the weight, just that much more.
Oh, wow.
Um,
That must have been a big camera.
Yeah, it was roughly, I want to say 300 grams, but if you're
Oh.
sending something up to space, that's $200,000.
Yeah. Wow.
Yeah, our current weigh-in actually with that aluminum, we weighed at 48 kilograms today, aside
Hmm.
from our 47.6.
Okay.
But we did have a goal for 60 kilograms to be under there, and thankfully we are still around 12
Yeah.
kilograms less.
Now tell me about your wheels here. They look very interesting.
Yes, they are. Uh, the rims themselves are 3D printed with PETG,
Okay.
wrapped in carbon fiber. It's all continuous, and we have our grousers kind of into that carbon fiber wrap as well. Um, our spokes are aluminum, and the centerpiece, the center wheel hub,
Yeah.
is made of polycarbonate with
Oh.
5 layers. It's proven to be pretty resilient. We actually had a bet before we got here when we tested it to see if the wheel hubs would fail or if they would succeed.
Mm-hmm.
I was very confident in the strength of it. We did a little bit of analysis and we determined that as long as it doesn't run into another wall, should be beautiful. And we've even driven over some small rocks about the size of the ones you have here, maybe a little bit smaller.
Yeah.
It did crawl over them, so if it
Wow.
can hit that, we are pretty confident our wheels are strong enough to hopefully
Okay.
keep under the weight. But yes, I was wrong on the metric I said yesterday. I said 800 grams, they were 500
Yeah.
grams
500
each.
grams each. Hey, what's the lowdown on the competition time? Network issues on our end? Okay. So we're having network issues either in mission control or in the arena area. We're trying to get that sorted out before we kick off this competition run. Okay. I'll continue grabbing data here
Mhm.
for the interest of full disclosures where we're at right now.
Oh, we've got it moving.
Okay, we have,
Oh,
and
it's
the
already
timer's going.
leaps and bounds ahead of better than yesterday.
Yeah. Okay. Needs to pick up the bucket ladder so you're not dragging it. Hmm. That was the same issue we had on our first run. Oh, there it goes.
Seems
It's
up.
coming up. There we go. You got it engaged. You can see a little bit of gap open up there between the and the background. So they're getting it off the floor. And it's turning much easier now.
Much easier. Yes,
Yeah.
like I said, if we raise that very, very high, at some point it will hit our button, and that's when the shaking will start.
Oh, okay.
So, as you can see, there has a little orange marker,
Yep.
which tells us exactly when they're just about to hit that zone.
Mm-hmm.
And then once they see a little bit of a gap at the bottom, that's when they know that it's right about to hit. A little
Okay.
bit of a easier visual marker for our driver.
Yeah.
If he
So-
doesn't feel it, he'll definitely at least see
Yeah.
it.
Well, it looks like he's getting lined up.
And we actually also sped up our motors just a little bit, so we'd have hopefully more time for
Mhm.
cycles.
Mm-hmm.
Our current goal is to get 15 cycles in this run, so that's about
Ah.
2 minutes per cycle.
Okay.
If all goes well, looks like he needs to lower it down a little bit,
Mm-hmm.
and yeah, looks like we are starting to pick up
We are
soil.
starting to get some samples. Yeah.
And like I said, yes, our bucket is or our hopper, the door is permanently slightly open,
Mm-hmm.
because our linear screw could not get that to work with our
Oh.
hardware.
Hmm.
But the angular repose of the regolith is just enough to start sitting on that 20-degree angle.
Mm-hmm.
It will build up a nice little pile on the inside still, and we can still shake it all out. Our drive train itself, like I said yesterday, they're the Flip Sky motors,
Mm-hmm.
or Flipski, whichever way you like to pronounce it.
Yep.
Connected to our gearboxes, which have a ratio of 192 to 1. So we really went forward with a robust drivetrain, because our last year's rendition was only working with those small Neo motors,
Yeah.
which it barely managed to turn on its own weight, let alone
Yeah.
full load.
Mm-hmm.
So yeah, we're pretty confident that our drivetrain will never fail. It will be our wheel hubs. And as you can see,
Mm-hmm.
if our bucket ladder ever stops,
Yeah.
that means we our motor was how do I say this? We have a kind of a mechanical system set in place, so we never burn out our bucket ladder motor.
Ah.
It's almost like the best way I would describe it is like a ratchet style gearing that we have in there.
Mm-hmm.
So once it hits a certain amount of torque, I don't remember that metric
So
offhand.
you essentially have a load clutch in there
We have a
to
load
keep it
clutch.
from. Yeah.
And so it'll click and it won't move the buckets so that the motor stays safe. Oh, I think you can hear it. I think
Yeah.
that's the sound. Yeah, and there it is.
There it is.
Coming out.
Coming out.
Yep, I know. I'm not sure if you can pick it up on the microphone, but we have a
No,
very.
we can't. We can hear it.
We can hear it.
We can hear it buzzing away.
Yeah, and
Tons of concrete.
Through tons of concrete, we can hear that motor go. Yeah.
Everybody's plugging their ear in the arena.
Oh yeah. Yeah, and like we said earlier, before we started the stream here, we told the crew at Iowa here that our robot's gonna be a little bit loud.
A little bit loud.
When they heard our drivetrain move, they're like, "Oh, that's kind of loud. Okay, I understand what you mean."
Yeah.
And we were like, "No,
No,
that's when
no."
it's quiet." We need to put up a decibel meter,
Well,
see
yeah,
exactly
let's
how
see
high you can get
exactly
it.
how loud it is. Well, I know we know what loud is because Hilton Coliseum, when it gets rocking and rolling during a very raucous Iowa State basketball game, is one of the loudest arenas in the country.
Oh, I believe it.
And I think they've measured the decibels in there at 109 or 110
That's
when
pretty
the
loud.
audience gets really into the game.
Off the top of your head, do you know a similar metric for that, like a chainsaw or?
Oh, that's a good question. We'll have to look it up.
But yeah, I remember I drove by the Coliseum and the fields. Very, very impressive in comparison to UND.
Yeah.
Um,
Oh, well, thank you. Thank
Yeah.
you. Let's hit the Coliseum. Nice. 109 decibels.
Very nice.
And let's see. What makes decibels? Okay, this is comparable to a hand dryer. I doubt that.
No, it's
Or a
much louder.
motorcycle. Jackhammers,
Jackhammers.
power saws, symphony orchestras. Really?
I'm sure.
Oh,
they've
here's a fun fact. Guinness World Record for the loudest burp was 109.9 decibels.
There you go.
Okay.
Yeah.
Not gonna argue with Guinness.
I'm sure they caught you on an off day when they recorded.
Yeah. Oh, they are gonna attempt to get a decibel meter on this.
That would be
Okay,
amazing.
That would be fun. That would be fun.
Are you-
We're always about data here
Of course.
at an engineering school. You know, you can say what it is, but let's get the numbers.
Let's get the numbers.
I am very big on numbers with my students in my vehicle dynamics class because, well, how do you know you got a good car? Well, show me the numbers. Well, what sort of numbers I'm supposed to show you? Well, let's run through the list. First is how much does a car weigh? What's the weight distribution front and rear? What are the spring rates? What are the suspension travel distances? What are the roll center heights? What's the CG height for both the full car and the sprung mass and the unsprung mass? And then all of a sudden, about that point, I see the eyes glass over because I realize, okay, he's winning a lot more numbers than I realize there are on designing a suspension system. And it goes way beyond that, of course.
And that's the beautiful thing about engineering. You can make whatever you want, but if you don't have the math to back it up.
Oh, very good, Grasshopper.
And the way I always see it is anything you see going on in the world, you can quantify it.
Yes.
Accelerations, how fast you want to fall, all that stuff. You can figure anything you want out with math in some degree.
Yeah, it's really, one of my favorite quotes is from Albert Einstein. He said, scientists observe that exists. Engineers create that never was. And then at that point, I always ask my class, do you know what Dr. Einstein's first job was out of college? And they all sit there and kind of look. And he worked in a patent office. He was a patent clerk. So he got to see everything that the engineers created, was duly impressed by what they created. And
Yeah. I'm sure my team is very hooting and hollering in the control center
oh,
right
I'm
now.
sure they are. They've gotten several good piles here. The unload seems to be working. And unlike our 2012 robot, your vibrator is not unhooked to any of the electronic wires. We were sharing that story earlier. We had tested vibration. We had some very loud vibration, not near as loud as this thing here. We can hear it all the way over here when it runs. But in 2012, we tried vibration unload on our robot during a practice run before the competition runs. And when we engaged the vibrators, oh boy, you betcha, the load came out right away. But then the robot went dead, and we had unplugged half of our control wires on the computer system. So we unplugged the vibrators and didn't use them anymore. And I've talked about using vibration with a club ever since then, and they're all afraid to do it.
Yeah, and we had a good example of how vibration motors can be a little bit scary at times.
Yeah.
What was it? It was Thursday.
Yes.
We were all in the pit area, and this little girl lost her balloon. And every team went and all looked at the balloon, and we were all watching it float up. And some of our teammates who were plugging in wires, they lost concentration for just 1 second to look at that balloon, and our vibrator motor started going off.
Oh, dear.
And everyone thought there was an alarm or something. And thankfully, our computer scientist, Garrett,
Yes.
he instinctively just slammed down on that e-stop, and we got a good way to prove that our e-stop worked for all the teams to see.
Oh, good. Well, here we go. We're going to do another unload. I see material starting to come out. Getting a pretty good pile there.
And yeah, our team goal was 0.15 cubic meters of regolith
Yeah.
to mine.
Okay.
As our senior design team started in August, our professor had us label out 6 criteria for success. And based on our last year's team, they could only manage about 0.9 or 0.09, not 0.9, 0.09 cubic meters. And we figured, let's shoot for almost double. And so hopefully we can hit this 1.5 mark. In testing on sand, we did manage to reach that, but that was in a better controlled environment. We could have immediate response. This added challenge of the 2-second delay, I'm sure, is making our driver a little bit nervous, but he seems to be adjusting quite well.
Let's see. Stopping for mechanical failure.
Mechanical failure. All right.
Okay, maybe something did come unplugged.
Perhaps. Well, I know that this already has been a success in our book.
Yeah, it really is. I mean, you got material in the berm area. You will score points, even though maybe the robot is now dead on arrival. 100 decibels. Okay, well, that certainly has a voice.
It's about the sound of a burp.
A loud one at that.
A loud one.
Very loud one at that. Well, very good.
Well, all right.
Okay. Well, Cole, thank you.
Yeah.
It's a very nice conversation and good luck.
Yeah, thanks again.
Yeah. Very nice run for the most part. And even with all the technical difficulties, we got a fair amount of material in the berm area and successful run.
All right.
Okay.
Thanks again for the invitation.
Oh, thank you for being here. Okay, and as mentioned, I was been looking up data, and so far here are kind of the results that we're looking at. Day one, San Diego State University got 852 points on their first run. and collected 147 liters of material into the berm area. Followed by New Mexico Tech, who got 767 points and collected 182 liters of material into the berm area. And University of Arkansas did 262 points, but only had 16 cubic centimeters, or about 0.016 liters of material into the berm area. ISU first run did 222 points, 57 liters. And Youngstown State University did 428 points and deposited 41 liters. And that was day one. Day two, New Mexico Tech came in and rocked the arena and scored 1,026 points and deposited 310 liters. Actually deposited more than that, but that lies outside the box area doesn't get counted. So what did get counted was 310 liters of material. Arkansas did their second run and got 233 points and 3.8 liters of material. ISU did their second run, got 435 points and 73 liters of material. YSU did their second run, got 623 points and 45 liters of material. And UIUC Iris did their first run and got 218 points and 6 liters of material. University of Minnesota did their first run. They got 325 points and 33 liters of material. And Virginia Tech just finished their run, and they got 307 points, and earlier here, 307 points and 105 liters of material. Let me go back and double check that. Yes, that's correct. 307 points and 105 liters for Virginia Tech on their run today. And as we just saw, University of North Dakota completed their run. Don't have the numbers yet on that, but I'll report that as soon as I can. San Diego State University on their second run, they scored 823 points today and had 144 liters of material collected. So a very consistent run between their two runs for San Diego State. We take the max or the best run out of the two runs, so they'll obviously take their run one. New Mexico will take their run two. Arkansas will take probably their run one, even though they had less material, but just scored more points. Iowa State is not in the competition, but if they were, they would be taking their run two at 435 points. Youngstown State will obviously take their second run at 623 points. UIUC, Iris has to do a second run yet, so we'll see how that comes out. University of North Dakota, I believe, should have their first run, I think, was maybe a scratch, so they'll go with those points that they'll get, and I'll report that as soon as I know that. University of Minnesota has another run coming up, so does Northeastern University. Their first run was a scratch. I don't have any points for them on the first run. And yeah, and then after that, we will have robot games. Not to be confused with the reindeer games. There's no Rudolph here, at least as far as I know. And we'll come back with more as we're ready for the next run. Again, this is Jim Heisey, faculty advisor for the Cardinal Space Mining Club, coming to you from the Student Innovation Center at Iowa State University in Ames, Iowa. This is the Collegiate Space Mining Competition.
video.
Back. We're getting ready for Northeastern University. And remind me your game.
Dylan.
Dylan. I've been having a wonderful conversation with Dylan and his teammates and his advisor. And I won't tell you everything that we shared here because it probably shouldn't. But
Will be a great story.
they were asking me for a lot of advice as to what should they do teaching students. And I said, I'm not sure that I'm the person you should be asking that of. But at any rate, so Dylan, we're ready to go here. Tell me more about your robot.
So our robot's name is Theta, but
Theta?
Theta.
Okay.
But the goal of our robot was to create the best possible robot with innovative design on a super, super tight shoestring budget. So we're a brand new club. We just started up a couple months ago. You know, a lot of other teams here, we see they've got these amazing
Wait a
robots.
minute, a couple months ago?
A couple months ago, yes.
You know,
sir.
most teams work on this for a full year.
I mean, I guess that's just what makes us different.
Oh,
But
I guess so.
so basically, we wanted to lay out at the start, right?
Yeah.
We want to complete these tasks. We want to use these specific parts. What makes us different? Obviously, our budget. But
Yeah.
obviously, what can we do different within our budget? So I think the most obvious thing is our rocker bogie system right here.
Yep.
So while a lot of teams we see they use, you know, 4-wheel drive, the wheels are kind of it's kind of like a tank.
Yeah.
Ours has the ability to have one wheel just completely up and 3 on the bottom.
Okay.
And that gives us more grip. And it honestly, I know we're supposed to avoid the rocks, but basically
Yeah.
what that gives us is that in the real moon, right? So say
Yeah.
our robot's on the moon right now.
Yeah.
It can just kind of go over rocks
Okay,
instead of
now
having
a
to go
question,
around
how
them.
does
Yeah.
it maneuver? Is it doing a skid steer system? Or
No,
do
it's
the
just
wheel start?
regular tank drive. But
Tank,
so
now, okay. I'm doing a correction here. I've been
Yeah,
trying to
okay.
work everybody.
oh, of course, yeah.
Tank drive involves tracks. Okay, and
I'll
two
follow, yeah.
motors. Okay.
Okay.
You've got 4 motors, right?
We got a 4-wheel,
that's
four-motor.
That's a skid steer
skid steer. Okay.
type drive. Okay.
You know, you learn something new every day, I guess.
Yeah, yeah,
Hey,
yeah.
so
It's not a
I learned
tank
something new.
drive.
It's a
And,
four-wheel drive, yeah.
now, before we get going here too, here's a funny little story too, because I've been trying to convince NASA that they need to look into possibly using tracks on their future robots that are going to do mining. And it's because you get better flotation, better traction, and you only have 2 motors. And, you know, that's more reliability, supposedly, right? You know what their answer to me every time is?
What is it?
Oh, we can't use tracks, they're too heavy.
Oh, come on.
Yeah, exactly. No, can't be.
I don't
we,
think so.
We had built one robot with tracks one year, 31 kilograms was the weight of the robot.
Got you.
And so I explained to him, well, why do heavy vehicles have tracks? Well, you look at a Caterpillar tractor, it has tracks. Well, why do they have tracks? Well, it's because they're moving a lot of dirt, and they have a lot of horsepower, and they have to have a lot of traction. They can't afford the vehicle to get stuck. So tracks give more flotation. And the reason the track system itself is so heavy is because of the sheer amount of horsepower that the vehicle is running, and they want to have that mass so they can push a lot of dirt.
Yeah. I mean, I think these. Oh, sorry to cut you off.
Yeah.
I'm just gonna say that
Yeah.
these are attributes I think NASA would kind of like to have. Just from what I can say.
Just to understand it, you know, because if you don't have the weight, if you don't have the massive horsepower, you don't have to have the massive weight on the track system. We've had some very nice track systems in here that have been running and doing a pretty good job. And then well, tanks, you know, too. Well, stop and think about a tank. I mean, yes, it's heavy, and a stuck tank does nobody no good.
Mhm.
But the biggest issue there with a tank, you got to have a strong track system, because a little phrase I like to use: a tank lives in a projectile-rich environment.
What do you
Think
mean
about
by a
that.
projectile-rich environment? Like
It's always been shot at.
I
See,
was
now,
about to say, I'm like,
this is the humor that we were talking about here. You know,
Hey, you-
Mr. Heisey, are you ever serious? I'm serious all the time.
but you gotta have fun. while
I have
doing it,
fun
right?
while doing
That's
it.
what-
So I
that's it.
find fun phrases
Yes, sir.
to describe situations, you know, and so when you're being shot at, it's called a projectile-rich environment. Okay, we're moving here,
Awesome.
and they're turning and rolling. This is looking very promising. And yeah, you talk about rocker bogey and having clearance to roll over rocks and that. A lot of our earlier designs here at Iowa State too were designed to just roll right over these rocks, but not the same size rocks that we have here. They were generally at NASA a little smaller, but so, and then the NASA got a little tighter on their requirements on autonomy and that, and they got the size box smaller, so we couldn't afford to design the ground clearance into a robot. But you got some really nice ground clearance here.
No, thank you. Actually, I don't know if Matt mentioned this, but there's a set of stairs nearby where we're working at, and we were
Yeah.
able to drive down the stairs with just the chassis. Now, with the excavator, it might be a slightly different,
Yeah,
a slightly
CG.
different, different CG. It might fall over,
Yeah, yeah.
but that just shows, the capability of the rocker bogie system. Like
Yeah.
the fact that this robot that we built in a couple months with like a simple rocker bogie, if it can
Yeah.
go downstairs, that means we might be onto something kind of serious right here.
Yeah. Well, we'll see how it does here because I'll just add some personal interjection here. The wheel drive system is fairly small in size, so your pressure density is pretty high on the ground. You can see how they're digging in right now
Exactly,
while
yeah.
you're trying to maneuver, and so that's going to be an issue. And if you looked at SDSU's robot Creed, how
Got
big those
huge wheels.
huge
Yeah,
wheels.
so that was if I could actually talk about the wheels for a second.
Yeah.
I actually designed the wheels themselves.
Oh,
But yeah,
excellent.
with a little bit of help from our
Well,
from
they're a
Matt.
nice looking set of wheels.
Thank you.
Yeah.
So our thing was also that we didn't have that much time, and 3D printing, right? So our wheels are 3D printed out of PETG. Completely everything's 3D printed, and we don't have that much time. So with those
Yep.
parameters, we're like, okay, we could have big wheels, but if we want big wheels, we're gonna have to do 2 different prints. And we were basically working with one 3D printer because we share our
Yeah.
workspace with 4 other clubs.
Mhm.
So it was either do half at a time and not be able to spend that much time testing, or kind of just knowingly create these smaller wheels that might not perform as well, but it gives us time to focus on the other aspects of it.
Yeah.
So I mean, because these wheels are smaller, we had more time to allocate towards testing, say, the scoops, like the buckets on there,
yeah.
and also the excavator, and different electronics, and it just gives us more time.
I'm really enjoying your bucket ladder system
Thank
here
you.
because you are using a classic 4-bar mechanism
Actually, it is a 4-bar mechanism with 3 bars.
with three
With 3 bars,
no,
yeah.
Well, no, the chassis is the 4th bar.
I guess so, yeah.
Yeah, see, you're talking to a former GM suspension
No.
engineer here. So
I'm actually really enjoying your take on this, because it's a whole new perspective for me, and
Yeah.
please, I'm absolutely loving it. Thank you
oh,
so
great.
much.
Well, you're welcome. It's been my pleasure. But yeah, and very nice range of motion on there. And now he's going to try to collect some material. And
It's doing better than yesterday,
Yeah.
honestly. We had an issue, so yesterday we got stuck around this point because we're using a worm gear to lift up the excavator arm to get
Yeah.
it back up and down. But what happened was we have a plate at the top that
Yeah.
keeps our motor's mounted vertically, if the camera
Okay,
can see.
yeah.
And there's a plate on top here, and
Yeah.
a shaft goes through here and it keeps the motor from falling forward and disengaging the gear.
Yeah.
But what happened was we didn't put the plate on because we thought we left it at home. So
oh,
we kind of were just like, let's go for it. Let's see if it works. Unfortunately, it didn't, but now we were able to find it back at our Airbnb. So now it's up and working, and honestly, from the looks of it, it's doing a lot better than yesterday. So
yeah.
yeah.
You're getting
And we're
some
also
material.
we're trying to use some autonomy. So the first part, when we were going to the dig zone, that was fully teleoperated. But now when we're going from the dig zone to the drop zone, we're trying to do full autonomy and really try to gain some points on that. We were
That's
working really
excellent.
hard on it
Yeah.
last night.
Good. Well, let's hope that the computer doesn't get the robot lost.
That'd be a nightmare.
Yeah, and it does happen.
I don't think PBS would want to show that. So. Yeah.
But okay, here it's picking up a little bit, and
I just want to say I told some of my friends, my family, to watch this. So
okay.
yeah, I just want to say hi, and
Yeah,
if you
give
guys
them
are
all a
ever in
shout out.
Iowa, go to Hickory Park. Jim, you gave a great and absolutely amazing suggestion for where we should eat dinner. We went to this
Okay.
place called Hickory Park. Absolutely amazing. They have some of the best, just I think everything I've ever had. Best sundae, best I wouldn't say the best burger because we got In-N-Out, but
Yeah,
but you know,
no,
I'm
no,
not
it's
not trying to
okay.
offend you guys, but
No, no,
yeah,
no. They have good burgers too, but
amazing.
now maybe I'll get my next meal for free at Hickory Park. If anybody from Hickory Park is listening, or spread the word.
Of course, yeah.
Or I'm gonna get fired before advertising somebody who's not one of my sponsors.
I don't think Caterpillar's gonna be too happy with that.
Well, no,
No.
I'm talking more of the university.
Oh,
We have very strict guidelines on how we're
gotcha.
supposed to do things. I'm not
Yeah.
supposed to use catchphrases or whatever, and I haven't here, and we've been very good about that.
My
But,
friends and my faculty advisor, they're right behind there. They were telling me like, Dylan, don't say anything weird and get the university in trouble. So
Yeah,
doing the best.
okay,
doing the
okay.
best,
We're gonna
doing the
we're
best
gonna
we
we're
can.
gonna control ourselves from here going
Exactly.
forward as we
Yes,
watch
sir.
the run here. So it looks like they're figuring out. Oh, that's right. You dump out the bottom, right?
Yes. So
Yeah.
what we have is if you look at the opposite side of the excavator
Yeah.
right there, you see how it's kind of like open.
Yeah.
What we do is we have the dumping system go into this little chamber, and
Yeah.
the chamber's got a bottom with the slide out.
Okay.
And so we kind of just position the robot. I think that's
yeah,
right
that's
there. That's the drop
it's
right there.
a little
Yeah.
pile right there.
Absolutely amazing. So we'll
Well,
drive our robot.
It's
to
actually
over it
like
now.
we got two piles there, but one's right on the line. But hey, that works. You know, I mean, it'll get part of
Hey,
it
better than what
counted.
we did yesterday. So
Yeah.
it's honestly, this is exactly what we wanted to do. It's just this. What we wanted to do was kind of have the ability to really quickly get down, get some dirt in, go back
Yeah.
out, shoot it out, and then just get right back and just keep going back and forth. And
If you want to have a fun time sometime, look up the Rule 32, Iowa State University. I think it's 2017.
got you.
And that
Rule
robot,
32.
it was space ketchup and space mustard were our two robots. We ran two robots at one time in the arena. I don't recommend it. But we thought it was a good idea at the
I
time.
didn't know it was legal. I didn't know-
Oh yeah.
Oh,
Well,
wow.
back then you could run multiple robots, and I think they
see.
still allow it. But every team that I've seen run multiple robots, the first thing you discover is you got to get out of your own way, and we were constantly in our own way and doing that.
If I could interject for a second,
Yeah.
if there was something that really surprised me was seeing how small the arena is. Kind of, it was like I was surprised at the multi-bots because
Yeah.
it's barely wide enough for one robot to get through the entrance right here and like to get to the excavation zone.
Yeah.
Having two would be a
Well,
little
I'll be
detrimental
honest
from what I
with you.
can
The
see.
arenas now that NASA is running and we're running in are a little more constrictive than they were early in the competition. But yeah, it does become a real issue because the receiver is only so wide, and the receiver was just wide enough the year we were doing the two robots that you could park two robots side by side. But you had to be very accurate in maneuvering, or you'd drive right on top of the other one, and we did
I
a few
see.
times.
Oh,
Yeah, and then we
Not fun.
and if you get them jammed together, you're done.
No.
And we almost did, and we burned so much time trying to maneuver to get out of each other's way. Hey, there we go.
that's the
drive
rocker
right on-
bogey right there. Yeah.
right there, doing his thing,
Yep.
and doing it very nicely. Yeah,
If I could just talk about the rocker bogey for a second,
Yeah.
if you can see right there, when that front right wheel went up,
Yeah.
the rest of the three are just on the ground. So that's kind of exactly what we were looking for. It's
Mm-hmm.
being able to have as much traction as possible, even when you're on uneven ground. We took
Yeah.
a lot of inspiration from the Mars rovers on
yeah. Curiosity, and
Curiosity,
Perseverance.
Perseverance.
Yeah,
I think
spirit and opportunity.
absolutely amazing. Like I'm from Locker Center, which is right next to JPL, and
Yeah.
so seeing the rovers, seeing their rocker bogies, and being able to kind of implement it on our own robot, like that was my idea, but seeing it implemented is absolutely awesome, and just it's so
Yep.
cool. And I was talking to I know a couple people who work at JPL, and I was
Yeah.
talking about the robot with them, and then I was like doing my little, oh, do you know what a rocker bogey is? And they're like, do I know what a rocker bogey is? Like they're like, we made
Yeah.
the rocker bogey, and
Yeah.
that was just so cool. You know, we'll talk about
Yeah.
it with them.
Okay. Yeah, you even tried a rocker bogey with a track system in 2016
Was it
with
just
ketchup
two
and mustard.
tracks?
Just
Was
two
it
tracks.
2 tracks?
But we actually had them on pivots and the rocker bogies so that we
Oh,
get
I
the
see.
tracks to walk over rocks a little bit better. We didn't quite figure that one out quite correctly because we discovered that we didn't have a limit, and one of the tracks wound up doing this.
Oh, Jesus
on us.
Christ.
Yeah. Yeah, but we were able to get it back by reversing that track, and we got it back down, and we just we can't do too harsh.
Was
of
there any
maneuvering.
suspension on it at all? Were there any
No.
shocks? Or was it just pure 2 tracks?
Just pure two
I
tracks
see.
on a pivot, and none of our track systems we ever built ever had a suspension on it where the bogies would move. In fact, a couple of years ago, our track system. Oh, we're trying to move here, and we're getting. Okay.
I think we're just going for the dump right. I see a decent amount of dirt in, so
Yeah.
it's also we're able to, since the excavator's kind of off,
Yeah.
it's a little harder to move because our center of gravity is now so off. Because our robot's
Yeah.
super light. I think, correct me if I'm wrong, I think we might be the lightest robot here at this competition.
I haven't seen the weight measures on it yet, but yeah, it's a very light robot.
26K. Okay, got you.
Yeah. Yeah.
Either us or UIUC, but
Either Iris or you guys.
yeah. So
Yeah.
our weight is only 26 kgs with the excavator fully on and like stowed in the back.
Yeah.
That's where a lot of our weight goes. So when it kind of gets off and shifts to CG, we're not able to put as much pressure on the wheels, and we're not
Well,
able to.
it looks
get
like
out.
you're getting stuck here because
Yeah.
I think we're turtling on
Yeah.
the ground again, and that's very common with these small wheel systems.
100%.
Yeah, yeah. So that's unfortunate, but
yeah.
this is what it's all about: is
Exactly.
engineering and learning. And
100%.
you know, the fact that you guys have done this in 2 months, my goodness,
Not two. We did it in
three,
in
3 months,
3 months.
Still,
Can't forget that.
3 months. My goodness. And it's, you know, for the most part, it's operating pretty good. But you know, a little bigger set of tires.
100%. Yeah.
Yeah, and you'd be rocking it.
Can I just say something real quick though?
yeah.
Like, we really do want to thank ISU for hosting this competition. We were absolutely devastated when we couldn't get into the Florida competition, and I think a lot of people kind of just lost interest in the club as well.
Yeah.
But being able to come here and actually see what it can do, and you
Yeah.
know, have the opportunity to visit Iowa and look around the campus, it's been really cool. Like, thank you very much. It's been awesome.
No, it's been
Absolutely
our
amazing.
pleasure. We after we got over the initial anger, and boy, we were
Oh,
spitting fire.
no.
You know,
I
that
can
this whole
imagine
thing
that.
kind of happened. You know, no animosity to Caterpillar or NASA. These things just happen. But you know, you don't like being in that situation.
no,
And so we got to thinking, well, what are we going to do with this? How are we going to make lemonade out of lemons? And then the club decided, well, let's run our own competition.
It's like, how can you make lemonade how can you make lemonade with lemons but no squeezer? You got to create your own squeezer.
Yeah,
And that's exactly
well,
what you guys have done. It's
That's
just
what we've
amazing.
done. Just
So much fun.
and I think the biggest hurdle here is what you're watching right here is this arena. Is the fact that we could design this very temporary arena, get it put up in 3 days,
It's
and
amazing.
we were told it was probably going to take a day to load it, and then we were told it was going to take 2 hours, and then facilities comes in with an extra skid steer, and they get it loaded in 10 minutes. Once the load arrived, we got pictures on that, which just totally unbelievable. It's just been amazing how things have fallen into place, getting ready for this competition. We're just really thrilled with how it's gone, and yeah, we've had a lot of requests. Will we do this again next year? Well, that's not our intent, but and I should say that very carefully because I don't want to be ousted by the club. Yeah.
No, it's,
I don't want to be voted out from the club being their advisor because I enjoy it too much. But, you know, we'll see what the next 12 months brings and what happens with the NASA competition. And yeah, because,
I mean, I gotta say though, really quick,
yeah,
I think I'm having more fun. I don't want to speak too soon, but I'm having more fun here than I would at Florida. You know, we got there's some awesome stuff here going on, and like, you know, the state of Iowa is just, we've been like just going around Iowa. Like we went to go play laser tag yesterday at Perfect Game. So much fun. We went bowling. We're about to go like mini golfing, and you know, going around Iowa. I'm from California, so it's like I've never been to the Midwest, and like seeing how things are done here, it's so much fun, and like
Wait.
actually everyone loves it here.
well, you know,
Yeah.
have you ever seen that movie Field of Dreams with Kevin Costner?
I haven't, but I'm a huge baseball fan. I watched
Watch
the
it.
actual game.
Watch
I
it.
will.
Yeah, go watch the movie because there's a phrase in there, and then you'll understand why. And I'll let you figure it out when you watch the movie. But you got to watch the movie.
Gosh, no.
because it's very
I'd be
much
very
an
excited.
Iowa movie. And one of the big phrases that we get told a lot about Iowa is this whole thing that people experience when they get here is this thing called Iowa nice, and just how friendly Iowans are and how helpful they are.
Exactly what I'm going through. It's like, you know,
Yeah.
I think a lot of people have ideas about the Midwest when they're from either the West or East Coast. They're just like, oh,
Yeah.
the Midwest, it's the middle of nowhere. You know, it's like super boring. It's like, oh, like Like, you know, it's just not like
Now,
the East
now
and
wait
West
a minute.
Coast, yeah.
We want to keep them thinking that way because we don't want them all moving here. at
Actually, it
once.
sucks here. Don't come here. Don't come here. No, don't come here. Mom, Dad, don't move here ever. Please, to my friends watching, do not come here.
No, we shouldn't say that either. No, we're
it's-
very happy
it's
to
so
have people
amazing.
come. But no, we do have a very nice quality of life here. The cost of living is very reasonable in Iowa. Our education system is excellent. It's just a very nice because you're located in the middle of growth. I mean, every year you got the farms and the animals and it's just not crowded. I mean, you don't have
I love
smog,
it.
you don't have traffic jams.
I saw the stars come out, and it was beautiful.
yeah.
It's like when I go back home, and it's like you just can't see those
Yeah,
stars unless you drive out like an hour.
Yeah,
It's
yeah,
awesome.
the
here.
light pollution. Yeah,
Love it.
and here you don't have to get very far at all, and you can watch. I just moved into a property south of Ames, and yeah, I can step out my backyard, and I have no light pollution, and I can look at the Milky Way.
That's the
And-
dream, isn't it?
Oh, if you ever have the opportunity, if you really want to have a mind-blowing experience, and that this is for everybody out there as well, if you get a chance to go to the Big Island of Hawaii, take time on Wednesday evening
Wednesday.
to go,
evening.
Wednesday evening to go to the observatory center on Mauna Kea.
Mount. Okay,
Mauna
Mauna
Kea.
Mauna Kea.
Yeah, because they have a 10 o'clock at night stargazing experience, and this is being
Oh,
done
wow.
at 10,000 feet altitude. So, and,
Do you have to
and
climb up all the way?
you
first, or-
drive up there.
You drive up. Got you.
Drive,
okay.
but they have a good vehicle to do it because if you
see.
take an old vehicle, it's not going to like the drive. And watch out for the turkeys. They're out there.
Didn't know there was
It's crazy.
turkeys in Hawaii.
And pigs and all sorts of other stuff. But you get up there and you get your eyes acclimated to darkness. And I was totally amazed at everything we could see at 10,000 feet looking into the night sky. We could see the satellites going overhead. The airliners looked like they were right on
Oh my
top
God.
of you. It was awe-inspiring is what it was.
I think
So,
a lot of the reason why I'm trying to study engineering, and a lot of the reason why a lot of people in this club are into engineering is because of that love for space and that love for exploration, and like that just sounds like exactly what
Yeah.
everyone here wants to do, you know, like be able to see the stars and the satellites and like the airplanes. That just sounds
yeah, well,
awesome.
we're very, very big. I mean, that's the whole purpose of this building here. It's the Student Innovation Center. We're very big on innovation and creation and I mean creating things and solving problems. A lot of what I do through my senior design program is a large part of our mission as a land-grant university in the United States, and that is helping to develop economic growth within the state that we reside and providing education for the masses to raise their level of education and make the state a better place. And we certainly are very proud of that mission that we have as land-grant university and continue to hopefully have the chance to do that for many years to come. And I'm
I hope so
very,
too, yeah.
very grateful to be a part of that mission.
I'm very grateful that you guys have had us out here, and I think from the looks of it, that might be the end for us.
Yeah,
but,
I think
yeah,
you're done. I think we're going to stick a fork in that run, so to speak.
No,
But
sure. You can see
hey, you
that,
got
yeah.
some material dumped. You got some data. A lot of the mechanisms working well, but you're going to have to. Those are beautiful tires. Can you just scale them
just
up?
get
now?
them bigger. Exactly.
Yeah, scale them up.
Exactly. I remember when I first because I joined the team. So
Yeah.
just real quick about me. My first semester, so I'm a freshman.
Yeah.
My first semester, I had to do it abroad, so I was in Spain. So I came back my second semester, and at the Club Expo, Matt, our president, was
Yeah.
there. He was just there alone with the lunar bot. It wasn't there was no bot, and he was like, "Do you want to join Lunarbotics?" And I said, "What's that?" And he said, "We built a lunar rover." I was like, "You know what? Sure." First thing he
Yeah.
had me work on was those wheels,
wheels.
and he was like, I was like, "How big do you want them?" He said, you know, we can't. We just want them to print all at once on the 3D printer." So I was like, "So you can't do 12 inches or 6 inches, but I
Yeah.
guess we're gonna have to do 6 inches." And you know,
Well, hey, I tell
what
you
it
what,
is.
you're a freshman. That means you're going to
Yes,
be
sir.
back next year.
Yep.
Stay in touch on things.
I will. Thank you so
And-
much for having me on
yeah.
the show, Jim.
Oh, you're
have a great
welcome.
day.
You too. And you probably won't be trying to do the robot tug of war, I would imagine.
I'm telling you right now, we are.
Oh, you are?
Yes, we are. I don't know if
Okay.
we're gonna do too well, but make sure to check us out on the tug of war.
Well, maybe you'll get lucky and you'll get us, and we'll share our drive on our track, and you'll pull us around
Hey,
instead.
we'll try that out. Jim,
Okay.
thanks so much for having me.
You're welcome.
Have a great day.
You too.
So-
Take care. Okay, so that was Northeastern University Lunabotics had their run, and a whole lot of chit chat from the two of us, but nonetheless, this is why we do this. It's not only is it a lot of fun to do, but it also fulfills a major purpose of education and adventure and exploration, and kind of finding out what the next steps are going to be if we're going to be doing things like heading to the moon, staying for a long time, or getting to Mars and surviving for long stays. Because while going to the moon is technically a very difficult thing, I mean, we can get back if we need to fairly quick, but going to Mars, you're looking at least a 9-month trip to get out there and get back. And the problem is once you get there and you land, your window of opportunity to come back home again is actually a very long time. I'm not exactly sure, but one time I think I heard it was as much as 2 years before the next launch opportunity comes to leave Mars and go home. So that is a major technological jump in going places. The distance traveled too is significant. Millions of miles versus 290,000 miles to get to the moon. To give you an idea scale-wise, if the Earth were a softball and the moon were a ping pong ball, they'd be about 12 feet apart. And Mars would be a tennis ball, and at its closest point to the Earth, it'd be a quarter of a mile away. That's 1,250 feet. So you're looking at 100 times farther away than the moon at its point. And at its farthest point, it's going to be 6,000 feet away. And that's quite a travel. And just to give you another fun perspective, because I looked this up a little while ago, just curious, when they did the mission to Pluto and Pluto's distance, Pluto would be the size of a dime, and it would be 60 miles away. So you go from 6,000 feet to 60 miles. And that's quite a distance. So space has a lot of space. And we have to be thinking very carefully as we get ready to go do exploration, because there's all sorts of things that we have to be cognizant of. First is staying alive. So anyway, so thank you for watching. We have University of Minnesota up next to run, and then we'll probably be taking... Well, we're going to be taking a lunch break and then do University of Minnesota, and then we have robot games, so it should be fun. All right.
All right, hello everybody. This is Tim Kewen here from the CSM Cardinal Space Mining team. Mr. Heisey is out right now, so I'm going to start at least doing some of the commentating for the U of M robot run here. And it looks like we're loading the robot in here to start our setup time. So as soon as that hits the ground, our 10-minute timer will start. You can see the control room up there has, I think, 3 or 4 cameras up, as well as their own computers for controlling the robot. And with me, I have Graham. Welcome, Graham.
Thank you.
Great to meet you. And we're excited to see what you all can get going here. I mean, you have a promising looking robot, so it should be pretty exciting. Do you want to tell me a little bit about your robot design and how you guys came to that?
Sure. Well, a big part of what we were going for is I know last year's robot used traction to drive and scoop up material with middling success. And so our number one design criteria was having some sort of digging operation that didn't require that. And so we played around with a lot of different ideas, chain buckets, chain wheels.
Yep.
And sort of in a roundabout way ended up with this articulating chain design. We hemmed and hawed a little bit because it does have a lot of complexity.
Yeah.
But at the end of the day, it was different enough and interesting enough that we decided to go with it.
That's awesome. We, amongst our team, we didn't fully understand your design until about 3/4 of the way through your first run. We were all looking at it, trying to figure out exactly how it works, and it's a very interesting and amazing design that it all comes together and actually operates. I mean, it's a testament to your team to be able to get that to run smoothly. It's a complicated design, but the design principles make sense, and our team has been looking at what we can steal from you all throughout the competition. So
Thank you.
Yeah.
Yeah, I mean, our main concern was digging a hole that we then fall into.
oh yep. Yeah, that's one of our big concerns every year with our robot is we have a relatively deep trenching mechanism, and so we have to be careful that if you get one of the tracks stuck in it, you can kind of bottom out. And we're lucky that our tracks are pretty powerful, so we can kind of drive out of it. But I know with the wheels, they're a lot lighter and they're a lot more simple of a design, which is great for most principles, unless you're going to get kind of stuck in it, and then it can be tough to get out of a hole. So, do you know from a controls perspective what the plan is for your run today, or what you guys are looking into doing?
Well, that's not my area of expertise.
No worries.
But I do know that we made some changes, including removing the force limit for the digging mechanism.
Okay.
So, because I know there was an issue yesterday with them getting stuck and the end of the articulating actuator
Yep.
just pushing into the dirt.
Okay.
So we're hoping with a little bit more force, we'll be able to kind of overcome some of that.
Yep.
And another big change that they made was to incorporate some digging while moving.
Oh, okay. Yep. Yeah. I feel like about half of teams end up doing that, and so that's definitely a good way to get more regolith under your mining mechanism. So that'll be interesting to see how that plays out. Let's see. I'm trying to think of any other interesting things we haven't asked you all about this week. I guess how long was your build process? How long was your design process? Because I know some teams built theirs in the past week, and some teams have spent, like ours has been around for over a year now. So
Okay.
how
Yeah,
long
well,
is
that's crazy. I mean, I really want to commend anyone who can build one of these robots in a week.
Oh, it was Northeastern University. They flew their robot out in parts, and several other teams have told us a similar story, but they flew it out and then assembled it all and ordered new things. And yeah, they assembled it all at their Airbnb.
Okay.
And so yeah, it's some seriously interesting designs to end up with successful robots, which we're really excited to see. It's interesting to see how everyone gets there. I guess, yeah, when did you start your build process for
Yeah,
this
so
robot?
we spent the entirety of our fall semester doing all the design,
Yep.
Making everything in CAD, working through some of the concepts, and then right when we came back for spring semester, we started manufacturing.
Okay. Yep.
And it was a fun process because I know in the past we've relied heavily on only using water jet parts.
Yep.
And avoiding welding and avoiding machining. But this year we really wanted to make sure that we had some of our own manufacturing.
That's awesome. That's exciting to hear. I mean, one of the things that at least from my experience with Cardinal Space Mining is it's really tough to get people that are experienced with welding, experienced with some of that manufacturing processes. And so being able to build up that in a year and be able to have that expertise will help you guys going forward. Along with this year, it means you can have some more stronger designs. We stick with mostly water jetting for most of our designs just because, we don't have quite enough hands-on experience with the tool shop stuff we need. So that's awesome to hear. So you said you started in January. Do you guys have a name for your robot?
Yes, we do. Which I was not a part of this process.
Oh no.
Yes, our robot is nicknamed
gotta-
Cheese Grater.
Cheese grater. And where does that come from?
It comes from, well, if you can't see it in the picture here, but it's got kind of the digging mechanism itself sort of has the shape of a cheese
Okay.
grater.
Okay. Gotcha. Yep. So it's okay. You got your trapezoid shapes up there.
Yep,
So,
yep,
okay.
it's kind of a trapezoidal
perfect.
prism, and
Yeah.
it's got little cutters on it that,
Awesome.
you know.
Perfect.
And on top of that, the moon is also made of cheese.
Well, yeah, we all know that, right? Yeah. I'm always curious how they light the moon up at night. You know, whose spotlight is that to light the moon up? The cheese moon? I don't know.
The cheese moon, I think
Yeah.
it's the cheese sun.
Oh, you're right. The cheese sun lights it up. Okay, perfect. No, so yeah, I guess it looks like we've got 4.5 minutes left on this setup. And it looks like the controls team is doing their setup stuff. So we'll check back in when we're getting closer to the run, and we'll go through and see what's happening. Perfect.
This one too.
That might be good.
Oh, okay.
So
So why don't you tell me a little bit about Cardinal Space Mining, Tim?
yeah. So it's a club that's been around for almost as long as I've been around. I think our first year of competition was it 2009 or 2010? Do you know? Okay, somewhere around there. I may have those years wrong. So we've been around for over 15 years, and it's been kind of one of the staple engineering clubs at Iowa State. And Jim Heisey, our faculty advisor, has been the faculty advisor throughout the lifespan of the club. And he has offered so much insight into the designs. And if you look at some of our old designs, which I would love to show you, we have some downstairs that you can see which parts work from old designs, and we kind of keep them around. And it lets us really keep building on our designs year over year, which is awesome because it means you don't have to start from scratch every year. You can take the parts that worked and the parts that old teams, used 10 years ago and use that to help inspire your designs. Which is awesome from an engineering perspective because you get to learn from what works and what doesn't from the years before. And that's one of the really exciting parts about a competition like this, and what we really wanted to see is what can we learn from you all, from other teams, and what can you learn from us. And it's been exciting to see some of the successful runs and see what works there, and some of the ones where you know what to avoid for next year. And yeah,
Do you guys get involved in other activities besides Lunabotics?
so our space mining team here, Cardinal Space Mining, is exclusively for the Lunabotics competition. We also have a robotics club here at Iowa State that does battle bots and autonomous snowplow. I'm not sure. I don't know if there's any other competitions they're in, but those are the two that I know and I've seen them work on and
Okay.
compete on.
But so strictly Lunabotics.
Yep. And I think you all, your shirts at least show that your U of M robotics team has multiple different competitions, correct?
Yes. Yep.
Which-
I know. Well, I know the names of them, and that's about all I know. So yeah, we've got RoboMasters, which I think is like it's like a first-person shooter type thing where you get multiple robots and they get different abilities and they drive around an arena and
Sure. Is
shoot
that-
at each other.
Is that like sponsored by Lockheed Martin or something? Oh, DGI. Okay, cool.
Okay.
Cool.
And then and then we have VexU, which I don't know what they do at all.
Yep.
Okay.
Okay. So it's like First Robotics, but smaller. Okay.
Yep. And
So
then,
are those? I know Vex is a robotics platform that you can build. Does it use the Vex platform for the? Okay, mechanical assembly. Okay, yeah. For those of you that are unfamiliar with the Vex system, it's an easy to build, like pre-built, almost building block style manufacturing thing that lets you mess around with and play with different designs without having to know welding or water jetting, and it is a lower cost of entry in terms of manufacturing your designs, which means you can have more interesting and unique designs with it. So
Yeah, and then the last one is RI 3D, robot in 3 days.
wait, so does the team have to build a robot in 3 days or? Oh, okay. Gotcha. That makes sense. Okay.
The first
Wow.
robotics robot. There
That's
you
pretty
go.
cool. So then I have a question just for logistically, or if you're in the U of M robotics club, are you able to join any of them, be parts of all of them, or and are
Yes.
people usually a part of just one, or how does that usually work?
Yeah, I think it's usually just one just because of the time commitment.
Okay, yeah, that makes
Um,
sense.
But, we all tend to use the same spaces and interact. So,
Awesome. And then if we check back to the run that you all have coming up right now, it looks like we've just finished the setup phase. So we are starting that 30-minute timer coming up here, and we'll see what you all can dig up here. It should be pretty exciting. Let's see. I don't think we've started it yet, so maybe we're having communication issues, or have we heard anything yet, or are we just waiting to see the start there? Okay, nothing coming through to us yet, so hopefully we're good to go. It looks like we're radioing in. We've had a few technical difficulties. It's our first year running this, and so we had to replace one of our fiber lines overnight, and
Okay.
we've had some fun little hiccups throughout the thing, but hopefully it should be all good to go.
Well, we definitely appreciate you guys hosting this. It really took the wind out of our sails when we were expecting to,
Oh.
participate in the NASA program and
Yep. Yeah, no, it took it's been a headache for us when we realized we went from tying for first place last year and now we're not even at NASA. So it's been great to have something else to focus on and something productive to be able to help everyone else out with and help ourselves with. So
we certainly appreciate it.
yep. So it looks like we've started our timer here. So we have the 30-minute traversal mining and deposition time here. And for those of you that are checking in for this first run, you start in the start zone and you move through the traversal area, and then there's a mining zone and the deposition berm. And the deposition berm is what is visible in the lower left picture here, outlined in blue chalk powder. And that is where the team will deposit, U of M here will deposit their regolith, and it will be measured with a 3D depth camera for volume. So look at that. You guys are moving pretty quick. That's
We are moving.
looking good. Do you have any risks? Oh, nice rock hit there. That's good. Do you have any areas of concern that you all are worried about? Do you know?
I'm a little bit concerned about the camera that just was used as a plow for the rock.
You have a camera on that front area there. Oh, that might need replacing, or maybe a good wiping off. Interesting. Do you know? Are you all trying to run autonomy or?
Yes.
Okay, so this would possibly be the autonomy phase, and that may explain the issues you're running into, or the rocks you're running into, rather.
Yes.
Gotcha. Interesting. We'll see. I wonder if they'll take it off autonomy. It looks like there's hands on a keyboard there, so maybe they're switching from autonomy back to controlled mode.
I think that might be the play here.
Yeah, we'll see. But interesting. It was moving quick for a minute there, and then maybe some obstacle detection went wrong or something. I'm not sure. But it looks like we're moving cameras around there as well, trying to get different views. I'm not sure if that camera view is one of yours over on that far screen or one of ours, but
So the views we're looking at here, do they have access to these same?
yep. So all of these cameras we're looking at here we have 4 arena cameras. For a little bit of information for you, Graham, we have 4 arena cameras, and one of them is a pan tilt zoom, meaning you can look around and see just about every part of the arena except for straight below it. And so that would be this bottom right camera here. And then the other, they have 3 others, and that would be, I think, bottom left and top right plus another. And so that's the control center will have those views. Plus, it sounds like you may have a camera or 2 on your robot that you could be looking at. So yep, we can see the pan tilt zoom moving as they're trying to get a better view of what's going on.
Which it looks like we've dug ourselves into quite the hole here.
Possibly that right rear tire looks like it may be getting stuck, and that's one of the real challenges with regolith and regolith simulants. The moon can be extremely fluffed up, and as you saw before the run, the judges were in there fluffing it up, which is great for if you're trying to mine it, but it's very difficult to traverse in and navigate in, and that's one of the issues that wheels can run into. They have a lower surface area than other sleds or tracks, that sort of thing.
Yep, and now it looks like they're attempting to dig out some of the material under the robot in hopes of maybe getting unstuck.
Yeah, so digging out underneath so you're not stuck on the interesting. Yeah, it looks like the wheels are spinning there trying to get out.
And I'm thinking that maybe if they push down with the arm,
Yep.
it might move up.
There we go.
some
Get a
of the
little bit of
pressure.
movement.
Yep.
Yeah, this is where if we were able to access the arena and runs, you'd go grab your tow cable and attach it to your truck. But
Yes.
so it looks like, yeah, it looks like they're digging out maybe a little bit of movement. I'm hoping you all can get out of this. It's ooh, that rock is in a tough spot for you there because it's also going to be pinching your front up.
Well, and it appears that we're actually up on top of the rock.
Mm-hmm. Yeah, it's interesting, and I can't tell do you have is one of your controls member there have a controller in their hand? Does it look like?
It does appear to be
Okay.
that way.
Yep. So we're no longer in autonomy mode. We're just you all are trying to get unstuck, and it looks like yep. So we're switching to another camera. Thank you for that, Connor. Connor's been running our live stream for CoSMiC and has been really helping us with the production quality and helping us see what's going on. And yeah, oh, there we go. We're getting out. If you look at that,
Okay,
the
we're
top
off
right
the
camera,
rock.
you're off the rock and you're moving. Woohoo! We're getting cheers and a roar of cheering here from the U of M team in the Student Innovation Center at Iowa State. Look at that, and now yep. So it
We're
looks
off
like
to the races.
if you were to guess, do you think that would be the autonomy that ran you into the rock? And yeah.
Certainly.
Okay. Awesome. Perfect. So yeah, let's hope some nice navigation. Yeah, and you can see really how deep you're sinking just from the powdered. We're using ag lime as our regolith simulant here at CoSMiC, and it has the similar particle sizes to NASA's BP1 as well, which is based off of real lunar regolith, and it's similar, and so you get similar properties with the fluidity of it and the densities. So it can get really compacted down, almost like concrete, where it's heavy and dense, and it also can get very loose, and that is what can cause issues with traversing on it. And that's one of the real challenges of the Lunobotics competition. When you all were designing this robot, what were some of your major design considerations that you were really looking for and really targeting to look at this year?
Sure. Well, like I said, our first design constraint was not using traction as a digging method. Another thing that we really wanted to do was prioritize making it as light as possible.
Yep.
And
Sorry to interrupt, but I'm assuming you're doing that because of the scoring considerations.
exactly.
Okay, for those of you unfamiliar, the way that CoSMiC and other Lunobotics competitions are set up, scoring the amount of regolith you mine is then normalized or divided by the mass of the robot plus energy usage, and energy usage tends to be tied with the weight of a robot, meaning that if you have a lighter robot, you will tend to score better just based off of those factors. So you're targeting a light robot, and what else you were saying?
Another major consideration of ours was trying to carry as much material as possible. So with that dump box we have there, and originally we were thinking, we would extend our digging arm downward, and so we wanted to kind of match up how much volume that swing arm
Would hit
would
during
cross
that. Yep,
over with
yep.
how large the bucket was.
Yeah. And so were you all doing that when you were doing that math, was it with simulations, or was it just hand paper, CAD design with your preliminary designs? I'm just curious what your process looked like.
Yeah. So we actually, I mean, we used SolidWorks to design the entire robot, and we basically just swung it down and used that swing area that
Yep.
we calculated from SolidWorks to figure out how large the bucket needed to be.
Okay. And so it looks like, are you doing your mining phase here? I think I'm seeing some movement under the robot. Is that what's happening here?
Yes.
Yep. And so if you were to guess, how long does that mining phase usually take per sortie or per cycle?
I would say probably 2 to 3 minutes.
Okay. So we're well within your estimation. Oh, and there we go. It looks like we're moving that rear bucket.
Okay, and
Are you dumping early there? Is that what's happening? I'm just curious.
that does appear to be what's happening.
Okay. Interesting.
Yeah, you win some, you lose some.
It's a learning process, and that's one of the great things about Lunobotics, and one of the great things about this CoSMiC competition is it gives us all an opportunity to learn. Definitely, we had some learning. I don't know if you saw any of the Cardinal Space Mining runs, but we did some serious learning and not much scoring is kind of where we ended up, which is great for next year. We're really excited to have the data we capture, that sort of thing. But interesting. Okay, so it looks like maybe there's still some regolith in your hopper back there.
Sure. Well, I think maybe they're setting up a ramp so that when we build our berm up really, really high, we can come
Okay.
at the ramp and make it to the top.
Okay, yeah. So yeah, a little bit of construction to let you get up there. That's one of those design considerations that I don't know if you saw New Mexico Tech's run from yesterday, but I think by the end of their run, the height of the berm was taller than the robot, so they had to drive up part of the berm to deposit more. And so
Yes.
it's that is definitely an approach. It is interesting. One of the concerns with the regolith is if you try that, you are driving over the stuff you've deposited in that berm, which is a concern because that's how you get scored, and so you're compressing it and compacting it down. But interesting. And so are you all mining again? Is that what it looks like there?
It does look like they're digging again here.
Awesome. Yeah, and I think if we look at that, yeah, it looks like maybe there's a little bit of a deposition line between the rock and the robot there that you all did drop a little bit from that hopper. Do you know the volume of your hopper there? If you were to guess, I'm it's okay if that's not
Does anyone here
memorized.
know the volume of our hopper?
Okay.
Nope.
Perfect. No worries. I was just curious because it sounded like you all did a little bit of math on that, but that's no worries. I don't think anyone on any teams has everything memorized. So that was no, you're no worries. Usually one person does the math and then someone double checks it and then no one touches it again. So you know.
And that would absolutely be our brilliant mechanical lead, Alex Reed.
Awesome. Well, and I would love to chat with him later, or if you have insight into this. The hopper door, we call it a hopper. Is that a term you all use, or what?
The dump box.
Okay, the dump box. Perfect. That door mechanism where I think it's static relative to the drivetrain, and then it looks like the box moves, and that's how you do your dump. Correct?
Yes. Yep. So we use a linear actuator to lift the box, and then we have a linkage system set up that opens the gate to the dump box while we dump, which was inspired by like a mining truck.
Okay, yeah. Interesting. No, I don't know if I've ever seen that design on anything, and it really is a very simple and elegant solution for the problem. A lot of teams will have more complicated solutions, and like ours is pretty messy, and we use magnets. The door swings open all the time, and that sort of. And so it's a very elegant solution that you all have with that we've definitely been eyeing as. And there we go. Yep. So now we're gonna watch that dump, from the dump box there, and yeah, look at that pour out. Perfect.
Awesome.
Looks like we're starting to berm. That's exciting. That'll be some points scored. So for those of you online, anything in that blue zone will be measured, and we have a before and after volume photo, and anything in that will be scored relative to some of the weights of the robot and the energy used. So that's really exciting to see. And anytime you can navigate successfully to the berm building zone and get anything in there, I consider it to be a successful run. That's 90% of the challenge. So
I'm certainly happy to see it, especially and it looks
after
like
getting stuck on the rock, that's an
Yes.
exciting recovery there.
Yep. But yeah, and watching this run from here, I'm starting to see that a change we'll be making for next year is absolutely some wheels that have a little more traction.
Yeah. Okay.
I saw that some other teams had some fins
Yep.
on their wheels.
Yeah, and that really will help you if you have the area there. It helps you dig in and get moving, which is a great consideration. And I think one of the other challenges is balancing the weight of the robot with the wheel surface area. And some teams end up with very large wheels to have larger surface area. And one of the challenges, the larger your robot is, the easier it is to move large amounts of regolith. But then you sink more and you lose points for the size of your berm relative to the size of your berm. And so there's a lot of design considerations to look into, but I think the aluminum fins that we've seen on several of the robots here definitely are something that I would look at for this, just because it would reduce your chance of getting stuck.
Absolutely. And for us, we spent a lot of time developing the articulating bucket chain system as well as the dump box.
Yeah.
And so we ended up using a version of a wheel design from the last few years.
Yep.
Uh-oh.
Looks like we may be dumping a little short. Oof. So
Nice try.
some of it got in there, but yeah. Hopefully it'll get measured in our berm building area there. But one of the interesting things is there's a little bit of camera latency, about 3/4 of a second to a second with the camera latency.
Okay.
And so that may cause some of the issues we're seeing with the precise navigation can be difficult.
Now, is that intentional? I was
Can
gonna say it'd be a
we
really.
say that we're simulating the moon? No, and
That's kind of what I was thinking.
that's in previous competitions down in Florida. That is what a lot of the excuse is from different groups. But in reality, it's It's just that you're passing a large amount of data, and the cameras we're using are essentially off-the-shelf security cameras. They're surplus security cameras, and so that's where they maybe not the best suited cameras. And so if we run this again, we would definitely go out there and spend the dimes to get a nice camera solution.
Sure.
And we've been having some nice issues with the pan tilt zoom camera. It has some poor software where it's tough to work, and sometimes you just got to go unplug it and replug it in. And so, yep.
Classic.
Yeah, no, and that's the funny part about all this engineering is we do a ton of math, do a ton of design, and at the end of the day, most of the problems can be solved by just unplugging and replugging things. So that was, speaking of unplugging and replugging, the Cardinal Space Mining first run, which was the first run of the competition. We'd stayed up multiple nights in a row, as I'm assuming you all have done, which is the nature of the competition, and we forgot to plug in our linear actuators, meaning our mining mechanism couldn't dive into the ground. And so we ran into issues with that. Have you all had anything like that during your competition run this year, or have you faced that in the past?
Well, I wasn't here yesterday, but I did hear we had some autonomy issues yesterday
Yeah.
where we spent a good amount of our time idling.
Oh, nice. Yeah.
And, due to whatever reason, didn't realize it for a little bit, but,
Yep.
Luckily we were able to get up and running and,
Yep.
and get some material in there.
Yep. Yeah, the autonomy, there's significant reward in the points for autonomy, and so it means it's a great pie in the sky to reach for, but it also can be very difficult.
Certainly. Well, and I'm looking at that rock right there. That thing
Oh,
That thing was perfectly suited to thwart our efforts for
Yeah,
autonomy.
we'll have to make sure we tell the arena judges in there that they did a great job placing that rock to thwart your run there.
They
but-
certainly did. I
Yeah.
mean, I can see now that it was an effort at sabotage,
Oh, for sure.
and
No.
I don't blame you.
Yeah. No, yeah, that's great to hear. And actually that last deposition there, it looks like that last dump looks like we got some more in the dump zone, so that's good to see. Hopefully that'll increase your score and give you guys some more information to run off of. Do you know, are you recording any for autonomy for next year? Do you record any of your data and look back at it from your runs?
Absolutely.
Yeah. So what sort of navigation systems are you using for autonomy? Do you know?
Yeah. Well, we're using. Hey, what kind of cameras do we have? Our depth cameras. The Z, yeah. 2 Zs.
Okay. Yep. So you have two depth cameras, and those
Yep.
you use those to measure distance to things, I'm assuming.
Yep.
Okay. And what is your if you're not 100% on this, Graham, I know this isn't your area. But what is your software solution to handle that information and process that? Do you use ROS or what software solution? We can wave someone else
That
in
is a great question. Yeah. Does someone else here have some knowledge about how the software works?
for the autonomy, I'm just curious what software you all run for your autonomy. Okay, so you're using ROS too. Yep,
ROS.
and that tends to be a pretty common solution for most robotics. For those of you online, ROS stands for Robot Operating System, and it is an embedded operating system you use to control robots. And most teams tend to run something similar to that. And it's really easy to get up and running, but it's really good or really hard to get a good solution going. And it makes sense that you all, if you're trying autonomy, and it looks like you had a pretty good autonomy run there to navigate, it makes sense that you're using ROS. It's really customizable and gets a lot of different parameters you can control and different things you can do. Yeah, that's
Well, and I know from my side of things, I think autonomy is a great thing to shoot for. But I know, when we're looking at coming up with our design for next year,
Yep.
We're gonna take a big look. I mean, I know that, the robot design, the emulating a skid loader
yes.
was,
Yep.
it at least makes me think, well,
No, yeah.
there's a reason that construction equipment on Earth looks the way
Looks the
that
same
it
with
does.
us. No, we had the exact same conversation after that run where there were 4 or 5 of us, including Mr. Heisey, our faculty advisor, who saw that run from New Mexico Tech, and we all looked at each other kind of mouth open like, whoa, that changes just about everything. And we have historically, Iowa State, we've been around for several years, and historically we've been using the similar bucket ladder designs. We have some robots from I think the 2017 downstairs that use a similar design. Obviously, we changed dimensions, remodify it for the exact application, but a similar bucket ladder design. And now, after seeing yesterday's run from New Mexico Tech and some of the stuff out of NASA's finals competition, we are really looking at whether we need to come back to the drawing board and do some more math and see whether it's a viable solution. And one of the things about the scoop construction style is it's very difficult to do autonomously because you are moving a scoop in front of your sensors, and then it's difficult. You have to know the angle to scoop at relative to the ground, and so there's a lot of design considerations. And so it'll be interesting to see if after this year's set of robots, whether the autonomy will continue to develop with that type of robot, or if it'll be more to the bucket approach or the scoop approach that you all are using and that we use, which seems to be more suited for autonomy.
I would agree.
Than the large scoop. But I don't know. Do you have any thoughts on that, or what are your
I mean,
considerations?
you took the words right out of my mouth. I mean, I think that is a great design. I mean, especially if you have someone who's familiar with operating that kind of equipment.
Oh yeah, yep.
But I find it. I mean, I think it's certainly possible to make that kind of operation autonomous, but
Yep. And no, there's a
it seems
reason.
very challenging.
100%. Yeah, there's a reason that Caterpillar has a group that exclusively does autonomy for that sort of equipment. It's a very difficult set of controls, where if you look inside of some of those more complex skid loader styles, you have several joysticks that all have different axes and buttons and that sort of thing. And I've never driven one, but I know that they take a while to learn. But once you learn them, you can place, a penny on another penny vertically, sort of thing. I've
Yes.
seen videos of that sort of thing.
Yeah, absolutely.
So-
Yeah, the people who are good at operating that kind of equipment, it almost is like it becomes an extension of you.
Yep.
But with that, I mean, it's that you have that human element of
Yep.
being able to see everything and operate those controls.
Yep. So go ahead and explain. Are we doing some more mining here before we do another deposition, or if you were to put yourself in the control room here, what do you think is happening?
Yes, it does appear to be what's going on. I can see on the front side of the robot there, the buckets
Yep, the
making
buckets
their
moving.
rotation.
So yeah, and we're just doing another 1
Mhm.
to 2 minute sortie there of mining, and then we'll hopefully see some movement back towards the berm zone.
Mm-hmm.
I don't know. Do you have any initial thoughts as you've watched the first 20 minutes of this run?
Well, one thought that I have is that, I mean, I can see as our bucket system goes down, it seems to push a lot of material forward.
Yeah.
I almost think we would have had more luck turning the thing around.
So I'm pushing into the berm as you're digging.
and using the robot as a
Yep.
rake
Yeah, no, that's an interesting approach.
rather than a scoop.
There we go. Looks like we're in a good
All
place
right,
for this drop.
a little
hopefully.
more.
Yeah, We don't have a camera on us right now, but Graham is sitting there waving in the robot like he's waving in an airplane or backing in a truck there. So that's kind of what yeah.
Oh, nice job.
That's a great drop. Awesome. No, it's fun to see. I think spectating from outside of the control room, it's a lot lower stress because you don't have to make any decisions. But at the same time, you wish you could help some of the time and say, no, back it up a little more, sort of thing. So
Yep, I'm sending them my brain waves from
Yeah.
across the
Yeah,
building
yeah.
here.
good vibes into the Yep. And so for those of you who haven't walked around our setup here, we have the control room is across the building from the arena. And so they are separated from the judges who have seen the arena, or from the members who placed the robot, and separated from the rest of the team. And you can have up to 4 people in that control room. And so right now it looks like you all have 3 in there, and they are in charge of making the decisions and driving the robot, which is a lot of responsibility, and I think can be really stressful. I know that when our members leave after their runs, they are pretty tired, pretty worn out, just because it's a lot of pressure.
Certainly. Well, and I know they can't hear me right now, but if they could, I would say, whatever you do is great, and I'm happy that you're the one there and not me.
Yeah, and they've done a great job so far of getting material into the berm. It's exciting to see. Anytime you can successfully complete the challenge in some level, that's exciting to see. And there hasn't been any mechanical or software failures, which is usually, I mean, about 1 in 2 runs, maybe even 2 and 3 runs in a Lunar competition, the team will break down within the first 10 minutes. So this has been a very successful run in terms of resilience and maneuvering.
Oh,
And-
absolutely.
yeah.
Well, and I would specifically point out the rock hit at the beginning.
100%.
I mean, that could have ended the run right there.
Yep. No, and we've seen stuff like that end runs and the fact that nothing broke mechanically. You said that maybe we collided there with a camera, and the fact that the robot's still running and still able to keep doing the mission is the sort of resiliency you look for in remote robotics. You know, in the real applications, if you were up on the moon or up on Mars, you wouldn't have the opportunity to go in there with your tools and fix it. So having a resilient robot that's able to get itself out of situations and keep working on the mission is really exciting to see. And I think that's kind of what the competition's all about, and that's why a 30-minute run really lends itself to that style of resiliency. And yeah.
So do you think that that ISU would consider hosting another competition like this in the future?
We've heard this question several times from several different sources, and we have really enjoyed the opportunity to do this. But one of the things that it's been a big task for our club, and we're an engineering club at our heart. You know, we want to build a robot, and we want to compete with our robot. And so if someone at the university or another university is interested in doing it, we would love to support them in any way we can. But at the same time, we want to make sure we're still able to compete with our robot. And so like this year, we were so busy running this that we didn't do much redesign on our robot. And mechanically, it's almost the exact same. So yeah, that's our first goal for next year, is to make sure we are able to build a robot that we're able to compete with and run with. But at the same time, we've heard really good feedback from teams, and it's been really fun to have you all here. And I think our university's been happy to show off our campus. We've got some great facilities around here, and it's fun to show everyone, because what's normally, you may be able to test this, but what you use day to day as an engineer, you think, oh, this is normal, and then people come in and their jaw drops, and you forget that how fortunate you are to have some of the facilities you have.
Absolutely. Well, I know we're thankful as Minnesotans to instead of having to drive to Florida, drive to Iowa.
No, and that's 100%. I walked from my apartment here today instead of having to drive down to Florida. I was able to walk from my apartment to the arena, which was very, very nice for me. So no, that's one of the great benefits. What's interesting is we talk about traveling down to Florida, and it's expensive for us to do, but some of the teams that came out here, I know Creed, for example, from San Diego State, they flew from San Diego to Ames, Iowa, and that's almost, I think, is about as expensive of a trip as getting from Iowa to Florida is. And so we've been fortunate that teams have been so willing to come here and trust us to put on a competition, which has been exciting. And I think we've had our hiccups. You know, it's our first time running a competition, but it's gone relatively well. There we go. We're back in the burn zone. Awesome. Hoping we get some more drop here. So we've got 4 minutes left, which means maybe there's time for one more dig sortie here if we can get this dropped soon.
Yeah, and it looks like they're trying to get a little further back.
Yep, that looks good, I think. Hopefully, yeah. And we've got the rear dump box. Looks like it's moving, and hopefully the regolith's coming out. So are you all relying on gravity to drop all the regolith out there? It looks like you get to a pretty steep 45, 50-degree angle there, right?
So we at first we were only relying on gravity, and then during some of our tests just using sand, we noticed that there was a lot of material sticking in the bucket.
Okay.
So that was one of our very last mechanical additions, was actually a mechanical agitator on the bucket.
Oh, okay. So vibrating?
Yep.
Then? Okay. Yep.
Exactly.
Yeah, that makes sense. That I think was it. UND Lunabotics has a 24-volt vibrating motor that you'll have to hear it run if they're around. It is 100 decibels. It shakes the walls. So it's small. Probably yours is a fair bit smaller, but we've seen success from some of the NASA runs on teams to vibrate to help turn the solid regolith into more of a fluid. It's which is an interesting mechanic and something that is complicated to deal with, but I think makes sense for the dump design here.
Yeah, absolutely. Yeah, I would wonder how you could combine something like that with maybe a scooping mechanism.
Yeah, and that's what we've talked about, is can you vibrate the scoop and get some more volume and make it easier to dig deeper in the regolith. And one of the struggles with these regolith simulants is, as we were talking about, they get dense, they get compacted down, and so if you get to a certain layer, it gets to be pretty dense and it gets to be hard to dig through. And so if you could loosen it up a little with that vibrational motor, you may be able to get deeper and get more out of a single scoop, which would be awesome. So yeah, we've been looking at some of the designs for next year. We've been looking at some of what Caterpillar does and what the real construction equipment does, and looking into the design considerations, because you see construction equipment around and you see things in your day-to-day life, and you don't really do an engineering analysis on it. And so once you look at it and say, why is that running this way? Why do they use the actuator in that direction? Why are the hydraulics set up like this? there's a lot to learn, and I don't know, have you done any research into that, or are you in the same point where we are?
Yeah, well, I actually, before I started as a student at the University of Minnesota, I worked in construction
Oh, so there we
and
go.
the civil engineering field
Okay.
for the last 10 years.
Wow, so then you know everything there is. Wow, you're gonna come back
No,
next year with,
not even close, not even close. But it was actually construction equipment. Being on job sites,
Yep.
I would be standing there and I was supposed to watch the construction,
Yep.
but I would be far more interested in looking at the cranes and excavators.
Yep. No, I'm with you. Yeah, that's funny. Yeah, no, there's sometimes you see a crane or construction stuff and you just kind of sit and watch if you have the time. That's the engineer in us for sure. So, and what are you studying, Graham?
Mechanical engineering.
Mechanical engineering. Awesome. Gotcha. That's kind of the do it all of engineering is from what I've
Absolutely.
gathered. Do you know how's your team divided in terms of discipline?
Yeah, so we have, I would say the largest team is software.
Okay.
You
Yep.
know,
Same with us. Yeah.
Computer science is a really popular major.
Yep.
And then second in size with, so maybe software is 12 people.
Yep. Out of 25
Yep.
ish. Okay.
Mechanical is perhaps 8
Yep.
or 9,
Okay.
and then electrical is our smallest team
Yep.
with 4 or 5.
All right, so we've got 38 seconds here. It looks like they finished the mining and they're going into the berm zone. And if they get it dumped before the 0 second on that clock in the control room, it counts. Otherwise, they'll have to move the robot forward, and it won't. I'm thinking they should have enough time here for this
Looks
last
like
dump,
we're gonna get it.
which is awesome for you all and should definitely help your score here. Look at that. There it goes. Awesome. That's exciting to see.
Nice job.
I think this has been actually a very successful run for you all, and I'm excited for you all to have been able to recover from that initial bump on the rock there. I think that shows a great design to be able to overcome obstacles, literal obstacles, and yeah. So
Thank you.
that's exciting.
Well, and I want to say I'm very proud of our operators there. They did a great
Yeah.
job.
Yeah, no, we'll see if we can interview one of them after this to hear their thoughts. And I'm assuming it was the autonomy that caused that initial bump,
Yes.
and then
Yep.
So that's exciting to see. And it looks like now with the operators are going to drive the robot away from the entrance door, and then some of your team members will come in and hit the E stop, which will stop the robot and allow safe movement of the robot. And then we'll also check the power usage for it, as that is used in the scoring. So should be a pretty standard procedure here, and I think everyone's kind of getting used to it as we get further into it, which is
Just in time for the last run.
I know, right? Yeah, no, and, yep. So yeah, which is it's always fun to get used to it, and then it goes away for a year, and you have to relearn for next year. But and coming up for anyone on the live stream and for you all, Graham, is we have a little bit of time in our schedule before we do our closing ceremony with our award banquet. We are thinking we're going to do some robot games where one of the things that NASA did in the past that we think is pretty fun is if there's extra time in the schedule, you do stuff with your robot that you wouldn't normally do with something you want to compete with. So now our robots are done and we're talking about future designs. And so maybe we'll do some robot drag races, or tug of war is one that's a common one we've seen. And so we're looking into that. I don't know, is that something you all are interested in doing with this robot?
I think we're planning on participating.
perfect.
I think at least when it comes to tug of war, our focus on making the robot light is going to work against us.
Yes, yep. Yeah, no, and ours is a heavy tank tread style, so that's definitely gonna be beneficial for Iowa State's robot there, but awesome. Yeah, so that should be exciting. We'll see. And we're planning on keeping the live stream up for that, I think. Let me check with our live stream operator here. We are keeping for the live stream up for the robot games, correct? Okay. So you all, if you're online, you'll be able to see a little bit of chaos, and as we decide what's going on, we'll make sure we're broadcasting it, because hopefully some fun things happen, and it's stuff you wouldn't normally see out of a Lunabot. And it looks like the control room members are getting up here, and hopefully we'll see them coming out, and maybe we can grab one for an interview.
Yeah, that would be great.
Awesome. Well, thank you very much, Graham. I appreciate it, and congratulations to your team. This was a really exciting run, and really shows a great development in your program this year. So
Thank you
congratulations.
very much. It was a pleasure, Tim.
All right, hello. I'm with Peter here from U of M, and you just finished your run there. It looks like there were at the beginning there was a little hiccup with this rock in the corner bottom right thing you can see there. Can you tell me what happened? Was that autonomy that drove into there, or driver error, or what happened?
So, in setup, no one else on the team besides the people in the control room know this yet, but during setup, we were launching everything, and the GPU on our computer was not being detected.
Oh wow.
So, the front camera does not relies on the GPU being like, we have a Z on the front camera, that's how we used to drive, and that gets launched, and that requires the NVIDIA GPU and the Jetson AGX on to work.
Okay.
So, because the GPU wasn't being detected, the Z camera would not come on, and we could not get the video camera stream off of that Z camera,
Oh wow.
which means we did not have any way of seeing what was in front of us.
Oh my goodness. So wait, correct, do you have a discrete GPU? And for those of you online who are not in the computer world, GPU stands for graphical processing unit. And so that's what they're using to process that camera feed in their robot. Do you have a distinct one, or is that built into your
Built in. So
Jetson
we
there?
use
Okay.
a Jetson AGX on developer unit.
Yep.
It's
Yep.
yeah.
Yep. So again, little explanation for those of you who are not tied into the robotics world. Jetsons is an NVIDIA line of products, and they're using it's a small computer that is designed for robotics processing, and so it has a built-in graphical processing. And it sounds like, was it disabled, or what? Do you have any idea? You're gonna go autopsy it?
We're gonna go look, see if we can't replicate it.
Yeah.
We did not have this issue at all in the future. Anytime we're using this robot, and it was just like we were launching it, and it was like, oh.
It's not there.
And we even rebooted the Jetson because it was like reboot, and that still didn't fix it. So it was just
Interesting.
kind of go off. Luckily, there was like all of autonomy kind of relies on the GPU, and only the one Z camera relies on it.
Okay.
Everything else.
So you were able to use. I think I heard. Do you have two depth cameras? So one Z. Is it two Zs, or was that?
So
Can you explain what other sensors did you use to navigate
yeah,
after that?
we did turn on the pan tilt zoom arena camera. You might have
Okay.
seen us moving
Yep.
it around to the
Yep.
lower right hand one.
Mhm.
Once we were stuck on that rock, and we were like, we're not moving. What's going on? So I'm like, we need to turn on the arena cam to see. So we took the 60 points for use that we
Yeah.
didn't want to do,
Yep.
but it was worth it to get unstuck
Oh,
from the
yes.
rock.
Okay, that makes sense. Yeah, no, we weren't sure what was going on. We weren't sure if you were trying to run your autonomy and it ran into the rock, but it sounds like you were just kind of driving blind for a minute there.
Yeah.
Yep.
It was we had like all of the other 5 cameras in the robot working fine. We realized we could have driven backwards because we have a back cam.
Oh, okay.
The front cam wasn't working, and we were like, we should have just turned around and drove
Yep.
backwards. But
Okay. Yep. Yeah, and so for those of you who are unfamiliar with the scoring, as we were talking about, there's a 60-point deduction for using each camera you use out of the 4 in the arena. So the pan tilt zoom camera in that bottom right corner is probably the best of the 4, because you can control the angle. And so it sounds like after you ran into that issue, you were able to turn that on and use that to help guide your navigation and get unstuck. Did you run into? I noticed when you all were on the rock, you started to wiggle and spin a little bit. Did you, once you lifted your front up, were you kind of stuck in the regolith? Or
we
what
were
happened
kind
there?
of stuck. Yeah, with only the 2 back wheels, we didn't have enough force to bring ourselves off of it. So the back wheels, I also noticed later on when the back wheels were like completely covered in regolith.
Yep.
So they were not getting any traction. So
Yep.
eventually we were able to like wiggle off somehow.
Yeah.
I don't know how.
And I saw, did you run the trenching motor there to try? Okay, yeah, no, I saw that. And so, yeah, it looked like we were watching. It looked like you turned on the trenching or the digging mechanism, and it was able to maybe help get your bottom unstuck of the bottom of the
Yeah,
robot there.
we tried to like lower it down and maybe lift our robo up, which like is not designed to do that, but
No.
we were stuck
Well,
at that point.
And,
so
and yeah, in competition, you got to risk a little bit of the,
Yes.
the mechanical design there, and yeah, that's awesome. I mean, it was an impressive resiliency from the control room. I can't imagine how stressed the 3 of you all were. It's that moment of the entire team is there, and watching this, and I need to make sure I can perform.
and we had
properly,
never
so.
seen this issue before. It was just
No,
like
I would love to hear what happened. It's really interesting after this. I would love if you all discovered, let us know.
we'll send a message or something.
Yeah, no, and we're looking into future compute solutions, and we keep hearing everyone's computers, their computers, you get bugs and that sort of thing, and it's always difficult to anticipate this sort of thing, and usually it's impossible to anticipate
Yes.
it. So, and then actually I have some controls questions for you
Go
that
ahead.
that I had said during. So it sounds like you all are running ROS 2 maybe.
Yes.
And I guess, have you written all of that ROS yourself, or what is your process? What is your software built upon? How have you developed that?
So we use ROS 2 humble
Yep.
version. It gives us it gives us a backbone of you build nodes. The nodes can then communicate with each other
Yep.
and on topics and publish. we've then built almost all of the nodes that we use. There was some like open source nodes we found. Like CAN bus communication. There was something that was already built. We just used that.
Yep.
The main ones that we've added is there's like everything we use, and then we've also the reason we have the Jetson is so we can use NVIDIA's Isaac ROS packages. So then those all rely on an NVIDIA GPU to work. So any of those just did not run during this process run because we didn't have the GPU.
So you're missing a big block of that. Yep. So I'm going to go ahead and, for those of you who are not in the software ROS world, what that means is ROS, Robot Operating System. I mentioned that earlier, but Robot Operating System is a development platform for robotics, and most robotics teams tend to use that. And NVIDIA Isaac, NVIDIA the graphical company, graphics card company, and now AI company, they have a set. It's called Isaac, and it's a robotics software library. So you can pick and choose different things from it, and it's by far and away the best option for most autonomy.
Yeah.
And the only requirement to use it is that you're using an NVIDIA processor. And so it requires the Jetson to run or a different NVIDIA processor. And so it's interesting that I imagine you had a lot of autonomy and a lot of navigation software that wouldn't run.
I mean, if you remember the auto dig, we had to dig right on the edge of the boom zone because it would usually back up, but the backup is run by nav2, and nav2 relies on the NVIDIA Jetson.
Yes. Okay.
So
and that's what Graham and I were curious, because that first dump on the edge of the berm zone didn't quite get into the berm zone, and I imagine it's because it was behaving differently.
Well, yeah. So we tried it the very first time we tried it. We were out like in the dig zone that we normally, and that's what we plan to do is back up to the boom zone. But then the second one was like, okay, how close can we get to the boom zone, still following the rules, and be able to dump and get the autonomy points? Because we really wanted those autonomy points.
No, and it ended up working out, I think. So that was impressive, and it was an impressive run to overcome some of the things it sounds like you ran into, and I think that's what Ludobox is all about, and that's why it's exciting to be able to compete. Coming up after this, we are planning the robot games, so I'm excited to see what you all can do there.
We're hoping to compete in tug of war, so we'll see.
And we also are thinking maybe robot racing, and possibly the one I've been pitching is robot sumo wrestling, where you get a circle. I don't know, we'll see. So we would love to talk with you all and learn what you all are interested in. But thank you very much, and congratulations on the run.
Thank you.
I know that it's been done at NASA, and I'm not sure if UCF has run it like this, but I know NASA's done this before, and it's a fun video to see, and it's a fun thing to compare the torque and the mass of the different robots. And it's something that you wouldn't normally do with your robot that you designed for space mining, and so it's fun to kind of find another purpose for it. So
Yep. It's kind of funny watching them back there. You normally have them all like one team just super concentrated around
Yep.
a single monitor, and now you have everybody over there.
Yep. No, it's
just
fun
packed
to,
in a hallway, just surrounding a little tiny monitor.
no,
So-
it's a pretty fun setup, and with the way that most of these that this has been run and other robotics competitions will run is you have your set time slot, and you don't interact with the other teams as much as you maybe would like to or not. And so it's pretty fun now to have a time where we all can kind of hang out and chat and talk about
Yep.
our robots and the design and other things. And so it's a pretty exciting time of the arena or the competition.
Either
here,
way,
so.
we're just giving them a hook and they
So it looks like the Razor bots are setting their robot in there. You can see they have a digging arm and large tires or large wheels. So large wheels will probably be a benefit compared to smaller ones in this sort of competition. Just because it'll give you more traction, more torque, which should in theory help you in Robotug. What's interesting is right now they have it currently faced with the plow forward, or the scoop forward, which is maybe they're running it that direction. I don't know. Is there a forward on these robots? I don't know. I guess not really. But an interesting decision there. And then it looks like we also have the New Mexico Tech robot in, and they have slightly smaller wheels, but also have longer. I'm gonna call them paddles. I don't know what the correct term for those are. Do you have the technical term?
I mean, we use grousers as our term, but that's
Grousers.
for our tracks.
That's for tracks. So yeah, I don't know. They have the paddles there that stick out and they give them a little bit more diameter on those wheels, and that may help traction too. New Mexico Tech has the scoop design that made us rethink our entire design for next year with how big of a berm they were able to build with this robot. So it'll be interesting to see. I don't really know what to expect. I haven't really considered tug of war as a design consideration for any of our robots. So
Hopefully they have a solid mounting point somewhere.
yeah, otherwise we may have some issues. But hopefully.
Oh, there we go. They
There we
flipped
go.
it around
Okay, so
now.
they're going. We'll have to see if New Mexico Tech decides to follow suit or if they.
I
are
mean, New Mexico Tech already has their heaviest axle away.
Right. Yep. You're
away
right.
from
Yep.
the line.
Yep. You're
So-
saying that the mass is. Wait, their heaviest axle, meaning the.
Yeah, their heaviest axles, I think
the
their
control
back,
box.
back
Yep,
axle
the
there with the
box
control
there.
box.
Yep.
I think Razorbots, their heaviest axle is the front one, I think.
But with the bucket on, you have a long lever arm there, right? So
Yeah.
I'm not sure if that will be an issue for New Mexico Tech of tipping forward, which was when they had large regolith scoops yesterday. We saw that a little bit with them. They had to be really careful with their scoops, and they did it successfully, navigate it really well with making sure that they weren't tipping forward too
Yep.
much when they had a large scoop. But they also were extending the lever arm upwards, which gives you a different moment of torque and that sort of thing. So we'll see. I wish I had a good engineering analysis for this, but I don't even. Do you know the robot masses off the top of your head? I don't.
I could pull those up. We have those in the
Okay, maybe yeah. If
score
you want to see if you can find some of those, it'd be interesting to know going into this, just so we can have an idea.
I kind of wish I had a whiteboard behind me to like draw out
Yeah.
the robots and do
We
some of that.
we can pull one of these over.
I
We
mean,
have a
we're
white-
using that one as a camera stand.
Yeah, we
so-
are using a whiteboard as a camera stand. You should. The people watching the live stream didn't know this, Jacob. They thought we
Oh,
had a
I'm
really,
giving away our state secrets.
Yeah, we had a really official looking camera.
You're not
They-
gonna get your clearance renewed now, dude. Come on.
But yeah, if we can get one just to
And like a marker, that'd be nice.
yeah, just so we can keep track of things we want to keep track of here.
Yeah.
Yeah, sorry, we weren't fully prepared for the robot games because since it was all kind of our contingency time to see what we can do after we have the final competition runs. We have a lot of time here. We have 3-ish hours before we are going to call it, and so yeah, hopefully we can get some fun stuff and learn some stuff about our robots that we wouldn't
Ooh, we
normally
get a
learn,
whiteboard
so.
now. Excellent. Do I get a marker as well?
All right, so I'm back and I'm here with Julian from the New Mexico Tech miners, the Miner 49ers, and we brought him up to see if he has any thoughts on what to expect from this and what his robot is gonna do in this, or what you're thinking. Obviously, you didn't really plan or design for this, so this is somewhat outside of your systems design. Do you have any thoughts on what's gonna happen or any ideas?
It'll be interesting because our wheels are I feel like designed for this. They have pretty large grousers,
Okay, yeah.
and then we also have pretty beefy motors as well. So I think with a combination of good motors and good wheels, I think we'll make for a good robot that could win in tug of war. Yeah.
Okay,
So,
interesting. Do you know what your robot weighs? What your mass is?
yeah. So right now we're at 71.15
Okay,
kilos.
yep.
We're the heaviest, I believe, amongst
Yeah,
the other robots here.
I'm not sure what ours weighs, but that's a heavy. The maximum weight you can compete in our competition here is I think 80 kilograms is the top
Yeah.
limit.
Yeah,
if I recall.
exactly.
And so yeah, you guys are definitely getting up towards that end. So we possibly we may not see a heavier robot in mass. Is obviously even in real tug of war with people is a big benefit just because it's hard to pull that much weight. And,
Exactly.
And you're used to moving that much weight with your motors, as you said. Powerful motors will give you an advantage.
I believe the only problem with our robot is our center of gravity is more
Sorry, go ahead.
is more focused on the front end.
Yeah.
Of course, it'd be ideal if the center of gravity was focused on the back end. So that'll be interesting to see how that affects the dynamics of this.
Perfect. Yeah, no, I think it'll be interesting. It's fun to do a little mental logic and try figuring out what to expect. But obviously, none of us have ever really run. I'm assuming you haven't done anything like this.
No, of course.
We in the past we've done a few tests where we try seeing how much we can tow or how much we can pull and how much force we put out. But it's different. You don't know what the other robot's capable of.
Exactly.
And so with me, I have a member from the Razor Bots.
Yeah.
Nice to meet you.
Nice to meet you. I'm Leighton. I'm team lead.
Perfect. And yeah, we just want to get some insight into what you're thinking for your robot. We just heard from the Miner 49ers from New Mexico Tech. And I guess, do you have any insights to what to expect from your robot? And
So we're looking at the strategy here is we're going to try and use our paddle, see kind of a little hole dug. We're hoping the radius of our wheels being a little bit bigger is going to help us, but we are pretty light, so we're not sure how it's going to play out. We've never done really anything like this.
I think our advisor has told us stories about this, and it hasn't been done at NASA in, I don't know, 8 years, maybe. I don't know the exact date, but it's one of those ones where we have a video of our robot from that year. It was almost, as you were saying, almost designed for this sort of competition, for a robo-tug. And I don't think we performed well in the mining portion, but in the robo-tug, it was like we were a semi-truck towing a smart car sort of thing. So do you know the dry mass of your robot?
Dry mass, we're looking at around 82 pounds, 36 kilograms
Yep.
roughly. Yep.
So this is kind of a heavyweight versus a lightweight here.
Yeah.
We'll see. You could almost fit 2 of your robots for the same mass of
Yep.
the single New Mexico Tech one. I guess if you guys just want to sit and watch from here, I'd love to hear your
for sure.
insight as whatever happens.
Absolutely.
And the rules, I assume the people in the pits or the arena have been told the rule that it's, as soon as, is it any part of it or is the full robot? I assume it's any part of the robot, correct?
Yeah, any part of the
Okay.
My understanding is what we're going with.
Okay, we should radio that in and make sure.
We're also doing, that some robots have like hoppers or buckets that you can fill with regolith to get yourself some extra weight. We're just saying that, sorry, you guys have to run without any regolith in, and you have to run at your dry weight.
No, and I think that
So-
that makes sense from a logistics perspective. Like I know the Iowa State robot, I can attest to that, can store, I want to say it's 80 liters. Is that our
It's a
volume?
lot.
We have that big
Within
box
your guys' robot?
in our hopper.
Oh,
We
I
can
see,
store
okay.
80 liters of regolith, and so you're going to be looking at several 100 pounds. I mean, it's 150, 200 pounds. I remember
Yeah.
something like that. Those numbers may not be perfectly accurate, but that would be a big advantage in a competition like this.
Yeah.
And so, yeah, we've decided that's not allowed, just out of fairness for all of different designs and to kind of level the playing field a little bit.
Right.
But it obviously is a little bit unfair for the Razor Bots here, who designed it optimized for the weight consideration in the scoring for the Lunabotics Challenge.
Yeah.
Now we're kind of pitting you against a heavy robot that is a different design philosophy. So
Well, that's part of the fun of it, is this all hasn't been, exactly designed for this, but
yep, yeah, and so that's one of the interesting things is we've spent so long considering all of the systems design and all of that sort of stuff, and now we're taking that and throwing it out the window and just kind of seeing what our big fancy remote controlled cars can do. So
After tug of war, you said you wanted to do
one of the things
sort of a speed competition as well.
yeah, one of the things that I think is fun and might be more conducive to all different types of robots is a race. And so where maybe something either depending on who's okay with what, either have all of 2 robots racing each other, or doing a. And it looks like we just lost our camera stream there. Sorry about that, everybody. We'll get that back. And then we are going to do a race in essentially a track system. So we'll set up 4 corners. You got to go outside of those, and maybe 3 or 5 laps, something like that. And we'll stop, watch them, and see who does what. I think it'd be kind of fun. I think we have the capability on our stream to have clocks up there, and I think it'd be kind of fun to see speeds, and that'd be a little bit more fair to a
Yeah,
bot.
I think we have a huge advantage in that one. We're
Are you pretty quick when you
really
put it in
quick.
gear? Okay, yeah.
Can you do wheelies?
Oh yeah.
I don't know about that.
Yeah.
I haven't tried that. But
That's one of the things Iowa State's robot, the Cardinal Space Mounting robot, is able to do. We have enough torque and enough speed in our grousers and our tracks that if you accelerate at full speed, which we don't run during regular lunabotics competitions, you wheelie backwards a little bit and you can hit the back of the robot on the ground, which is fun. All right, so we're getting an update on the bracket here. And so first up, we have New Mexico Tech Miner 49ers versus the Arkansas Razorbots. And the second matchup will be Iowa State versus the Minnesota University Robotics team. So should be a pretty exciting set of rounds here. We have 4 teams, and I think we'll probably do whoever wins. 6 teams. Oh, we have more entries into the competition that I've missed since I've been up here. So I'll let you know when we have a finalized bracket here. Should be pretty exciting. Okay, it looks like San Diego State Creed is entering also. They're being drawn on the board in front of me, so I'll let you know as I'm seeing them. Okay, look like we got some dance moves on the live stream there. I'm not sure whose team that was. If that was that was yours. Okay. Well, actually, I know that. I think right there is an Iowa State member. And one of the exciting things I'm looking forward to in this is that we've all been in competition mode where you kind of you want to optimize your score and you want to make sure you're ready to go. But now there's low stress. If you get knocked out of the tug of war competition, it's okay. It's not what you engineered for. It's not what you designed for. So It's exciting. I don't know. Is there anything you're looking forward to, or anything you're?
Man, it's nice to just take a day and not have to worry about everything working. We kind of sent a Hail Mary with our robot this year. We actually had another one that's been tested. It's worked, but we dropped almost 50% weight out of this one, hoping that was going to work out in our favor, but it was kind of last minute, as y'all saw with everything. Loose wiring, we've had to redo it several times. But it was a good test ground. We got a lot of data. Good platform for next year to start with. So
That's awesome.
looking
That's
forward to it.
Yeah. No, and I think that's one of the crazy things about every competition is your team can be as prepared as possible for 9 months of the year, and then once you get to those last 3 months of getting ready for competition time, things go wrong, parts don't come in, parts break, and
for sure.
And I think, is that what happened to you all? Did I hear that correctly?
Well, we had a router. Our router actually is on the fritz right now, so it's our only one they brought. So we had connection issues several rounds due to that router. So that's unfortunate, but you deal with it. So
yeah, no, and that's one of the things that you see a lot, and we've seen it a lot this weekend. Is the connectivity to your robot is one of the easiest points to fail, and we had in our system here we had a few issues we got to figure out, and so
for sure.
It is interesting to see that, yeah, you'd think that we use internet connectivity and all that all the time for our day-to-day lives, but doing it for a custom solution it's really difficult, and it can take a lot of planning, a lot of testing to be sure that you got it right.
Right.
All right, so walk me through here from the New Mexico Tech side. Can you walk me through the mounting point there? Is that, it looks like it's mounted on the scooping arm there.
Yeah, so behind the bucket, so the bucket has 3 mounting points, and right now the strap is wrapped around 2 of the outer mounting points, and then of course wrapped around, and then the hook is in the centers just so that the weight gets distributed evenly around the 2 arms. But I'm actually curious to see how those welds will hold up, because of course it wasn't designed for this. So.
Yeah, and hopefully it doesn't break anything too bad, but it's worst case scenario, rebuild the part and you can put it on display for next year or use it for next year, and so that'll be interesting to see. One of the things that when I've watched the videos from the previous NASA tug of war competitions, it's interesting to see teams sometimes will attach off center, and I can't remember how they perform, but I know that it's a little interesting because it means that your motors and your powertrain is essentially not equally distributed into the line that you're pulling on.
Exactly, yeah.
Which I think is usually a slight negative. Maybe it doesn't matter too much, but it's just interesting to see, and that's definitely a consideration that we'll see. Maybe some teams will attach off center, and we may see what the result of that is. It's a little bit of your dynamics homework problems, but in action.
Yeah,
interesting. So
it's interesting because for the NASA Mines competition, we initially planned to attach a hitch in order to pull a trailer. If we would have went through with that, I think the hitch would have worked perfectly for something like this.
It's almost the exact the exact application here is you're towing something, but yeah, it'll be interesting. I wish we had a good way to measure the power output of us when we all kind of go all out on something like this, because it's, at least for us, it's way out of our spec of what we normally do. And we have 2 or 3 speed modes that, depending on what you're testing, you can run. And so sometimes when we're out in like a sand pit or a parking lot to test it, we'll let it really run loose, and it's just a totally different robot. It's a totally different game, and it'd be fun to see the stuff when we're doing that kind of outside of what we spec it for the competition, to see what happens. Yeah. So do you have any insight for the Razor bots where you all will be mounting to? And I can't see if there's maybe it looks like there's
so
attachment.
I think really the only spot we have a good spot to do it is right at the base of the arm. That's kind of the strongest point we have. We thought about the bucket, but that's a little bit of a weak spot. The only problem with the back is we do have the battery box back there, so that may come out, but if it does, it does. We're looking for we got to take it apart and rebuild it anyway.
Yeah,
so.
no, that's one of the exciting things is the NASA competition and Lunabotics in general kind of requires you to start new and build new every year.
Right.
And so it's, once you finish your design, there's a few parts you may want to harvest and reuse, some of the more expensive things, like some of our sensors or computers, but usually you rebuild all of the mechanical stuff anyways, and that was one of the, because you don't want it to wear out, and that was one of the things we ran into. Iowa State didn't fully build a new mechanical design. We reused some of the parts, and that actually caused us some issues this year on our I think it was our second run. We had one of the pins in our motor shear.
Oh, really? Wow.
And it fully split in half, and it's because it wasn't designed for 2 years, and we didn't properly maintain it. And so that sort of thing can happen if you reuse parts. And so a lot of times teams decide that it's cheaper to spend a couple $100 on the new materials than it is to travel and then have your robot fail. And so
for sure.
It's a design consideration for sure. Yeah. Yeah, so I just we just got a question here from the Miner 49ers on what the insights for the Cardinal Space Mining robot here, Lance, are, and I think we are kind of designed for this. The track system is it's designed for it's heavy, which is a big downside for the Lunabotics competition, but it's really good for traction. We can go up really steep slopes. We can drive over just about anything, which is definitely going to help us here. And we're a pretty heavy robot, so we'll see. This is a pretty good application of. Yeah, our system is almost designed for this, and especially if we could add the extra mass, we're outlawing it during these runs, but if we could add the extra mass to the hopper, that big box on the back, it would be a pretty hard robot to beat, probably. And we've got really overpowered motors. I was talking about we get some serious speed coming out of them.
What's your guys' torque on your motors?
Oh, I don't know. Let me see if does anyone know the torque on our motors? It sounds like we have 240 Newton meters on our motors, and our gearing we've struggled to gear it down enough just because we have such fast motors that we struggle to get it to actually work properly there.
Yeah.
All right, so it sounds like we are updating our schedule here, that the Razor bots from the University of Arkansas are having a short or an electrical issue with their robot. So we are going to update the bracket. So now University of Minnesota is who will be facing the Miner 49ers, which is great for me because I ran out of things to talk about during the setup. And so now I can get some more stuff to ask them about. Awesome. So we just got Angelina from the University of Minnesota Lunabotics team here. And I just would love some of the insight into your robot, and hopefully it looks like it may be entering the arena now.
Yeah.
How do you think it'll perform in tug of war, which it was probably not designed for, I'm assuming?
Well, absolutely. It was not designed for tug of war, but our robot's about a little over 60 kilograms. And I'm not sure about the weight of the other one.
Yep. Miner 49ers, I think you said 71 kilograms.
Okay.
There, so.
So we do have the disadvantage there. Sheer power wise, it's whatever they have it tuned to at the moment. I don't think it's at full power. But I'm thinking that we can at least put up a good fight.
Awesome. Yeah, and that's one of the exciting things is just trying to see what happens because you never know.
Yeah, neither robot was actually built for this, so.
I don't know. He seems to think, that
Oh,
from the Miner
did you?
49.
Did
No,
you?
I'm kidding. But yeah, no, it'll be exciting to see, and it's just a fun activity that we all can come do, and it's low stress. I know one of the things during these competitions is, especially in the control room and watching your robot run, it's a year of work that's gone into a 40-minute time period, and this will be fun just because it's.
You get to have some fun with it, play with it.
Yep, you get to play with the toys you don't normally get to play with. Yeah.
Are you guys facing forward or backward? I can't tell.
Right now, the strap is attached to our backside, so we'll be driving forward.
Okay.
So it looks like you're attaching to that dump box that you all have there.
That'll be interesting.
That will be, yeah. And the thing about these robots is a lot of times there's not really a forward or backwards in terms of drivetrain. Usually the drivetrain's pretty balanced.
Yeah.
In cars, you have a forward on your drivetrain, and with these you won't really as much. Do you know, as far as mounting, what considerations? I don't know if you were into those insights. It was obviously an impromptu thing.
Yeah.
What considerations were probably considered to mount to that rear point instead of a different point?
We decided on that rear point just because we just have a really nice spot right there in the front. We kind of have like a little bar going across, but that was mostly just like to have an actual hoist point. And so in the front, like we have all our electronics there. We do have a Z camera right there, which is extremely expensive. We didn't want to put that at risk since it's not something that can easily detach from the robot. And so the back was the best place for us.
No, and that's one of the things as we've been preparing. We wanted to let teams know that if you have something you don't want to get damaged or messed with, remove it if you can, or make sure it's as far from any possible issues that you can have. But we've got a pretty safe setup here. You can see everyone in the pits is wearing their full PPE as well as their safety goggles, that sort of thing. So we shouldn't have any issues with that, but everyone will leave the arena before the start of that, and that means that if anything unexpected happens, everyone will be distanced and it should be just good to go. One sec. All right, and we're working on getting this live stream so it shows the matchup, and we can all see who's queued up after both the University of Minnesota and the New Mexico Tech Minor 49ers here. It should be a pretty interesting bracket, and it's fun to see. Sometimes the robot you don't expect to win will win, but I definitely feel like both of your teams with these heavier 60 kilogram and 71 kilogram bots will definitely have an advantage compared to some of the lighter robots. We've had some pretty light robots just because of the design considerations for the competition. A lighter robot sometimes has benefits. So for something like tug of war, maybe not as much. But
I'm excited to see how the other teams do as well after
Yeah.
ours.
yeah, and I guess we talked to the minor 49ers here, but do you think, Angelina, do you think that the if we do a race section, how do you think your team would perform in that? And I don't know if you heard our
Yeah.
what we're thinking. If we have time for it, we'd love to do a okay, it looks like we're about to start here, is what I'm hearing.
Okay.
But if we do a race, it'd be around essentially a track by yourself, and it'd be timed. Do you think you all have the speed, top speed for that, or would that be something you may struggle with?
Well, I can't speak for other robots, but I do know that if we're able to get in there and tune some stuff really quick, just
Yeah,
in our
little
controls,
adjustments, yeah.
then we have speed.
Okay.
We have speed,
Yeah.
and we have very good handling. So I
Okay.
think that we could put up a good fight for that one as well.
There we go. Awesome. So it sounds like we're getting close to ready here. I'm not sure how they'll signal us, or maybe the robots will just start moving. And we'll see what happens here. I'm pretty excited for this, and hopefully we'll have a shorter setup time between the next few bots. But we're doing this for the first time, and I assume you all have you ever tested pulling anything, or is this a new experience for you all?
We have not tested pulling anything with ours.
I guess for our excavation subsystem team, they did do some physical testing on the bucket, and they did try pulling weights, but I think the max is 45 pounds.
Okay.
So 20 some kilos.
Yeah. So you're around. Yeah. Definitely not what you're gonna be attempting to pull here, and it won't be pulling. Those obviously weren't pulling back as much, but something that you at least have looked into, and I guess is interesting. We've done a few tests with our robot where we tried pulling something through regolith, and it's just interesting how much torque you have. Just
You
to
guys
even
were training for this.
well, yeah, we've been going to the gym really, if
Oh,
you
yeah.
sort of the robot gym. But it's interesting just to even navigate. You really do need a lot of torque and a lot of traction. So it is something these robots inadvertently kind of are designed for. But it'll be interesting to see what happens when we get these moving.
Now, is it against the rules if we move our bucket up and down, or does the bucket have to stay stationary?
Looks like we just lost our camera feed here.
We can.
All right, looks like we lost our camera feed there, so sorry about that. We're switching to another one, and hopefully we'll be back with that original one. It gives us a slightly better perpendicular view, but here you can still see what's going on. I think here are we looking over the University of Minnesota robot, so we're on the other angle from this, and then looking at the minor 49ers. So
The suspense is building up.
I
Honestly,
know.
when are they gonna start this?
I'm feeling this is we needed a game day show or something beforehand.
Yeah.
So no, but it'll be interesting to see. I don't know, and it's the nice thing is if something goes wrong, you're just kind of like, oh, okay, next year we'll maybe not fix that because we're never gonna do this again, sort of thing, So, but it's also fun videos. I hope we get some good footage for you all. It's fun to be able to show prospective members as you're trying to recruit or whatever.
Yeah.
Just to be like, here's one of the things we've done in the past and we may do again. So. All right, so we just checked on our rules with our rules expert who is in charge of judging the Lunabotics competition, and it doesn't seem that there's a rule against moving the bucket. Yeah, the scoop here from the minor 49ers. So we'll see. That maybe definitely be a tactic.
They
You
might
guys
have
have
a strat.
some pretty large actuators there that definitely will have a lot of torque. They might be able to just off the start tug you. That'll be
They
interesting to
might.
see.
We also might have a strategy here, though, with
Okay.
our bucket chain, with our digging
Oh, you could
mechanism.
dig in.
We can dig straight into the ground because
Yep.
it does lower.
Yep.
That might give us a little.
Yeah, a little bit of anchoring, if you will.
Yeah.
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 Interesting. That'll be. Oh wow, there's some different strategy here. This would be. Maybe we should take another week and we can all practice and come back and do it again. No, but interesting. Yeah, yeah, you'll have a lot more surface area under the ground, which will be fun. Yeah, I don't know. This will be a fun one to see, and we'll come back when we're ready to start here. I think we're waiting on maybe one or two more things. All right, so we're talking about some of the logistics here. But because the teams are sitting next to each other in the hallway, looking at the same monitor, we'll probably just, I think the plan is to have a countdown, a 3, 2, 1, and then the team will do whatever their plan is, meaning there shouldn't be any latency on that end or on the networking end. They're wired straight into the router to communicate with the robot. So hopefully it should be an exciting and fair match, but we'll see what happens. This is obviously the first time running this. It looks like we're closing the door there. And I don't know who that is and if they're going to head out. It looks like there's someone from the Cardinal Space Mining Club based off of their PPE and the protective full face respirator they're wearing. But I think we're going to close the doors here, and then we are hopefully going to get started. All right, and so
Cool.
if you look there, we've got a crowd camera that we've just set up to show the people here from the different teams watching their robots go to run. So, yeah, we're all pretty excited for this. It's a fun little activity we can do that's outside of the regular robot here. All right, so it looks like we're about to close that door, and then I'm assuming we're good to start. I'm looking over at our streaming group, and do we have an update? If you want to count me in when they're good to go, but. Yeah, and one of the nice things about these robots, we have a lot of safety features built in. So like e-stops are great for something like this because if you get outside of your regular operation, there's a separating button that will stop everything from running and essentially separate your batteries from everything else.
Yeah.
Meaning there's no real risk there. And we've taken a lot of safety precautions with fire mitigation. We have sand buckets, fire extinguishers, that sort of thing. So hopefully this is all going to be great and should be safe. We're making sure that we're doing this in a little bit of a chaotic but safe manner here. So. All right, so sounds like we've got all right, 6, 5, 4, 3, 2, 1. All right, let's see if we get movement here. Oh, there we go. We got oh my goodness, look at them dig in. Wow.
And they're just going
Oh
down.
wow, no one may end up across the line here.
Holy.
This is crazy. I think we may be here a while.
Oh,
Oh, wow.
oh.
That
We've
high
got some
center, yeah, the
crazy
high torque
motion.
there is interesting.
Wow, this is. I was not expecting this.
Wow, that is, yeah, there's some serious digging going on there. That is interesting. I'm not sure anyone's gonna move here.
And now here's the question:
Yeah, what's up?
Would it, like I mentioned earlier, would
Yeah.
it be breaking the rules if the bucket were to?
No, I don't think so.
actuate?
I think the bucket could totally actuate.
Okay.
I'm not
That
sure.
might be the only way we get some movement.
But yeah, you're right. Is if you lift the bucket here, you may be able to. I don't know. Yeah, maybe If you the minor 49ers here, consider that.
Oh,
Ooh,
looks like they're grabbing up on themselves. Okay.
Maybe getting some motion. Maybe
Something's
pulling you all
happening
back.
there.
I don't know. I'm not exactly sure what's happening here. We may just be at a stalemate. This may just be a tie. I don't know what the protocol is there.
Seems
we
like
do
they
we
might be moving
How
a
long do
little.
we give them?
do we have protocol for what the plan is before we just are worried about a motor fire?
Ooh.
You know, I'm a little worried about actually motors will overheat and shut themselves down possibly, and then you'll lose some control there. I'm not sure.
Yeah, we're just digging down into the pit right now.
Oh, there we go. Some climbing there from the New Mexico Tech team, the minor 49ers. Wow, I have to imagine these motors are probably heating up, don't you
Yeah.
think? I mean, they're running at full blast outside of. Uh-oh.
No, the other way.
Oh.
The other way.
Uh-oh.
This is wow. It's
Lift it up.
really exciting except for not moving much.
Yeah. I don't think either team's gonna let up here though.
No, I know. I think what's gonna happen. I don't know. And even if a motor dies, do you think a team could pull the other one out? I mean, if it's 70 kilograms,
Honestly?
you're looking at over 150 pounds, right? With
Right.
that, and so I mean, it's a lot of weight to be pulling. Oh, is it? It looks like
Have they
maybe
stopped?
your motors have stopped New Mexico Tech here, minor 49ers, correct?
But even with our wheels not moving.
No, oh, everyone
We
stopped.
both stopped.
Okay, so maybe we were at a draw here, a standstill. I'm not sure. Have we heard from the arena? Okay, we're
Reset.
resetting. So it looks like we're
Okay.
gonna dig them out and try again. I don't know if we're gonna get a different result here. This seems a little bit interesting, but yeah, maybe
That
maybe
was a
we'll
good
do some compaction of the cross diag lime, and that will maybe give us a stronger base to work with. Obviously, during the mining part of the competition and the actual competition part, you want to have loose ag lime for our regular simulant, just because it makes it easier to mine and easier to and more realistic to the moon. But for something like this, as we're now seeing, it is not very beneficial because everyone will just kind of trench into the ground and dig themselves in and go nowhere. So we'll check back in when we're ready to go. All right, it sounds like we are going to move to the San Diego State University's Creed and Cardinal Space Mining Club from Iowa State University as the next matchup. We'll get an update on that New Mexico Tech minor 49ers versus University of Minnesota Robotics Lunobotics team. We will let you know what the result of that is. To me, it looks like a tie. I'm not sure if we'll redo that, which is possibly, or we'll. I don't know. Are you all happy with your results from that?
No, not really. Actually.
Oh, okay. A
They
little,
need to win.
yeah, a little bit of frustration for the minor 49ers here. Why not? Can you dive into that a little bit?
I don't know. I honestly thought our motors were a lot beefier, but it just seems like we just sort of dug ourselves into the regolith. So
Yeah, and I think that makes sense just from the way that the lunar soil behaves.
Yeah.
It's powder, it's a dust. So
Yeah.
I guess it makes sense that we're all kind of trenching in. But yeah, with this much torque between the two, it's interesting that they just dove themselves in. And then any input from the Minnesota side?
Honestly, I had no idea how this was gonna go for us. But I'm happy that we didn't lose.
There
you know?
we go. Yeah, no, yeah.
Um,
I'm just happy to be here, sort of thing,
right,
right? Yeah,
yeah.
okay.
Obviously, it was not built
Oh,
for this.
this is interesting. I don't. It looks like there's not too much tension on that line, but I was a little bit
Okay.
worried that I don't know how they're gonna get these apart. Are they just gonna move the robots? We'll see. Oh, okay. They have.
They might just have to pick them up and
I think they'll just loosen the line there. I think
Okay.
I think it's a
it's just a ratchet strap.
ratchet strap.
Okay.
I think, which is a good thing because otherwise these robots would be tied together forever, and
Absolutely.
we'd be stuck watching static robots for a while. So. All right, then we are going to go ahead, since we're switching the teams over, we'll go ahead and say goodbye to our member from the Minnesota team here. So thank you so much for coming up. Hopefully we're back here with you to watch either a rematch or the next match. So thank you very much.
Absolutely. Thank you for having me.
And then we also are going to say goodbye to our member from New Mexico Tech's Minor 49ers. So thank you very much.
Yes, thank you. We hope to have a rematch, hopefully.
Yeah, I look forward to it. All right. Hello. So we're back here. We have switched the runs here. It looks like we've just shifted the 2 robots to the bottom there from New Mexico Tech and the University of Minnesota. Looks like they're just going to sit out of the way. So we won't have to reload them, which will save us a little bit of time here. And we've just loaded San Diego State Creed, that your robot in. And I think I'm here with Courtney, correct? Is that who you?
Yes.
Okay, perfect.
Hi, I'm Courtney.
And so I'm here with Courtney, and then we are working on loading the Cardinal Space Mining robot, Lance 1, or Lance 1.5, I think is what we're running this year. And we're here with Brady Bangasser. Welcome, Brady.
Yep.
And so I guess, I don't know, what are you looking forward to in this? It looks like you all from Creed have a very large wheelbase. Do you know what your robot weighs off the top of your head?
So the first time we got weighed in, it was like 63 kilograms,
Okay.
but then like after we've done a couple rounds, it's now up to like 69 kilograms.
So you're telling me there's 6 kilograms of regolith somewhere in that robot?
Yeah, pretty much.
Do you all know where in that robot? Because it looks pretty,
Honestly, it could be anywhere within the wheels, within the chassis. Honestly, probably in the deposition part of it is probably where the most of it
Yep.
is.
So just small amounts of powder. Yep.
Yeah, exactly.
Yep, and so you can see there, we're loading the Cardinal Space Mining team there is loading the Lance 1 robot, or the Lance 1.5 robot, and we'll see, it looks like you all have an attachment point low down towards your wheelbase there. Do you know where that's attached? Do you know what design decisions went into that?
Yeah, that's part of our chassis. So definitely probably part of the strongest part of our rover. So
Please ignore any background volume. We've got a lot of people up in our Student Innovation Center Stepatorium to watch this.
But yeah, so we're just hoping that with the use of our big wheels and our cleats that we'll be able to create enough traction to really pull your guys' rover.
We'll see. It's definitely not something that any of us considered when designing our robots. Well,
Indeed.
yeah, see, okay, yeah, so I'm having our mechanical lead, Carter, tell us that this was totally something that the Cardinal Space Mining team planned when we were designing our robot. So, surprise to all of the other teams. This is actually why we hosted the competition, just to get here to do this. No, but it should be pretty exciting, and I think yeah, you guys have a wide wheelbase, you're long, it'll be interesting to see. I'm kind of hoping we don't get the same result as the last run where we just all dig in and sink.
Hopefully the tracks help.
Yeah, so Brady's pointing out that since we have such wide wheels and such wide tracks and so much surface area, it might make it less likely to sink into our loose regolith here. Brady, is there anything you're looking forward to here?
Winning.
Winning. Okay. Yep. Very succinct, very short. I like it. I have to say I am a little bit biased on this run here. I do like the people from San Diego State, but I'm cheering for us for sure. So, yeah, sorry about that. You got a biased commentator, which I'm
No,
sure
it's
will make
okay.
it'll make the
We
fans at home.
figured.
Yeah. There we go. Yeah, it'll make the fans at home mad. You guys will actually. Normally you complain that they're cheering against your team when you're playing a sports game, sports.
I know.
match,
Yeah,
but
we're the away team.
Right.
So.
Yeah. 100%. So, yeah. And it seems, I don't know if you all will come watch here or not, but from when New Mexico Tech and Minnesota were getting ready to go, they had 5, 6, 7, 8 people in watching here on the Jumbotron, which made it almost feel like it was some form of sporting event that we were commentating here, which was fun.
The engineer version.
Yep, it's the engineering version, far less athleticism required, so, which is probably a good thing, at least on our end.
No injuries.
Yeah,
Although
well,
only 3
Well-
fights this year.
and our team is okay. Thank you, Brady. Yeah, no, that's good. But yeah, so we'll see here. It looks like we're tied up. I'm not sure if we've gotten a timeline yet, but there's no tension in the cable, so I'm a little bit worried if there's no tension when they pull. Maybe I don't know. That's a lot of stress there, but
Yeah.
should be all right. And actually, I don't know if have we interviewed you yet on the live stream?
No,
Okay,
no,
perfect.
it's
Then I would love to know more. What's your major and what's your role in the San Diego State Creed team?
Yeah, so I actually just graduated from San Diego State as a mechanical engineer.
Congratulations.
Thank you. So yeah, it's great to be an alumni now, but I feel like I'm still in school now that we've been at this competition for 4 days. But I'm a part of the drive team and propulsion, so this is actually perfect that I'm talking for this
We picked
because
a good person then. Perfect.
yeah, exactly. And I was actually a co-team lead for the 5 people that were a part of the drivetrain and propulsion. Or, well, technically there were 10 because we had 5 mechanical engineers and then 5 electrical
Oh, wow,
and computer
okay.
science. So that was like 10 of our 15 members and everything. So
Awesome.
yeah, yeah.
Thank you. Yeah, thank you. It's fun to learn more about how teams are. You guys are a senior design group, correct?
Yes.
It's fun to
yes.
hear how teams are run and how it differs between teams. For
Definitely.
example, from Cardinal Space Mining, we're a team of 25, 30 members, and we have everyone is usually here for at least 2, 3, 4 years of their time at Iowa State, since it's a student organization. Brady, if you want to introduce yourself a little bit about who you are and what you've done for Cardinal Space Mining.
Yeah, so I'm Brady. I'm a computer science major with a minor in cybersecurity and data science. And I don't know, I didn't do anything for the robot. Not a thing. I don't know how it works. I don't like robots. I don't know why I'm here. But I did all of the networking for the competition.
So any issues we've had, we should blame you for then, correct?
Yeah. How many
Okay.
issues did you have?
A lot, actually.
Yeah,
It's a lot of
yeah.
headaches. No, yeah. So I don't know. No, but no, Brady's been a huge help for this competition. He has set up. I didn't know you could do this, but he set up a computer, like a regular Dell desktop, as a router. I didn't know that was something you could do. So he's been, doing a lot of work and working with our IT group, and he also has been handling his internship. So he's been awesome to work with and has been an absolute savior for putting this on. So. Yeah, thank you, Brady.
And huge shout out to Tim, who's done all the management.
So now
all
at
the
this point,
planning.
we're just complimenting each
Yeah.
other. So, but no, it's been an exciting thing to run. Are we tugging? Oh my. Okay, it looks like we're tensioning maybe there. So it looks like San Diego State was driving forward there to tension the line, and then I don't know if we're gonna get a countdown from our control center again. Oh, perfect. We're on camera. Awesome. I wasn't prepared for that. I should have done my hair. But no, as you can see, we've got a nice crowd in our Student Innovation Center Stepatorium to watch this. It is a lot nicer of an atmosphere than when we're all stressed for our robot runs. No one's quite as worried about how they're going to do in this compared to the actual runs.
Oh yeah.
Are you at all nervous? Are you,
I mean,
walk me
I'm
through, yeah.
a little nervous, but definitely the nerves were high during the actual rounds. I was like bouncing my leg and I was like texting my parents. I'm like, I don't know what's happening, because I wasn't in the control room.
We got 3, 2, 1. All right, let's see. Oh my goodness, look at that go.
Okay.
Oh, wow.
You guys are digging.
We're digging in, but you're gonna get us over that line, I think.
Does it? How
I don't
far
know
over
if it's
the
beginning. I
line?
don't know. I think you guys will. Oh my goodness. Wow. That is awesome. That is great.
I'm gonna have to chat with you.
Wow. I know. No, that was amazing. That is impressive from San Diego State there. Congratulations. Perfect. So you guys are going to move on to the next round, which I'm not sure how we're setting up. Are we doing another round in the Yeah, are they going to face the New Mexico Tech or Minnesota? I think so. Okay, we'll get back to you on that. Congratulations.
Thank
that was
you.
crazy.
No,
Wow,
that was exciting.
It was very
It was
quick.
short.
I would say it's boom over. But that was definitely more exciting than digging into the ground there. That was interesting. I'm excited to see you guys have a high, large torque wheels, so should be exciting to see where we go from there.
Definitely. I know. I'm excited too.
Awesome, perfect. I'll probably see you back in the next round. So
Sounds good.
Alrighty, so we are coming back to you from the Student Innovation Center Stepatorium. Um, and we have San Diego State again. Courtney from San Diego State, welcome back.
Thanks.
And then New Mexico Tech, a new person. Hello, welcome. Introduce
Isaiah.
yourself. Isaiah, welcome.
Yes.
And hello to Isaiah's mom. We've heard that you're asking whether he'll be on camera, and we got him on. So congratulations. No,
Thank you.
but we're excited to have you all run here. And I guess the reason why San Diego State is running again in our pseudo bracket is because we don't want to swap the robots around too much and move them. So we're gonna have San Diego State run, and then we will against New Mexico Tech, and the winner of that will then face Minnesota. And I guess it sounds like we've heard an update from the arena that there is a rule from the judges over there that you are not able to lift the moving arm, which is probably going to be a disadvantage for you all. So I think we're just going based off of the drivetrain and the traction is what it sounds like, which is interesting and definitely seems to, at least from a visual perspective in terms of size, maybe lend itself to San Diego State more so than New Mexico Tech here, just based on size of wheels.
Yeah.
But can you tell me, do you know the motor configuration that you all are running in?
The motor configuration is it's like tank tracks. So there's two motors, one on each side, and it's chain driven to all four wheels. So all four wheels will be spinning. And if you're looking for like torque and power, I don't have that off the top of my head, but there's some beefy motors. They're pretty big. But so far, that's all we got.
Perfect. Awesome. And then San Diego State, could you tell me about, it sounds like you have 4 motors on yours, right?
Yeah.
And so do you think that's going to give you an advantage here in terms of the amount of torque and the amount of force you all have?
I think so. We actually were doing the math a little earlier, and so yeah, we have 4 motors, and our ratio is 400 to 1, and then we have like a stall of 7 Newton meters, and then we're going at like 75% power capacity.
Okay.
So all that added together, it was about 8,400 Newton meters of torque. So I don't know how that is relative to you guys, but
we haven't done the math, which means they're probably at an advantage here, right? So
I am not a part of the team that has done the math for that.
I know our team hasn't done the math on how much we're pulling with. So you could just pick a number and say, oh, we have 15,000. We'll believe you.
Sure,
You know, if you come up with a number, we'll believe you. No, this should be exciting. I'm not sure if we have an update on time. It looks like we still have some people in the arena, so we'll wait till they're out and then we'll check back with you all, and hopefully we get a good little matchup. All right, it sounds like we have a 5-second countdown here until we start the matchup between Creed and the Miner 49ers. And look at that. Wow, we're digging in again. Oh my goodness. We may be at a standstill here. It's about the same result you had earlier in the Miner 49ers.
Yes,
Any
it
input,
is.
Isaiah?
Nah. I hope we would change a little bit of tactic, but if we just stand still, then
Yeah.
who's gonna go next?
I'm not sure. What's interesting
Put
about
SU against the other one. See how they do.
maybe, yeah, I'm not sure. This is the paddles seem to be really good at moving regolith. We may have to look at this as a mining design next year.
Oh,
Yeah. No, I think one thing like with the last round was that it was wheels versus traction,
Yeah.
and now it's just wheels versus wheels. So
Yeah. And yeah,
maybe that's, I don't know. Like it's
It's
gonna be
interesting.
like a
yeah,
thing for any wheel against wheels design.
maybe. Well, oh, we may be getting somewhere. Nope, it fell back down.
I
Okay.
think it is like once we get to a standstill, they're like, hey, move your bucket a little bit or your arms. And
Yeah.
Test some stuff. This is interesting. Oh, a little bit of movement back. Yeah, maybe. Okay, it looks like the bucket does seem to be moving there, correct?
Ooh,
Yeah,
ooh.
so, oh my goodness. Look at that.
Oh my gosh. That's so. Oh, this is nerve-wracking.
Ours against you all wasn't from Cardinal Space Mining wasn't nerve wracking. Oh my goodness, wasn't nerve wracking because you guys just pulled us across the line immediately. So okay, so it looks like actually all that's really happening is the wheels aren't moving too much. You guys are just adjusting.
Wow, you guys are doing like some acrobat stuff.
Yeah, you're just adjusting, and we'll see. It looks like maybe I don't know. Is there any movement from the San Diego State time or side? I mean there. Uh-oh. Oh, that I don't. That might not
that's
come back
not-
down, will it? Oh.
Wow, that would have
It
been
has
our
so much
time.
torque.
Oh yeah.
It has so much torque. Wow, that's so much torque to be able to pull that down. I really hope all of our sponsors are watching this, appreciating what we're putting their engineering money towards. This is funny to watch. Everyone in the arena here, the watch zone here, is all talking about how they would manage and drive the robots. We're hearing everyone, you gotta do this, you gotta do this. So pretty fun to see.
Oh my gosh. Oh my gosh.
Oh, wow, this is kind of how you're doing the mines too.
Yes.
It
I was like,
they
I don't
are.
know if
It looks like they're pulling San Diego State a little closer.
Oh wow.
I was
Yeah,
saying, I don't know
that's
if
really
it's like giving
close.
away like information, but our center of mass is really close to the front axles.
Yeah.
So like
Mm.
at any point there's like a little bit too much weight in the bucket or over, we will start tipping on those.
And
front
is that by design you did that, or is it just happy accident it worked out with how you drive? Or-
Happy accident. We did want to move it closer just to like the middle of the robot, but we just couldn't.
Yeah. No, I mean you have the control box all the way in the back, sort of thing. Ooh, some serious movement there.
Keep moving.
I mean, it looks like you guys are just slowly being dragged towards the line
Yeah,
here, which is
I know.
interesting. We'll have to see. I don't know if.
I'm like, I wonder if we were to like turn or something, if that would help us. But
Well, but no, do you don't adjust the wheels at all, right? So wouldn't it just be one side versus another? And so you probably want all.
well, no, it would be one side going forward and one side going
and
backwards.
so maybe you could turn
Yeah,
sideways slightly.
yeah.
Yeah, and I must have hit the line. It looks like we've stopped. So
It tipped.
a judge call.
Oh, they're gonna go in.
Are you a judge?
No, I think if let's ask our judge Jacob Mosier here.
Okay.
All right, so we've just gotten a ruling from our lead judge there, Jacob Mosier, who is also the controls lead for Cardinal Space Mining. And it sounds like New Mexico Tech has gotten San Diego State to touch the blue line, meaning New Mexico Tech has the Miner 49ers have beaten San Diego State. So congratulations.
Thank you.
And thank you for joining us, Courtney.
of course.
It was fun to watch your team and watch your robot absolutely destroy the Lance 1 from Cardinal Space Mining. That wasn't even a match. No, that was embarrassing, and we need to design for that next year for sure. So thank you very much.
Yeah, of
And we'll check back in with you all when we have the next set of robots set up. I believe it will be. Oh, this is interesting. It'll be the Miner 49ers versus Minnesota again in this bracket. So maybe we'll adjust that. It's not an official bracket because there's no prize money or anything. It's just for fun. So we'll get back to you when we know who is matching up. All right, so we are back here. We have a rematch between the Minor 49ers from New Mexico Tech. That's you all. Sorry, I was looking the wrong way there. And then the University of Minnesota Lunabotics team here. So welcome. I would love for you both to introduce yourselves and give us a little insight into what you're expecting on this rematch.
I'm Julian Martinez. I'm with Miners 49ers, and I hope with our new strategy we're able to defeat Minnesota. We'll see, I guess.
Yeah, and I think you all discovered something nice there, something new that was maybe will give you an advantage going forward with the adjustment of your scoop there. So we'll see.
Yeah, so I'm Adam. I'm from the University of Minnesota, and I hope that we could gain traction and maybe push through it. But it seems like they do have a pretty good strategy and with their shovel. So.
Do you know? Has your team considered one of the things that I talked about earlier with? Was it Angelina? Is that who I was talking to?
Yeah.
Was the using your digging, your trenching mechanics to possibly dig in a little bit? Do you know if that's something they're considering, or
yeah,
will we see?
We thought about it, but I think we also turned it off, like those motors. But also, it might not have enough power to like even, I guess, dig, and it'd be more to a detriment to us as it's in the ground and we can't really like push it out of the way.
And it may lift you slightly.
Yeah.
So yeah, that's definitely something. Okay, interesting. So then I guess what this comes down to is, will New Mexico Tech's new strategy be effective enough to overcome that freeze up we had earlier where you guys dug in and didn't move much?
Yeah, I guess we'll see if either the robot will tip over or not tip at all, and I guess it might be another tie.
Yeah, well, I guess one of the interesting things from a mechanical perspective, it seems even if you tip forward, it'll just drag your front tire in, so it'll just be an anchor.
Yeah.
You know, which I don't know. It was a good tie in the first match, but we'll see if their new system will work. And it looks like we've got a bunch of New Mexico Tech fans here up in our front row. Woohoo! So that should be. Are you all nervous for this run, or have you seen it and you're excited now? You're ready to dominate the competition. Yeah. Yep. They're giving me some nods here. So I don't know. That was an impressive run. We got absolutely pulled across the line by San Diego State, and then you guys were able to inch them out. So that was impressive. We'll see here. So do you think any of because it looks like I think you're attached below where your drop box is on the tail end of your robot there. Do you think that there's anything you could do with those motors or that hinge there that would give you an advantage, or is that kind of something that probably wouldn't help much anyways if you're able to move it?
Well, the way it pivots at that location where we're attached. So even moving that dump box wouldn't really change the angle much. And yeah, right now we're attached to the frame. So
yep. And so all it would do is just shift it doesn't move the wheelbase any shorter, right? All it does is just adjust the drop box, correct?
Yeah,
okay.
It would just move to drop.
Yep. So it shouldn't do much there. Maybe it will shift your center of gravity forward, but wouldn't make too much of an impact there.
Yeah.
Okay, interesting. I'm just trying to consider any other options or possibilities you may have. So
yeah.
All right, and it looks like we're starting there.
Whoa. That was an early advantage.
Are we getting tension there? Okay, can we get a rules check there? I think it was just tensioning the line, maybe.
Disqualified.
Yeah, I'm sure. Yeah. We got. Awesome. That's great. Let's see. All right, we're gonna count down here, I think. All right, we got a 10-second countdown here. 4, 3, 2, and 1. And we'll have a slight delay here with our camera setup. And wow, look at that. Ooh, you're dug in.
Yeah.
The rear wheel on Minnesota is dug in, and wow, look how fast. Yeah. You all might want to consider that as a trenching mechanism or a digging mechanism next year. That thing digs quick. Yeah. That's interesting. I mean, you dig down. How tall are those wheels? How deep are we getting in for that? Do you think?
They're almost 12 inches in diameter, so we're probably like 4 or 5 inches deep into the dirt.
Yeah, maybe it could be even maybe slightly more than that. I mean, it looks like a lot there. That's crazy. And you all are about similar depth. It looks like.
Yeah.
I don't know. We may be at the same point. We'll have to see if we'll give New Mexico Tech a little bit of time to try their approach and see if you all can come up with something new. Do you know your motor configuration on your robot off the top of your head?
No, not really.
Okay.
I was more on the software side.
Yep.
I think we just have 4 motors, 1 on each wheel, and it's just like a tank drive system. So
yeah. So then it should be similar in terms of torque probably to what you all have over the Minor 49ers. But we'll see whether anyone moves. This seems to be a second standstill.
Yeah. See, like our wheels have stopped.
It looks like they're moving. but we have low frame rate on our video. I think maybe we're hitting the network pretty hard. We'll see.
I think eventually they'll let us raise our bucket. I don't know. It seems to be like
That seems it
that's
seems
what
like
happened
yeah
last match.
that maybe it's just the tension. Oh, and you all have, looks like you've stopped your wheels now, so that's
Yeah.
oh nope, we're spinning again.
Yeah.
Not much is happening here. This is really invigorating stuff.
Oh, look, here
yeah.
we go. Here we go.
Yep. Okay. So now
Okay.
it looks like maybe you got permission from the judges. Oh yeah. But now we're back to what? Yeah. And what's interesting about that is it's lifting the torque point, so it means you're able to kind of pull the other robot out, which gives you a great advantage. It's a perfect design for tug of war and for mining. You all had some very impressive mining runs.
Oh my god.
Well, I think was it your whoever was in the control room was saying that they wanted to dig through to the bottom of our 18-inch regolith pit here, correct?
Yeah, that was our pilot, Neil Devlin. He that was his main goal, and it seemed to have worked. But I
don't think
we
he
got to
reached the
very
bottom. Yeah, he didn't quite reach the bottom, which we're glad of. But he was close. That was a deep hole, and I know it was a lot of work for Carter and our other judges to dig back in and fill back up for the next run. So, which we're very excited to do, and we're tipping forward a lot. I wonder.
We seem to be pulling them little by little. We'll see.
Right, which is the same as
There
the
we go.
San Diego
Yeah.
State stuff. That was a couple inches there. I don't know. Any thoughts on Minnesota?
Yeah, it just looks like the issue is like we're stuck in our frame. So
So we're
pulling
yeah.
it for sure.
It looks like they're coming closer. We've heard that if this lasts another 2 or 3 minutes, we're gonna just play rock paper scissors to see who advances,
Okay.
which is great and very engineering of us. So
Yeah.
it looks like you all are getting close to the line there, Minnesota. I might be getting a little nervous if I were you, unless you've got a
Yeah.
rocket booster back there.
yeah, maybe something I don't know either.
No,
Something
I mean
like
this may just be a sweep from the minor 49ers all the way through.
yeah.
It's getting close there. I mean, on that edge, it looks like we're getting
Seems
a
like
couple
we stopped
inches.
moving.
Yeah.
Yeah, I'm not sure what the deal is with that. Maybe you all had an electrical or mechanical issue. I don't know.
Yeah.
Maybe that's how people end up beating you. You have enough matches between the final that your batteries will wear out in time.
They're still moving though. I'm curious to see what happened.
Well, and it sounds like I think they said 3 minutes until we cut it, and you guys will just rock paper scissors.
Yeah.
So I'm not sure if you all are maybe you're having control issues possibly. I don't know. This is
Or
okay.
unless they just called it.
Did they call it? What's happening here? Sorry, we're trying to get an update for you all from our radios over to the judges. Unless maybe our camera just froze. Did our camera just freeze? That's also an option. All right, so it looks like we've got a rock paper scissors between New Mexico Tech on the right and let's see, who won there in Minnesota? I can't tell who won. Oh, we're lining up for it. Okay, here we go. All right, this is stressful here.
Yeah, it's all skill.
Yep, all skill.
All
I've
skill.
I've heard. Yeah. A true test of wits is what I've heard.
Yeah.
So minor 49ers, what have you guys been doing to prepare for this eventuality?
Obviously a lot.
Yeah, it seems like we haven't had enough hours of testing here for rock,
For
paper,
rock, paper,
scissors.
Yeah,
so-
no, I mean, I don't know about you all, but we have a 2-hour meeting once a week to test Cardinal Space Mining's rock paper scissors ability. Yeah, so I don't know. Has Minnesota been preparing for rock paper scissors?
No, we didn't have this in our charts or
Okay, but were you guys ready for? I've heard maybe you were ready for a hockey shootout if that was an eventuality too.
Yeah.
But we couldn't provide the hockey rink for you all, so that's what I was hearing. Yeah.
Something's going on the radio. Who won?
And it looks like New Mexico Tech has won.
let's
Is that?
go.
Wait, no, we called it early. We'll let you know when we know.
What was that?
I can't tell.
And a crisp 3.
Okay, and it looks like maybe Minnesota has won the rock paper
let's
scissors
go.
match. So, I think New Mexico Tech. I think unfortunately you were eliminated.
So sad.
You guys had a very dominant design here, and definitely can be proud of your tug of war performance.
Yeah, we'll
Yeah,
have to do
no,
more
I know
training.
this. Yeah, yep, yeah.
Yeah.
In the crowd, they're talking about they have to lose. Yeah, for rock paper scissors, you have to do some
Yeah,
training.
Pretty evident we need more training.
Yeah.
So that's on our part.
No, I think so, and I think losing in a rock paper scissors match in a tug of war game is really not. You can be proud of going out in that way for sure.
But Minnesota really lucked out here for not having a rock, paper, scissors contingency
I know.
plan and only a hockey contingency plan.
You're right.
I mean,
Yeah, they
really
only
came in clutch.
Yeah, no, you're right. That's a little. I mean, it's lucky that neither team is practicing the rock paper scissors. I know there's a lot of strategy behind it, a lot of real, science and math. Yeah.
Yeah, we have a member on our team who can do Monte Carlo simulations.
Yeah, we do Monte Carlo simulations.
We should have him do one of those.
A little bit of game theory. So. All right, and it looks like the Minnesota team is coming back into the watching area here to celebrate their win with some food. So. Yeah. All right. I think we are gonna step away until the next matchup. So.
That's a very happy robot we got there.
All right, hi. So we're here with Tim Kewen again, and then we've got Jacob Mosier, who is from Cardinal Space Mining, but we don't have anyone from Illinois to represent them here. So maybe they'll show up and we'll replace him with them. But we would love to hear your thoughts, Jacob, about the robot that we're going to see here.
Yeah, so throughout the building process, had a lot of positive energy going.
You didn't build the robot. Let them, yeah, no. But I don't know. What are your mechanical thoughts on this? They've got a low center of mass. They're a pretty short robot. Is that going to be an issue? I'm a little worried about the angle. Are they going to tip over?
So that's kind of what I'm thinking. I think the blade might get stuck and they might get pulled forward. That's one failure mode I could see. Also, if they're heavy enough on the back, that blade might just catch and they might just wedge themselves in there.
That's a good point.
Oh, so trying to pull back. Even if if they have enough torque to pull enough traction, they're pulling both their plow as well as
Yes.
University of Minnesota.
So
Awesome.
I don't think that's as likely as the first scenario, but we'll see.
Awesome. And then I would love your input on this matchup between the University of Minnesota and the Illinois Robotics and Space team.
Yeah, absolutely. I think we can all see that there's a pretty big size difference here between the robots, but also with the Illinois robot, like while it is a lot smaller, they've got that huge wedge on the front, and they've also got a different type of wheel than we do.
Yeah.
So like those tank treads might be at some advantage to them. I do know that with the U of M robot, we're not the best for traction, and so if it does come to like us just straight up having to drag them, if they do end up wedging themselves in the ground, we might have a little bit of struggle there, but I think we have the power to do it.
Yeah, no, I think that seems like a valid assessment. We haven't seen this style of track yet or of treads, so we'll see. It looks like I haven't looked close enough, and I don't remember any perforations or anything on the tracks. It looks like there may be some slight browsers there that maybe will help with traction on their end, but it will be interesting to see. It's a pretty short track, pretty short area, and so depending on the mass, they may sink in a little bit, and it may act a lot like a wheel. So
That's a
we'll
good
see.
point. We have been sinking in quite a bit. I don't know how that's gonna play on their side.
Yeah, no, and yeah, it should be. It may be tough depending on their motors and how they have them configured. I know some teams change their configurations between competition and this just for fun. Maybe if they give themselves a lot of torque here or something, they could. Yeah, well, looks like we're starting here. All right, so we just got a countdown 3, 2, 1, and we got a pull. And wow, look at that. Oh wow, we may get a flip
My
here.
goodness.
The plow is entering. I don't think they have much
It
control there.
wedged.
It's just wedged. So
It's just in there.
yeah, and it looks like Minnesota, you're digging in a little bit, but less so than previous rounds, maybe.
Right. Yeah, right now, all of our power is focused on our drivetrain. We cannot dig, anything like that.
Yeah.
Everything else is turned off.
Yeah. Wow, look at it does look like your dump section is loose, maybe, or what's happening there? Do you see? I don't know. Is there?
Yeah, it's not like actively going out. It's just like not super fixed.
Okay, so it's being wiggled. Got
Yeah.
it. Yeah, I mean, this is interesting. It's like pulling a sheet now at this point.
Right.
Because
I
don't.
mean, if they do flip, it would be pretty easy to
Oh
slide
my!
with.
Wait, whoa! What just
Oh.
happened there? Did we call a pause? Maybe.
Maybe.
I'm
Are
not
we going
sure.
forward?
No, it looks like everyone's paused.
Mm.
I'm not sure what we're getting an update from our radio group here. Okay. Wait, what was the ruling there? Okay, so Illinois, it sounds like has forfeited the match as they don't want to faceplant the beautiful smiley face on their plow.
Understood.
Which I think is a fair risk. I don't know if they gave him a name. I don't remember if he has a name. I think he did, and I'm forgetting it. But I think that he stayed happy through the entire run, and it may have been a close finish to ever actually tilt it all the way over.
Honestly, yeah.
It might have happened after enough time, but it's dug in pretty good there. And if you ever want to build a good tug of war robot, I think that sort of angle to trench you in deeper if you're getting pulled, because if they pull back, it would slide up and you'd be able to pull. So I don't know. It seems like a good design.
Unexpected, really good strategy for
Right.
this.
Yeah. No, I know. Maybe they were planning for this and we didn't know that. So, but awesome.
I think the only thing I'd change in retrospect is maybe like an angry face. He needs a
Yeah.
little more motivation.
I think he needs the inward eyebrows.
Yes.
Right. Little frustration that he's trying to. Yep. Awesome. All right, well then we'll step back until the next team, which I'm not sure if we have either the Razorbots or Youngstown State are the two teams we have remaining on our bracket. And maybe we'll do the next round first. I'll get back to you when I know. Alrighty, and so we are back here with the University of Minnesota and the Razorbots from University of Arkansas here. So would you go ahead and introduce yourself?
Yeah, I'm Leighton, team lead of Razorbots.
Welcome back.
Thank you.
I am David. I am soon to be the team lead of the electrical team of the University of Minnesota Lunatics.
Perfect. Well, welcome. And what are you all thinking for this run here? Any insight into what you're expecting from the University of Minnesota robot?
They look pretty evenly matched here. They're like the same size. I'm a little worried that our robot is taller than theirs and that our wheels are smaller, so we might just like not be able to make much progress.
Okay, there we go. And then I know the Razorbots, you all had an issue with some loose wires maybe before. Can you explain that?
Yeah, we had a CAN bus short, some wire disconnection, so got that fixed, back up and running. Should be good to go, hopefully, but we'll see.
Awesome. Well, then I'm excited for this. It looks like we have people that are starting to leave the arena here where we're doing our Robo Tug of War at CoSMiC 2025. And we'll see here what happens with this. I assume with wheels, we've seen a lot of digging in from all of the wheels as far as both University of Illinois Urbana-Champaign and Cardinal Space Mining from Iowa State. We have had the tracks kind of just get tugged along. So I don't know, maybe this will be some more digging, but I don't know. Do you guys think your teams have any extra tricks up their sleeve? We've seen obviously a few runs from Minnesota now, but do you think the Razorbots have anything up their sleeve?
Being with them mounted on the back, I think the only thing we can rely on is just the buckets. I don't think we can use not our bucket, but just the wheels. I don't think we can bring our bucket into play at all. So I think it's gonna be pretty straightforward from us.
Awesome. Yeah, and I think Minnesota. Do you think you guys will have anything new or exciting, or are we just gonna see you muscle through?
We're just gonna muscle through. We have our digger disabled, so we can't really like just dig into the ground and jam ourselves in place.
Yeah. Okay, that sounds good. Well, and I know that that you all have been practicing now. You're between matches. It seems like you've been practicing rock paper scissors, and we know you're dominant at hockey up there. So, I guess are there? Yeah. If you were to go head to head for any ties here, what would you all be looking for from University of Arkansas?
I like the cornhole idea.
Cornhole. Okay.
Ping pong. We got a lot of ping pong fans.
Wow, interesting. Yeah, some table tennis. No, I like that idea. I don't know. Are you all like? Do you have them in your dorms? Because I know here we some dorms will have
we do
have table tennis.
We have a lot of ping pong tables.
Yeah, gotcha. Do you play? Are you?
I do. I like playing.
Yeah. No, I played with my family a couple times, but I'm definitely no good compared to people that are any good. And are you a big table tennis fan, ping pong fan?
Yeah, actually, we have a ping pong table at our Airbnb here.
Oh, so they've been practicing now.
We've been playing nonstop. We'd so be ready for ping pong.
Is that why you all, if you come in tired, it's not because you've been working on the robot, it's because of the ping pong table has been keeping up. Yeah, no, okay.
Never stop.
Yeah, awesome. No, that's exciting to hear. So then maybe let's go down to a ping pong matchup.
Yeah.
I don't know. That's an option, you know.
I'm good for it. For sure.
Perfect. Yeah. So I guess I haven't heard a countdown here, but I think we'll be getting started soon, hopefully. And we have a matchup between the University of Minnesota and the University of Arkansas Razorbots. So. All right, so I was just talking with our networking guru, Brady, and he's telling us that throughout the competition for the past 3 days since we installed our cameras, we've passed somewhere around 85 gigabytes of data. Doesn't really mean much, but it's just a fun little fact that shows how much camera footage we've been passing through to live stream it and bring it all to you. And kind of it helps explain some of the issues we've faced when we've run into issues to delay some runs a couple minutes and that sort of thing to reset stuff. There's a lot of data flying around, a lot to manage, and make sure it's getting to the right place. So fun little networking thing. And I'm hoping here that we'll get started with some of the robo games, this tug of war here. I don't know, maybe that explains some of the latency we've been seeing with that much data. it could explain the 1 or 2 seconds we've been seeing, and maybe that'll play a factor here. I know they were counting down. It sounds like you count down from 5, and then the team will start. But if there's latency between your controller and the robot in some interface there on your design, maybe that'll cause a second or two, and that could be the difference here. I don't know.
Right.
So have you all noticed? I don't know if you either of you are the ones who drives your robots ever, if you've tested with any of it, but have you all noticed any latency with any of the actual controls? I know with ours it's pretty rapid. It's almost instantaneous.
So when we use our onboard cameras, we have a latency of it's about a second and a half.
And is that with the cameras or with the input or both?
Seems to be both. Yeah.
Yep. And are you? I forget. Are you all using ROS? What are you
Yes. Yeah.
using?
ROS
Yeah.
too.
Yeah. So that's something we've run into. Robot operating system or ROS. When you use cameras, you're passing a lot of data, and it starts to kind of slow itself down. A lot like when you're doing a lot of things on your Wi-Fi network, it slows it down. So we've run into that as well, and that's why we don't use onboard cameras right now, because we haven't figured that out. So I don't think you'll be running them now, but if you are, maybe that'll play a factor.
I've been hearing great things about our cameras and our controls. It's been working like pretty consistently, pretty well. Except last match when we ran into the rock. The reason why we ran into the rock is because our GPU wasn't responsive.
Yeah.
And that was in charge of the camera in the front.
Yep.
So we had no vision in the front of the robot.
Yeah.
So
No,
we ran
that's
straight
what we
into the
heard
rock.
when we interviewed afterwards. All right, 4, 3, 2, 1. All right, let's get a start going here. Let's see. Oh my goodness. Whoa. Oh my goodness. Okay, well that's over. I'm sorry that happened to your robot.
No, that's
can we get a quick reaction from you there?
Yeah, that wasn't totally expected. The lightweight's really not going for us there.
I'm really hoping they hit the e-stop real quick so we don't have any issues, but is that a battery out? Hey, radio,
it's
there's
very
a battery
possible.
out.
Yeah.
All right.
real close
Well,
call there.
that was definitely something special. We're gonna make sure we hit our e-stop here, so there's no issues. But wow, University of Minnesota here, you all have to be feeling pretty happy about that performance. That was impressive. Any thoughts?
I was not expecting. I guess the big wheels was a bad thing. I had a
Oh my goodness.
high center of gravity.
Wow, your controls are everywhere.
Oh my
Hopefully you didn't need any of that for.
No,
for
no, we were
now.
kind of going into that with a
Yep.
it's last day of the competition. We're
Yep.
gonna rebuild anyway, so no problem.
Perfect. No, that's exciting. I hope that was at least fun to see.
Yeah,
you
happy to
know?
provide the entertainment for sure.
Boy, that is wow. That's interesting. I was not expecting that. That's for sure.
neither.
That was quick. Yeah. I think you all should be all right. I don't think much will break.
Yeah,
It doesn't
no.
look like anything's mechanically
No,
broken.
mechanically,
and
I don't think we're gonna hurt, but
Yeah.
maybe controls that maybe.
so, yeah, you have to double check everything. You have to rewire it all back up. But that was something awesome. Wow, look at an unfazed, the University of Minnesota robot over there. I forget. Do you have a name for your robot? I forget. I think I asked, and I don't. Is it the cheese grater?
Yes.
Correct. Okay, the cheese grater.
grater.
Yep.
That was the name for ours last year.
Ah, there we
Yeah.
go. So, yep, they've taken the crown now.
Yeah,
it
for
seems.
sure.
So, awesome. Well,
Hand it
thank you
over.
both for joining me.
Yeah,
We'll
thank
make sure
you.
we'll get this cleaned up, and we'll check back in when the next team is ready.
Awesome.
Thank you. All right, hello. We are back. So, Youngstown State and Illinois Robotics in Space both have teams that are fully working on running their robots for this tug of war match in our Robo games. So I'm here with Denise. Hello, Denise.
Hello.
And also Sebastian, who is the president of Cardinal Space Mining Club.
Hello there.
And so we'll be providing some commentary on these robots and their tug of war match. This is what we consider a lightweight matchup. So the winner of the heavyweights was Minnesota's Lunabot, and they, as we saw, us with a very exciting flip there in the final match there. And now I think we're getting close to having this round start. Do you all have any thoughts on what we're going to see here, or any guesses or estimations of what we'll see?
Well, I'm an Illinois native, so talking about the Illinois Robotics in Space robot, I like their smiley face. I like their track design, and they put up a good fight up against, I forget who it was. Do you remember who they went up against last time?
That was Minnesota, wasn't it?
That was I think that was Minnesota, but they put up a good fight against them considering the size difference. So
Yeah.
I'm excited to see what they can do against a more comparably sized robot.
Yep. No, and I think Jacob and I were talking that, I mean, that front blade is almost designed for tug of war, where it can dig in if you're getting pulled forward, but then it will also slide backwards if you're the one doing the pulling. So
That's true, that's true.
Any thoughts, Denise?
I don't know. Most of the time, though, they're on the defense with the other one because they were being pulled so much. They weren't really like actually pulling back.
Right.
I don't know. I feel like since they're similarly rated, like weight wise, I think I don't know.
It's gonna be close.
Yeah.
For sure, I think so. And I think one of the benefits that Youngstown State will have, that from what we've seen, is that they have wheels. It seems that actually in this material seems to be definitely beneficial.
Definitely in the straight lines, the wheels seem to be much better than the tracks. So maybe the tracks would allow them to spin around our simulant here a little bit better, but it seems like in a straight line,
it's
having browsers and wheels
is
beneficial for this kind of.
Yeah, maybe it's because it's so compacted too.
Yeah.
Because we haven't aerated with it.
Yeah, and we've actually been compacting it after the first match. We started we went with the big tamp that smacks it down, and that just will let us get some more solid ground and have less digging in. So we'll see.
We ran out of chalk, I see.
Yeah, I think so. We just started drawing a line in the sand, if you will. And yeah, no, I think it works well enough, and usually it's pretty clear who's gonna win one.
Yeah, it's pretty binary. It's kind of either they start pulling or they don't. So.
All right, and it looks like we're sending in one of our group members here from Cardinal Space Mining Club to check in on the Youngstown State robot.
Looks like they might be having trouble connecting, perhaps.
Possibly some connection issues here is what it looks like.
Took my drawing.
Could you describe the drawing on his back?
Drawing,
What is it?
okay, one of them is like a scooping robot right on the left here.
Okay.
And then we have them tugging with, based off of our design, Lance on the right, a track design.
Okay.
Good, very artistic.
Yeah, thank you. And then it says CoSMiC Robot Games.
Very good. Nice. I think I saw the robot games on someone's back on one of the other camera
We need
angles
to get
earlier.
a closer angle of it.
Yeah. I wish we had control of our.
No, we need him to stand in front of it.
We just looked over at our live stream guy, and he just gave us a head shake. No, that's not happening here.
We have some Christmas colors going on.
Yeah, you're right. Yeah, there's some red and green straps going on. Yeah, little Christmas, yeah.
Do you think somebody will flip over?
I don't know. I think if anyone is, I would guess that Illinois, they have the high mounting point, which can be a concern for flipping if it's above your center of gravity.
And also they like all they do is like hold themselves.
Yep. So we'll see here. We haven't gotten an update, but it sounds like there's a lot of radio chatter, so maybe we're working on connection between, I would guess, the Youngstown State and their control center based off of which robot we had John check while he was in there. So
I believe this is Youngstown State's first run, correct?
Their first tug, yep, first tug run, yes, yeah. And they are a senior design group out of Youngstown, Ohio, and they have had a very impressive robot for it being their first robot design, and we've all been kind of floored with how quick they were to get going. And one of the things that we thought was pretty funny is usually, at least when Iowa State's Cardinal Space Mining Club shows up to a competition, everything is broken and we need to repair it all from traveling. But when Youngstown State walked in, they were the first team to show up at 9 in the morning, and they set their robot down and they got up and said, "All right, it's good to go. We're going to lunch," and they left, and it worked first try on their run, and they have really engineered it, and it's a great setup right now that they were able to just set it off and it ran on their first run and they had no issues with it, which was amazing.
Definitely very impressive. It's always a scramble coming to these competitions, and you know, something's not working. Controls might be having trouble connecting, but they just seem to be on it and prepared. So and it's very impressive from a senior design team. You know, you have a lot of these teams that have done this for many years and have all this experience from you know, freshman going to sophomore to junior then senior and being on the same team, and these youngston kind of just have all these seniors first years. And
I think I agree, and I mean the planning and the foresight to be able to have everything you need ready to go is remarkable. I don't know what their pre-competition timeline looked like, but even I'm yet to see our team ever show up and not have to fix everything, you know. So maybe that just says more about us than them. I don't know. So
3,
2, 1,
and they're off.
All right, let's see. Oh wow,
Youngston
big
off to a
tug
good
from
start.
Youngston there.
Oh.
We got a loose cable. We'll see what happens there.
Oh, they're backing it up. Come on now.
Looks
Who-
like
who
maybe
can't
we'll
tie?
re-tie that up and see what happens.
That'll be an easy fix.
Yeah, it should be. Hopefully, it should just retie it. And they're just backing it right into place. Perfect.
Good.
And then I hope they're disconnecting their robot for safety purposes here. But
yeah, YSU really got off to a fast start there. That was impressive.
yeah, it looked like they did give. I didn't see. Was there a little bit of pull on the Illinois Robotics and Space side? I didn't fully see
It was like a
there.
little bit.
Okay.
It looked like they weren't really moving the tracks.
It could have been that YSU just got off a little bit faster than Illinois.
Yep.
Because as soon as they both got in tension, they kind of stopped in their tracks.
Okay, we may have broken the ratchet strap we were using.
Oh wow.
Which shows the amount of force between these robots. That's actually pretty impressive because I know this is like when you tie your mattress down on the interstate, it holds down that several hundred pounds of force, you know. So there's a lot of force between these.
That's impressive traction force right there.
And to be able to transmit that on a difficult surface like our lunar regolith simulant is impressive.
I wonder how many people it would take to pull against
Oh,
those big and
I
heavy
would.
ones.
We may have to do
might be
that out in a
fun
sand pit with our robot,
Fun to test.
to see how many of us it takes to tug our robot back.
Although EH and S.
Yes, our safety folks. We will have to clear that with them. And but I don't know. You'd be far away from the robot, so it's no different than regular tug of war.
Yeah, I guess that's true. That's true.
But I don't know. Maybe tug of war wouldn't be approved by a
Just
safety
make
group.
have a long rope.
Yeah, you put them 20, 30 feet
Real
away.
far
and it would
away.
be- yeah.
That'd be fun.
I don't know. Maybe that's something we should consider next year as a
At
fun little
least-
activity for one of our Saturdays.
At least 2 people.
Oh, for sure.
I'm just kidding.
Yeah, I mean, how many people do you think it actually would be if you were to get do arbitrary guess? I have no idea. I don't know the physics or anything, but
Dude, me either. What?
half of a Walter. That's good. That's good.
It'd be the 100 men versus one robot.
One robot.
gorilla,
Yeah,
I
it's like the
think.
gorilla thing. Yeah. I mean, how many? I would guess it's got to be.
I mean, I think at
Maybe-
least 5.
I would say
probably.
three people's where I put
3?
my line over 3. I don't know. What are you thinking, Sebastian?
I'm thinking a little bit more than that. I know that our robot is around 250 pounds of force that it can pull.
Yeah, that it can pull. Okay, so that's at least one person. But if you dig in, I mean,
Yeah.
So I think 2, 3. I don't know. We'll try.
Depends if we're full.
Yeah, true.
Oh yeah, that's another
Yep.
thing. Yeah.
Yeah,
Adding,
that's-
adding mass to these robots definitely would help with the traction force that they can get. So.
Yep. No, yeah, that's one of those design considerations that people consider is should we load up our robot with regolith to allow us to get more traction? Because you kind of sink in more and it lets you get a more surface area, more force to move. And yeah, that definitely could help you with.
All right.
All right, it looks like we're getting close here to run again. So, yeah.
2,
1. Okay. All right, so we've gotten the go. We'll have a second here, and there we go. Wow,
yeah,
look at Youngstown
Youngstown.
State again. And it looks like Illinois is digging in. Ooh, maybe they're doing a little pullback. We got Youngstown State digging into the sand there. It looks like this may end up in a tie. We'll see, but it doesn't look like there's much movement going on either side here. I don't know. What are you all thinking there? Anything?
I
It
think
looks
you
like
might.
they might dig themselves in.
Yeah, and in Illinois, I mean, they're doing well for being so stuck on the surface just because of the nature of the tracks, which is a benefit when you're trying to navigate the true lunar surface. But when you're trying to pull people, it might be a little bit tougher. You'd rather be sunk in a little bit more. So
I think once Illinois is allowed to move that that front scoop there, they might be able to lift
a little.
Youngstown up and and
Okay.
get them free and maybe even pull them back. We'll see.
Actually, yeah, you're right because they may be able to lift the front end of Youngstown State. Yeah,
Am
that
I
may
not
be-
allowed to move it?
At the start, you're not allowed. At the start,
Yep.
they're trying just to compare track to track, but that might be what they're saying over the radio right now.
Yep. And yeah, so that's what allowed New Mexico Tech to have some impressive performances. Is they once they're allowed, they kind of sit there and just hold their own, and then once they're allowed to move their
other systems.
Yep.
Then kind of gives them an advantage.
Yep.
Yeah, we actually one of the plans was if we got to that point, the Iowa State bot was gonna maybe try to mine a little bit, maybe get
Get a
some
little
mass
more
on the
mass in the
robot,
robot,
maybe
yeah.
even
What do you mean?
get
Yeah.
trenched down in there and start pulling. But we never got to that
no.
point. No, that
we got
was
pulled off immediately. It was
Oh,
impressive.
but there you go. It
Oh,
looks
there we
like
go.
Illinois
Yep.
is
and so now
trying
I
to
mean,
use that scoop there.
That's interesting. They're kind of dug in. I wonder, huh? I'm not sure.
Oh, maybe they might be completely stuck. Kind of dug into that lunar regolith, and
I'm guessing we're gonna end in a tie here unless if something major happens, which is, yeah. Oh, it looks like Youngstown State's moving again. Yeah.
I can't really see how they're gonna get out of this. I think
No,
it might be a tie.
yeah, we'll see, but we've got a pretty long cable between them as well, meaning any
I
angular
don't even know
difference.
if the University of Illinois can even like tip over.
No, they might.
with
You're right.
the-
With
the scoop.
the scoop, they may not be capable of tipping. Yeah.
Looks like they're pretty stuck in there.
Pretty low center of gravity relative to the pulling point. You're right.
Mhm.
Yeah, that's interesting.
Oh.
Yeah, I think we're kind of in a stalemate here. We may get another rock paper scissors match in the lightweight category for the final, which would be kind of fun. Yep.
They might be calling it right now.
All right, sounds like it. Perfect. So yeah, it looks like, I don't know, we're still moving here. So maybe, all right, we've got 30 more seconds on the clock is what it sounds like. I haven't seen any indication of any other movement here, but we'll see. This is exciting stuff.
Yeah,
Very,
exactly.
very,
A lot of wheel spinning.
I'm actually assuming, I think that maybe ESPN will put this on their like
Oh my
top
God,
10 for the day.
that'd be
It could be
great.
this moment right now, I think.
This
I don't know.
moment?
Yeah.
Not the
well,
one when it flipped over?
No, this is good.
This
I
is
like
the best
this.
one?
Yeah, far more exciting.
Track for track.
No, I mean, if you look, Youngstown State's so dug in that they actually almost are bottomed out, it looks like.
I think that's that's
That
kind
might
of a
be-
theme with the beginning runs. I think I saw like a lot of them started digging,
Mhm.
and then they just kind of have their belly on the ground, and they can't get
Yeah.
any more traction than that, and
Yeah.
can't get pulled out either. So
Yep, and we saw that when Minnesota was doing their run earlier today. They got stuck up on a rock and kind of got stuck, so they actually had to trench out the ground underneath them to
Yep.
get traction and move again, and they successfully got out. But all right, looks like we've called it. They're
Well,
doing
they're doing a
their reset. Okay, so it sounds like we're doing a reset to give it another try. I can't imagine there wasn't any indication of anyone really going to have an advantage here, but we'll see. It's good fun, and we've got the time, so
Sure.
yeah.
Yeah, who knows? I wonder if they're going to move them from underneath where they were, because if they don't come back then they'll
Yeah.
just
They'll just do
dig
the
it-
exact same. Yeah, they'll
just
fall into
dig
the same
back in.
space. Yeah.
We'll see.
Yep.
We'll see. It's funny though because
yeah.
they're so flat that they're almost like parallel with the ground.
at this point, yeah, you're
They
right.
just dug themselves in.
You're right. Illinois kind of lost that I don't know advantage or disadvantage of having that higher kind of anchor point on
Yeah.
the toe there.
Well, and I think. Sorry, I was just looking there. I think that the length of the cable, we didn't regulate that. And if you
Mhm.
had, actually, you might get an advantage from the higher mounting point, depending on it.
Yeah, you get pulled
Um,
up and then you lose traction there.
Right,
so.
which is I think similar to that's what we saw on the Lance 1.5, our Cardinal space bending robot. Is in ours we just got pulled up and just got absolutely swept off our feet. So yeah. All right, it looks like we're filling in the holes there and maybe getting ready to go. It's interesting that how little regolith that the Illinois Robotics and Space robot is moving in terms of digging out.
Yeah.
Which is similar to what we saw with our track system as well. Tracks just seem to dig in less, which can
Which
be
makes
an
sense.
advantage.
It makes
and-
sense with the with the higher surface area. You're kind of right on top of that regolith, which again could make it easier to turn. You're not digging yourself in as much. So
yeah,
that's kind of the advantage of.
But
of
for
those
something like
tracks.
straight line, you're gonna lose that
Mhm.
torque, that power, that friction.
Mm-hmm.
So yeah, this is interesting. I wonder if they're gonna redraw that line for us. It's a little hard to see, but hopefully we should be good.
Yeah, I just want to give some insight on our ISU run earlier. It kind of looked like at the end we kind of spun out,
Mhm.
and initially we thought that it was one of the motors
Mhm.
might have gone out, but actually our I talked to our driver, and he confirmed that he saw that we were kind of losing at the end,
And he
so
tried to
he
twist
just trying
us.
to twist, do
Yep.
something, and yeah, that's what kind of
Gotcha.
ended our run there.
It
but
looked cool.
It looked very cool. Yeah, it
But
was very
no,
dramatic.
Yeah, I mean, it was almost immediate that we started, getting
Pulled
pulled
back.
across the side there. So,
If we would have flipped over, that would have been bad.
oh yeah, if ours flipped over, it's a big robot to flip back. That's for sure.
It's so clunky.
Have we heard how is the Razorbot spot? Is it okay? Is there any
No
massive
update on
damage?
that.
Or, okay, we haven't had an update on that. Well, hopefully we'll check on that, and I think they should be all right. It seemed to just be a couple loose wires, but hoping. I think they had a camera on that top side, so hopefully that's all right for them. But usually cameras are pretty sturdy, so
Looks like they are
tamping
tamping
it down. Yeah.
Trying to get it back to being compact, so that's good.
Stomping on it.
Yeah, that was one of the interesting things. We were expecting to have to tamp it down more for our competition, because that's what you have to do with certain lunar simulants, lunar regolith simulants. But because of the nature of ag lime, it actually tends to make itself more dense than lunar soil or lunar regolith, and so it meant that we were benefiting from going around and scooping up and like loosening up a lot of the ground underneath the robots to allow better mining, and that's one of those things that that once you learn that, it makes a lot more sense. And it's interesting because it differs from NASA's BP-1 that they run on at the Kennedy Space Center.
Well, it flows a lot more, and that's something we looked at as well. Between our two runs, is we were expecting a lot more aeration from the soil when we were mining and we were depositing, but didn't really see that when we were dumping. So we decided to get rid of our skirt in the back, which kind of saved on some weight and kind of complexity. We didn't want that to get lost in there. So
Yeah, and that's one of the some of our design decisions in our robot at least has been how can we avoid scattering enough dust around to lose a lot of that mass and a lot of that volume that we're scored on. And then also for safe dust mitigation, which we weren't scoring at this competition, but has been scored in previous competitions. All right, so it looks like people are, we got one more door open, someone looking back through, but people have left the arena here, and so hopefully we're going to be within a minute or two of starting, and maybe we'll get a different result this time. I'm excited to see.
yeah, it looks like Illinois might have spun their tracks to see if they're connected.
All right, yeah, maybe tension the line as well. So
Yeah.
all right,
there we
3,
go.
2, 1, we're going here. Let's see. Oh my goodness, look at that dig. Quick, look, moved them a couple inches, but then they're stuck in on the ground there, it looks like. I think we're gonna get the same results
I
here
think we're
from
gonna might see the same thing here.
So we may either go to I don't know what we'll go to after this. So
YSU really gets
they sink in a lot. I mean, it's a great tactic for this because it'd be hard to pull them no matter what.
Yeah.
You'd struggle if you tied your F-150 up to it to really get them pulled.
I think we might have to go to the rock paper scissors.
Oh, wait a minute.
I changed
Wait.
it.
Oh,
that's
they're driving
okay.
forward to give it a. Oh wow.
Okay.
We may
Yeah.
snap our line here with that. I like it, but that's
it looks like
Illinois
might
trying the
be-
same thing?
Yeah, might be a
think
copy
they're
that
gonna
strategy.
fight for it,
No.
this is interesting.
I wonder if they might be they might spin at some point. Maybe try to
Yeah, what's
spin them
interesting
around
actually
at a
is
different angle.
looking at Illinois, they seem to be tilted back slightly, and I think they may be digging the back end of their tracks, maybe digging in slightly.
Oh, maybe, yeah.
Which is just gonna make it even harder for Youngstown State to pull them out. So that's interesting. I
Illinois
don't know.
not even moving their tracks. They're really
No, they're just sitting
they're
there.
just sitting
I
on
think
there.
they've resigned themselves to a tie here. Maybe it
Yeah,
looks like.
maybe. You might be right.
We'll have to see if we go to rock paper scissors or if they decide on another form of decision making.
Yep.
So
It's okay though. Illinois has a smiley face on it.
That's right. That,
yeah,
that might be
happiest
extra
robot here.
points.
Yeah. Yep. I was hoping they put I already said this, but I was hoping they put the angry focused eyebrows on it for this,
Oh,
but
for this, yeah, so
but
it
they-
gives them extra points.
they just said we're just happy to be here, which is awesome.
Oh, they're gonna rock paper scissors here.
Oh, okay.
Right in front of us.
Right,
in
live.
our
So we're doing
steppatory, so we're gonna get
a
it
close, a close rock paper scissors. So, oh,
we got Mason on the
Mason
cab.
just straight up in the camera. That's awesome. Smile.
What?
Okay.
All right, so we are scooting out of the way from our table here, and we are going to have Illinois versus Youngstown State do a live rock paper scissors match to see who the winner is. So yeah, we'll scoot out of the way here for you all.
Here's our representative from Illinois.
You want to introduce yourself to the crowd at home?
My name is Rama. I'm a junior in computer science, and I've been on Illinois Robotics and Space for 2 years. Next year, I'll be vice president. This year, I am the autonomous lead.
Awesome. Welcome. And then if you'd like to introduce yourself here.
Okay. Hello, I'm Bryce Leach from YSU. And we're going to play rock, paper, scissors.
Let's go.
Stalemate.
Best of luck.
Sure.
Best of 3? All right. Ready? Rock, paper, scissors, shoot. Okay. Rock, paper, scissors, shoot. Rock, paper, scissors, shoot. All right, that's one. Rock, paper, scissors, shoot. Rock, paper, scissors, shoot. Rock, paper, scissors, shoot.
Oh.
Rock, paper, scissors, shoot.
Rock, paper, scissors, shoot.
Rock, paper, scissors, shoot.
Oh.
All right. Well, that will conclude our rock paper scissors match for the lightweight thing, and it appears that Youngstown State takes that. So congratulations to Youngstown State for the tug of war win with the lightweight category.
Very good showing from both robots.
Yep.
Congrats to both.
They had a lot of ties there.
Yeah, that was a lot.
Robots.
Yeah, you're right. Yeah, they had to run it a couple times there, so that was exciting. We'll see. It looks like we're just going to go through and clean up the robots here, get some of that regolith simulant off, and then they'll go back and double check everything's good to go, and
then we'll
pack
get
it
one
up.
more run, right? Or no?
No, I
this is
think that was it. I think we're packing it up here.
Very
So.
good.
Oh, nice.
All right. Hello, everybody. It's me with Sebastian. I'm Vice President of Cardinal Space Mining, Tim McEwen, and Sebastian Perez, President of Cardinal Space Mining.
That's right. Hello, guys. We just wanted to kind of sign off here and thank all our sponsors, and we're going to go through them. SICK, thank you to SICK, thank you to Danfoss, thank you to Iowa Space Grant Consortium, thank you to Caterpillar, thank you to Mechdyne, and thank you to Collins Aerospace for sponsoring this and kind of assisting us in building this great competition, and hosting all these teams and advancing great engineering here at Iowa State's campus.
Yep. Yeah. No, we really want to thank you, thank all of our sponsors for making this possible, and letting letting our team and the other teams that were able to come and visit really demonstrate what we're capable of, and have a competition to show off our engineering and communicate with each other. That was what was really fun about this competition, at least on my end. It was fun to see the ideas of the other schools and to learn from them, and to communicate with the other engineers, which was exciting. And then also thank you to all of the schools that came. It was really exciting to have 11 schools on our campus to show around our amazing facilities here at Iowa State, and to really be able to show off what Lunabotics is about to some of the newer teams. We've been around a while, and then also to learn from them. I mean, they all have a lot of great, valuable new insight, and it was really exciting to be able to do that. And a lot of long hours went into this. So thank you to Jacob Mosher, Anna Overman, Hannah Albrecht, our planner from Conference Planning and Management. Thank you, Jim Heisey, for doing the commentating and allowing us to do this as a club, our faculty advisor. Connor for doing our live stream. Thank you very much.
Producer,
Yep,
yes.
our producer for this whole live stream. So thank you very much. Brady for doing the networking, and then everyone who's worked in the arena. We know that's a lot of work, and so we really do appreciate that, the amount of effort that's gone into that. And then also thank you to Iowa State University for allowing us to use their facilities, and being accommodating, and making it a success and event. So thank you all. Anything you want to add?
No, that's great. Thank you to everybody who supported us. Thank you to all our members, and thank you to all the teams that came and visited Iowa State's campus and competed here. And no, we had a lot of fun.
Yeah. So, and we hope the Robo games were a fun little change of pace. But thank you, everybody, and we're signing off.